Hello and welcome. My name is Kevin Kemmer. I'll be your instructor for today's topic of economics. Before we get into our coverage today, what I'd like to talk to you about for just a minute or two is some key factors that will help you in succeeding in passing the CPA exam. One of the most important things that you'll need in preparing for the CPA exam is a good plan. So I hope you've thought it out about how much you're going to study and how long you're going to study, when you're going to study, and that you've really thought it out about how much you have to study. One of the things that I find when candidates are not passing the exam is they didn't put in the time that they need to. Now, as part of that time in studying, preparing for the exam, one really critical factor, in my opinion, is doing a lot of questions. You can do a lot of reading in textbooks and you could watch videos. You can go to all kinds of sources for help. But in the end, on the CPA exam, you are answering questions. And so you need to get used to answering questions. You see, when you read something, for example, you're a little bit passive. It's not really coming out of you or through your mind. It's more of a recognition kind of thing. You're seeing it on paper. But when you're doing questions, you are actively involved in that. And you can learn things by doing other questions and lots of questions. You can see the curves that can be thrown into problems. You can learn to identify what items are irrelevant to the question. I mean, it's just an incredible amount of advantages from actually doing questions. And I don't think that barely any candidates can really pass the CPA exam without doing questions. So if I had just one major piece of advice for you, it would be to do as many questions as you can. And I tell my CPA review students, you ought to do them, then you go around and you do them again and again. And in particular, when you miss a question, you check that answer and see why you missed it. And when you do that, I know it hurts some people's egos or feelings when they get a question wrong. But when you recognize what you did wrong and realize the correct answer, that's a learning opportunity for you. So do a lot of questions and experience a little bit of pain, but then you get that gain of experience, that gain of knowledge, and it'll help you in your efforts on the exam. Well, with that, let's get into our material. Let's start with the definition of economics. Now, economics is the study of the allocation of scarce resources among alternatives. Again, economics is a study of the allocation of scarce resources among alternatives. And as you can see from that definition, resources are scarce. That's a great big assumption here in economics, is that resources are limited. Another assumption that we tend to make in economics is that we have unlimited desires in consuming those resources. So we have a problem. There's a limited amount of resources to go around. Everybody wants it. How do we allocate those resources? Well, typically we can talk about two major fields in economics. We talk about microeconomics and macroeconomics. And what I'd like to start with is microeconomics. Now, microeconomics, and you think of the word microscope, you're looking at really small stuff. And that's what microeconomics does, is it looks at the small stuff. It looks down to the details. Microeconomics deals with the economic decisions of individuals, the buyers, the consumers, and the firms. These are the sellers, in pursuit of maximizing satisfaction. Again, microeconomics deals with the economic decisions of individuals and firms in pursuit of maximizing satisfaction. Now, in microeconomics, the first area we need to really get into is the law of demand. Now, the quantity purchased of a good or service is inversely related to the price, all other things being equal. That's the law of demand. The quantity purchased of a good or service is inversely related to the price. In other words, if prices go up, then demand goes down. And if prices go down, then demand is going to go up. It's going to increase. Now, what could influence demand. We have several factors that could affect demand that you need to be aware of. The first is closely related goods. Closely related goods can influence demand. And when we talk about closely related goods, what we're going to talk about later, we'll give it a name, cross-elasticity of demand. But for right now, we'll just think of closely related goods. Now, the more closely that two goods are related, then the greater the influence on the change in demand of the other product is going to be. Again, the more closely the two are related, then when you have a change in demand of one product, it's going to have even a greater influence, okay, as opposed to when they're not so closely related. The more closely related they are, the greater the influence. Now, one kind of closely related good is referred to as substitute goods. It's just like it sounds, we're able to substitute one good for another good. For example, margarine and butter. How about mayonnaise and Cool Whip? How about movies at the theater versus movie rentals? Chicken and turkey. Okay, these are substitute goods. If for some reason the price of margarine goes up, maybe I'll decide to buy butter because it's a substitute. Or if mayonnaise gets too expensive, I might buy a Cool Whip. Okay, so with substitutes, when the price of one good goes up, the demand for that product tends to decrease as consumers like us turn around and purchase the substitute good. Again, when the price of one good goes up, demand for the product tends to decrease. And that's because we're turning around and buying the substitute good. Other closely related goods are known as complements. The complements are closely related goods. These are goods that tend to go together, like hot dogs and hot dog buns. You know, who can eat a hot dog without it being on a hot dog bun? I hope you don't like to eat hot dogs on just bread. Okay, I got to have a hot dog bun. Peanut butter and jelly. You know, I have no reason to just have a jelly sandwich. I'm going to make sure I have peanut butter to go with it. Cameras and rolls of film go together. Razor and razor blades. And one of my favorites, surf and turf. It's nothing like some good prime rib and lobster. Now, when we talk about complements, when the price of one of the goods goes up, the demand for that product, as well as its complement, is going to decrease. Okay? When the price of one of the goods goes up, the demand for that product and its complement is going to go up. You know, if the price of New Zealand lobster goes from, say, $25 to $50, then the next time I go out to eat, I'm not going to buy that lobster, and I'm also not going to buy that prime rib together. Okay? Not going to get that surf and turf. Other factors can also affect the demand for goods. For example, income. As personal income increases, the demand for normal goods will also increase. Okay? Let me say that again. As personal income increases, the demand for normal goods are going to increase. When I talk about normal goods, I'm talking about things like steaks and airline tickets, brand new Armani suits. Okay? As our income increases, we're going to buy more of those items. On the other hand, some goods are inferior goods. For example, potatoes. A lot of times as personal income increases, the demand for potatoes tends to go down. Another example of an inferior good might be, how about public transportation? As your income increases, the demand to ride the bus is going to go down because more people will be buying cars. Same is true about clothing. You know, instead of an Armani suit, how about used clothing? As personal income increases, the demand for used clothing is going to decrease. That's because it's considered an inferior good. Another factor that affects demand for goods is future price expectations. If consumers expect future prices to be higher, consumers expect future prices to be higher, what's going to happen to the demand? Well, current demand is going to increase. And the reason being is because they don't want to pay those higher prices in the future. They'd rather go ahead and buy the goods or services now and enjoy them at the lower price instead of paying the higher price later. So future price expectations, if we have increases expected in the future, demand will increase now. On the other hand, if consumers expect for prices to go down in the future, then demand is going to decrease. They're going to defer their purchases. They're going to wait until the prices go down. Other factors also affecting demand would include things like consumer preferences, market size, and group actions like boycotts. For example, with consumer preferences, sometimes consumers are more interested in, let's say, the girls want to buy miniskirts. Well, then the fad sort of changes. People aren't buying miniskirts anymore. So consumer preferences change over time. During one period of time, demand might be higher. Another period of time, demand might be lower. Market size also affects demand. Typically, if population is growing, most of the time demand also grows. Okay. Things like boycotts, well, that's going to eliminate demand completely, because when people boycott, they're not going to buy any of the products. Now, what I'd like to do at this time is to look at a graph of a demand curve for video conferencing time. If you were to look in your viewer's guide, you'll find that graph. And I wanted to go over this at this point because I want to make sure that you're comfortable in looking at graphs. A lot of times in economics, we use graphs. And some people, when they're in school, were a little bit confused or intimidated by them. And I don't want any of my students to be intimidated by these graphs because they're really not that difficult. If you look at that graph in your viewer's guide labeled demand curve for video conferencing time, I want you to notice that there's a vertical line on the left part of the graph and a horizontal line going across on the bottom. The vertical line is also known as your y-axis. Typically, what we put on the y-axis in economics is a price. And so here we have the prices for video conferencing time. Up at the top, you see $1.90, $1.80 going on down. On the y-axis, the horizontal line there at the bottom, where it goes 0, 1, 2, 3, 4, that's the quantity of goods. And here for the video conferencing time, I have that in thousands of hours. Now, the curve that you see in the graph there is obviously a demand curve. And one of the things I'd like to point out right away about this demand curve is that you're going to notice this demand curve is downward sloping. So you can remember the D in demand stands for downward sloping. I remember as a student, I used to always get confused between demand and supply, and it's really pretty easy when you use a little technique like that. D for demand, downward sloping. Now, if you look at the y-axis, you'll notice that I have two lines drawn from the y-axis over to the demand curve. If you look at the price of $1.50, you can follow that line over, the horizontal line, from $1.50 over to the demand curve. And then where that intersects the demand curve, I have a line going down to the x-axis to indicate the quantity. And what that says is that at a price of $1.50, consumers demand approximately 4,000 hours of video conferencing time. Now, we can go down or along this demand curve, and what it will do is represent the changes in demand due to changes in prices. So the other line that I have goes from the price of $1.30 over to the demand curve. And you follow that over and then follow the horizontal line from the demand curve, from $1.30 over to the demand curve, and then follow the vertical line down to the x-axis where quantity is. And you'll notice that at $1.30, consumers are demanding 6,000 hours. So what we can say here is that if the price goes from $1.50 to $1.30, demand, what consumers demand, they would go from 4,000 hours demanded to 6,000 hours. And that goes along with what we said about the law of demand, that demand is inversely related to price. As price goes down, demand goes up. As price goes up, demand will go down. Let's look at the next graph in your viewer's guide. This is also demand curves for video conferencing time, but instead of just having one curve on here, I have three. And they're labeled D, D sub 1, and D sub 2. Let's start with the line labeled D. Okay, the demand curve labeled D, I have a line going over there from the price of $1.45 over to the demand curve and down to 5,000 hours, that would be the demand at the price of $1.50 on the demand curve. Well, D sub 1 is an entirely separate demand curve. In other words, at $1.45, if you follow the horizontal line, demand under D sub 1 is 7,000 hours. Now, why would in one curve there be demand for 5,000 hours, and another demand curve there be a demand for 7,000 hours, all at the same price? Well, what's happened here is that a factor has occurred that has caused an increase in demand from the 5 to 7,000. So we have a complete shifting from the left to the right of the demand curve. Some of the things that might cause that shift in demand to the right would include things like an increase in the price of a substitute. Let's just assume that airline tickets would be a substitute for video conferencing time, because if people are using video conferencing, they're wanting to meet their customers or clients face-to-face, and that's why they're using video conferencing. And they might use that because they don't want to fly. It's too expensive to fly. Well, if there's an increase in the price of a substitute, if airline tickets go up, then companies will be less inclined to send their employees to meet the clients face-to-face, and they would rather use video conferencing. And that would cause an increase in the demand for video conferencing time. Another potential explanation for a shift to the right would be a decrease in the price of complements. A decrease in the price of complements. If there's something that went along with this, I have trouble thinking about that for video conferencing. So let me go back to my surf and turf example. If this were actually a demand curves for prime rib, and the price of lobster decreased, okay? If the price of lobster decreased, that's going to result in an increase in the demand for lobster and an increase in demand for prime rib. And so the line is going to shift, or the demand curve is going to shift to the right. Also, if we had an increase in consumer income, the more income consumers have, the more they'll tend to spend on an item. So we'd have an increase also to the right. In contrast, we could have gone from the demand curve D to the demand curve D sub 2. And here what we have is a shift to the left, or a decrease in demand. And a decrease in demand could occur for just the opposite reasons that a shift to the right occurred, an increase occurred. The opposite, for example, a decrease in the price of a substitute would result in a shift to the left. An increase in the price of a complement would cause a shift to the left, or a decrease in demand. And a decrease in consumer income would also cause a shift to the left, or a decrease in income. What I'd like to talk about now is talk about supply. Supply is the quantity of a good or service that sellers are prepared to sell at a given price at a given point in time. Again, supply simply represents the quantity of good or a service that sellers are prepared to sell at a given price at a given point in time. And the law of supply says that the quantity of a good or service sold is directly related to the price, all other things being equal. Again, the quantity of a good or service sold is directly related to the price, all other things being equal. And what that means is that when the price goes up, supply is going to increase. And when the price goes down, supply is going to decrease. And you stop and think about it. We said all other things being equal. If the price of a good goes up, and all other things are being equal, including the cost to produce that good, aren't the companies that produce the good going to want to sell more since it's at a higher price and it has higher profit margin? Absolutely. And that's why when the price goes up, the supply increases. When the price goes down, the supply is going to decrease. Now, there are several factors that can affect the amount of supply. The first we'll talk about is production costs. If production costs were going to increase, for example, let's say that there are taxes that are now enacted They're slapped on video conferencing time. What is the effect of taxes on our video conferencing time going to have on our supply? Well, what's going to end up happening is, all other things being equal, with the production cost being higher, there's going to be a decrease in supply. Why? Because if the price hasn't changed, remember, all other things being equal, if the price has not changed, and there's an increase in the cost to produce that product, then the profit margin is going to be less. And so there's going to be less reason or less incentive for the company to supply that. So they'll decrease the supply of the goods. Conversely, any decreases in production costs due to things like lower wages to our employees, lower supply costs, maybe subsidies, all of these things would result in a reduction in our production costs. And if you keep everything equal, including the price, then that's going to result in higher profit margins for the company. And they're going to be willing to supply more at a higher profit margin. So any decreases in costs are going to result in an increase in supply. Technology also affects supply. If we experience technological improvements in the production, then that will result in an increase in supply. Because typically the technology improvements is going to decrease the cost, or we're going to be able to produce more for the same cost overall, so the average cost of production is going to go down. And that's going to increase profit margins. So the company is going to be willing to supply more. A third factor affecting supply is the prices of other goods. Let's say that both goods X and Y are made with the same inputs, the same materials, but the price of Y has gone up. Now, if the price of Y goes up, then producers are going to want to produce more of Y, because as long as the costs haven't changed, but the price of Y goes up, higher profit margins. And the less of good X that they're going to produce, because if the price of the materials have not changed, then the supplier will make a higher profit margin on Y. So the prices of other goods, as those prices change, could impact what the supplier is going to produce. A fourth factor affecting supply would be price expectations. An anticipated increase in the price of a good will cause a firm to supply less now and more later when that anticipated price increase arrives. Again, because they can sell it later at a higher profit margin if they're anticipating a price increase. So price expectations affect supply. If you'll go back to your viewer's guide, I'd like for you to look at another graph. I have a graph in there that's titled Supply Curves for Video Conferencing Time, and it has 3 supply curves. And you'll notice right away that in that graph that the supply curves are all upward sloping. Okay? They're all upward sloping, which pretty much reflects the fact that for supply, when the price goes up, suppliers are willing to supply more. So I sort of remember the supply is an upward sloping because of the UP in supply and the UP in upward. So demand is downward sloping, the supply curve is upward sloping. Now, let's look at the middle curve here, the one that's just labeled S. At a price of $1.45 per hour, suppliers are willing to supply 7,000 hours of video conferencing time. Again, all I have to do is follow the line going from $1.45 on the y-axis until it intersects the S demand curve, and then follow the intersection going down to the x-axis. And we follow that line down, we come to 7,000 hours. Okay. Well, what happens if we go from S to, say, S2? Why would there be a change here? Again, I want to point out, we're not moving up and down the same curve. What's happening here is you go from S to S2, you're experiencing an increase in supply. Why? We'll follow that $1.45 line over until it reaches S2. And then you go down to the x-axis, and you'll see that at $1.45 on the S2 supply curve, suppliers are willing to supply 9,000 hours, as opposed to the 7,000 hours they were willing to supply for the demand curve just labeled S. So what would cause that increase in supply from 7,000 to 9,000 hours? Well, one reason might be a decrease in production costs. If the company is able to produce those video conferencing hours for a cheaper price, whether it's due to an improvement in technology or some other production cost, then they're willing to supply more because they now have a higher profit margin. Again, we're holding everything else equal. The price being equal, we have a lower production cost. That's going to be a higher profit margin. Suppliers will be willing to supply more. Another reason why there might be a shift from the S demand curve to S sub 2, an example would be a decrease in the price of other goods. If other goods decrease in price, then the profit margin is not as good, and so it'll shift. What about shifting from S to S1? What's happening there? We have a decrease in the supply, and that could be caused because of an increase in production costs. If our costs are going up, whether it's because wage increases or just supply costs are going up, or subsidies have been discontinued, all of those would result in higher production costs. And if we have higher production costs, but the price that we sell it at doesn't change, what happens to your profit margin? It goes down. And so suppliers don't want to sell it at a lower profit margin. So they'd be willing to supply less. So there would be a shift from 7,000 hours to 5,000 hours. There's one more graph that I'd like for you to take a look at, and I've titled it Demand, Supply, and Market Price for Video Conferencing Time. And what I've done here is I put both a demand curve and a supply curve on this graph. And this is important to us because when we put the demand curve and the supply curve on a graph, we'll be able to determine what the equilibrium point is. In a free market, what is the quantity of goods that will be supplied and at what price? And so what we would do is find the intersection of the demand curve and the S curve there, the demand curve and the supply curve. And I've labeled that point E. And I've drawn a line, a horizontal line, over to the y-axis so you can see what the price is, $1.30. And I've drawn a vertical line down to the x-axis to 6. And you see that at a price of $1.30 per hour, suppliers and buyers, they'll have an equilibrium exchange of 6,000 video conferencing hours. What I'd like to talk about now is the concept of elasticity. Now, elasticity is the measure of the sensitivity or the responsiveness of quantity demanded or supplied to a change in a determinant of that demand or supply. The reason why I say demand or supply is because there are different measures of elasticity. And the first one that I'd like to talk about is the price elasticity of demand. So if we're talking about the price elasticity of demand, we're talking about measuring the sensitivity or responsiveness of quantity demanded to a change in the price of the good. Again, the price elasticity of demand is a measure of the responsiveness of the quantity demanded to a change in price. So if prices change, how does the demand change? Well, there's a couple of approaches that we can determine how elastic the demand is. And the first way that we could go about it is by using a formula approach. Now, the measure of sensitivity or responsiveness of quantity demanded, and using a formula, what we have to do is we have to look at the responsiveness of the change in demand, and that's going to be one measure, and then we're going to divide that by the percentage change in price, which is in the denominator, and then put those two together. So it's a sort of a large formula, and we actually have two different formulas, or two different methods of approaching the formula for the price elasticity of demand. So let's begin with the simple method. And just like it sounds, it's simple, it's easier. What you're looking at is the responsiveness of quantity demanded, the percentage change in demand. We're going to take the demand after the price change, subtract out the demand before the price change, and divide it by your starting point, the demand before the price change. And so that gives you the percentage change in demand. That will be your numerator for the price elasticity of demand. Then in your denominator, you're going to look at the percentage change in price. So prices are going to change from P1 to P2. You're going to look at the change in price. That will be P2 minus P sub 1, or P1. And then you'll divide that difference by the original price, the starting price. So it's very simple in that in your little calculations, the little denominators, if you will, are just the starting points. So when you look at the percentage change in demand, you're using the original demand. When you look at the change in price, the percentage change in price, you're looking at the original price. And one thing that I need to comment on here in computing the price elasticity of demand is that we use absolute values. So if price goes down, say from $1 to 75 cents, you actually have a decrease in price. And when you take that change in price, it'll be minus 0.25. Well, for price elasticity of demand, we'll take the absolute value and instead just use 0.25 instead of using the minus 0.25. Well, let's look at an example using this simple formula. Let's assume that we have a hot dog vendor. And every day at the rush lunch hour, the hot dog vendor sells his hot dogs for $1 per hot dog, $1 per hot dog. And in the normal lunch hour, when he has that price of $1, the vendor is able to sell 100 hot dogs. Let's say that the supplier, the vendor, wants to change the price and see what happens to demand. And the vendor decides to reduce the price to 75 cents per hot dog. And when the vendor changes the price of the hot dogs to 75 cents, it results in 150 hot dogs being sold. Well, let's compute the price elasticity of demand for the hot dogs using the simple formula. Now, again, the simple formula is the percentage change in demand divided by the percentage change in price. So let's do our percentage change in demand first. The demand originally was 100, it went up to 150. So to get the change, we take the 150 after the price change, subtract out the starting point of 100. So 150 minus 100 will give you 50. And then we have to divide that by what? Our starting point. Simple formula using just that one starting point. And the starting demand was 100. So we've got a 50 unit change divided by 100. That's 50%. Now let's do the denominator. That's looking at the percentage change in price. Price went from $1 to 75 cents. So we're going to take P2, the price after the change. That was 75 cents. Subtract the starting price of $1, P1, and you're going to get minus 0.25. Again, we're going to use the absolute value. So make sure you just use 25 cents here. And then in the denominator, we're going to divide that by the starting point, the original price, which was $1. So we've got 25 cents divided by $1, and that's going to give you 25%. So we've got 50% in the numerator, 25% in the denominator. The price elasticity of demand for hot dogs here is 2. Now, what that number tells us is how elastic demand is. And as a rule, when the coefficient is greater than 1, then we say that that demand is elastic. In other words, it's responsive to price changes. Well, now let's look at the computing the price elasticity of demand using the ARC method. Now, the ARC method, instead of using one starting point, in other words, the original demand or the original price, depending which part of the formula you're in, you actually want to use an average. So the formula for price elasticity of demand would be the change in demand, D2 minus D1, divided by the average demand. Well, the average demand is D1 plus D2 divided by 2. So now in the denominator for that part of our formula, we've got a lot more than just that original D1. We'll do the same thing in the percentage change in price part of the formula. We'll take P2 minus P1, and we'll divide that by the average price. In other words, P1 plus P2 divided by 2. So if we go back to our same example with the hot dog vendor. The hot dog vendor was selling 100 hot dogs in the lunch hour at $1 each, and when the vendor reduced the price to 75 cents, the demand went to 150 hot dogs. Let's fill in our numbers here for our formula using the ARC method. We're going to have 150 hot dogs minus 100, so we have a 50 hot dog increase, and we're going to divide that by the average demand. Well, the average demand, 100 plus 150 divided by 2 is 125, and that's going to give us 40% as the percentage change in demand for hot dogs, 40%. Now let's look at the denominator part of the formula. Let's look at the percentage change in price. That's going to be the new price, P2, which is 75 cents, minus the starting price, P1, which is $1. We're going to have minus 25 cents. And again, we'll take the absolute value. So we're going to have 25 cents in the numerator here for the percentage change in price. We're going to divide that by the average price. Well, we had $1 plus 75 cents. Divide that by 2. And you're going to get about 87.5 cents. So the percentage change in price comes out to be about 0.2857. Well, now we have our numerator, 40%, divided by our denominator of almost 0.29. And the price elasticity of demand using the ARC method would be 1.4. So even though we're using a different method, we still come up with a coefficient that is elastic because it's greater than 1. So again, this indicates that this demand of hot dogs is very responsive to changes in prices. Now what I'd like for you to do is to look in your viewer's guide. And I have a graph there that I've entitled Demand Curve Showing Different Elasticities. And you'll find 3 curves, actually, on this graph. One's labeled D, one's D sub 1, one's D sub 2. Let's look at the middle line here that's labeled D. And it says that it's unit elastic. Well, what is that? And how do we know? Well, demand is unitary elastic or unit elastic if the price, the coefficient is equal to exactly 1. Well, how are we going to compute that? Well, let's look at that D demand curve. You'll notice that I have a line drawn from the y-axis, which is where we have the price, and we have a price there equal to 10, and draw the line over from 10 over to the demand curve, and then down to the x-axis, and we see that it intersects at a quantity of 1,600. So at that point on the demand curve, at a price of 10, there's a demand of 1,600. Now, if we want to get the price elasticity of demand for this demand curve, we have to pick out another point that we're interested in. Well, let's say that we drop the price to $8. Again, go to the y-axis where the price is 8 and draw a line over to the D demand curve and then down to the x-axis, and you see that the quantity demanded on the curve there at the price of $8 is 2,000 units. So by dropping the price from $10 to $8, demand goes from 1,600 to 2,000. So it is responsive to the price change, and the question is how responsive is it? Now, in coming up with this graph, I've assumed that we're going to use the ARC method in computing the price elasticity. So let's compute the price elasticity using the ARC method as we change from the price of $10 to the price of $8. Well, what's our formula? We want the percentage change in demand. Well, we've got an increase of demand of 400 units, and we're going to divide that by the average demand. The average would be 1,800 because we have the 1,600 plus the 2,000 divided by 2. So we've got 400 divided by 1,800 as the percentage change in price. Let's look at the percentage change in demand, Now let's look at the percentage change in price. We went from 10 to 8. That's a decrease of 2. Of course, since we're dealing with the price elasticity of demand, we're going to use the absolute value. We're just going to worry about the difference, which is 2, not worry about that the price went down. So it's a price of 2, price change of 2. We're going to divide that by the average price. Well, 10 plus 8 divided by 2 is going to give you 9. So we have in the percentage change in price, $2 divided by $9. And 400 divided by 1,800, then divide that by 2 divided by 9, and you have 1.0. So that demand curve is indeed unit elastic using the ARC method. What about D sub 1? D sub 1 is labeled elastic demand. And elastic demand, as I mentioned previously, means that the coefficient must be greater than 0. And we can compute that. If we use the ARC method, you're going to find, and I encourage you to do that on your own, that the coefficient will be greater than 1. If you were to look at D sub 2 as the price changes from 10 to 8 and compute the coefficient of the price elasticity of demand, you're going to get a number that is less than 1. And when the coefficient is less than 1, that indicates that demand is inelastic. Now, in looking at this graph with these 3 different curves, we've come up with 3 different types of elasticity: elastic, unit elastic, and inelastic. But one of the things that I want to make you aware of is just because you look at the change from one price to another price on a demand curve, that doesn't mean that prices all along that curve are the same elasticity. In other words, D sub 1, when we looked at here, is elastic, but only from the price of 10 to 8. If you go to your viewer's guide, I have another graph, also called demand curve, showing different elasticities, and it's simply one curve. And again, if you were to compute the price elasticity of demand, as you go from the price of 10 down to the price of 5, you'll find that demand is elastic as we go through that price change. As we go through the price change of 5 down to 0, you'll find that demand is inelastic. So we can have one demand curve, and different parts of that demand curve will represent different levels of elasticity. Now, what goods tend to be elastic and what goods tend to be inelastic? I wanted to give you some example of goods that have a tendency to have a price elasticity of demand that we would consider elastic. In other words, greater than 1. Luxury items tend to be elastic. Large expenditures, durable goods, refrigerators, cars. Substitute goods tend to be elastic, and goods that have multiple uses. Again, elastic goods include luxuries, large expenditure items, durable goods, substitute goods, and multiple use items. Goods that tend to be inelastic include necessities, small expenditures, perishable goods, complementary goods, and those that have limited uses. Again, goods that tend to be inelastic include necessities, small expenditures, perishable goods, complementary goods, and those with limited uses. I have another set of graphs in your viewer's guide I'd like for you to take a look at, just to sort of give you almost all the different possibilities. If you go to the graph in your viewer's guide that's entitled 3 demand curves showing different elasticities, you'll see that it has three graphs in there. We actually have a graph A, graph B, and a graph C. Graph A simply represents a demand curve that is completely horizontal. In other words, at the same price, we would have various demands, various quantities demanded. That demand curve is perfectly elastic. In other words, there's no change in price, yet we have a great responsiveness in the quantity demanded. Graph B, you have a vertical line for a demand curve. And this demand curve is perfectly inelastic. In other words, we can change the price a lot, but it's not going to change the quantity. Demand is not responsive to changes in price. In the last example in section C there, you have a curve that represents perfectly unit elasticity. Now, another approach to determining elasticity would be using the total revenue approach. Remember, total revenue is simply price times quantity. So since in looking at elasticity, we're wondering how does demand change with changes in price, what we can do is look at the change in total revenues. And we have a number of possible situations here. If prices were to increase and total revenues were going down, demand would be said to be elastic. Remember, the coefficient is the responsiveness to the changes in demand to the changes in price. Okay? So if prices increase and total revenues go down, we're having a bigger impact on quantity than the change in price. If prices increase and total revenues remain the same, this is an example of unitary elastic. In other words, we have exactly the same percentage change in demand as we have change in price. If prices increase and total revenues go up, then demand is inelastic. Well, we've looked at three situations where price increase. How about if prices decrease? If prices decrease and total revenues go down, then demand is said to be inelastic because consumers are not responding to the change in price. The demand is not as responsive as the change in price. If prices decrease and total revenues remain the same, again, we have unitary elasticity. It's unit elastic. If prices decrease and total revenues go up, then the coefficient is going to be greater than 1. It's going to be elastic. Let's talk about some other measures of elasticity. Let's talk about the price elasticity of supply. This is the measure of the sensitivity or responsiveness of the quantity supplied to a change in the price. Again, this is the measure of the sensitivity or responsiveness of the quantity supplied to a change in the price of the good. So in our numerator, we're going to be having the percentage change in quantity supplied. That's going to be the quantity supplied after the price change minus the quantity supplied before the price change divided by either your starting supply, if you're using the simple method, or by the average supply, if you're using the ARC method. Then we would divide that by the percentage change in price. P2 minus P1 divided by either your P1 or your average price, depending again if you're using the simple method or the ARC method. Example, we might be interested in looking at how a 5% increase in the price of regular unleaded gasoline would affect the quantity supplied. So we could measure that with the price elasticity of supply and determine how elastic the quantity supplied is to changes in price. The next measure of elasticity is the cross-elasticity of demand. And what this measures is the responsiveness of the quantity demanded for a particular good relative to a change in price of a different good. In other words, our formula is the percentage change in the quantity demanded for good, let's say X, divided by the percentage change in price of good Y. We have a different good in the numerator and a different good in the denominator. For example, this would be like looking at how the price of filet mignon changes, how that price change would affect the quantity demanded for hamburger. So if filet mignon prices went up by 20%, how responsive would the quantity demanded for hamburger be? Now, one of the things I want to warn you about, here with the cross-elasticity of demand, we don't want to use absolute values. Here, we're going to come up with numbers that are either positive or negative, and we're going to use those coefficients to identify whether the goods are substitutes, complements, or unrelated. So by not using absolute values, we could come up with negative numbers. Well, if we compute this cross-elasticity of demand and the coefficient is greater than 0, we consider these goods substitutes. If the coefficient ends up being negative, then we consider these goods to be complements. And if it's exactly equal to 0, that means these goods are unrelated. The final measure of elasticity that I'd like to talk about is the income elasticity of demand. And the income elasticity of demand measures the sensitivity or the responsiveness of the quantity demanded to changes in income. So we're going to have the percentage change in quantity demanded divided by the percentage change in income. For example, let's say we have a 10% increase in income and an 8% increase in stake. Well, we have more income, we have more stake, which is what we would normally think of. Well, when we compute this coefficient, again, we're not going to use absolute values. If the coefficient ends up being greater than 0, then we know the good is a normal good. And we know before that stake is a normal good. So if we have a 10% increase in income and an 8% increase in stake, we know the coefficient is going to be positive. It's going to be greater than 0. And stake is indeed a normal good. Let's look at another example. Let's say that we had a 12% increase in income, and it resulted in a 5% decrease in potatoes. In other words, consumers are making more money, but they're buying less potatoes. Well, when we compute the coefficient for the income elasticity of demand, we're going to end up with a negative number, because remember, we're not using absolute values. And any coefficient that's less than 0 for the income elasticity of demand indicates that the good is an inferior good. Let's talk a little bit about the market. The market is the interaction between buyers and sellers of a good. So you can have a market for airline tickets. You can have a market for potatoes. And as we've discussed previously, the point at which the demand and supply curves meet is called the equilibrium point. Okay? The price at which that equilibrium point occurs is called the equilibrium price, or the market price. So you can sort of think of the market as sort of an automatic system of allocating resources. Essentially what happens is we end up allocating resources and the goods to those that are willing to pay for them. In the market, if there's a shortage of goods, we know that the market price is going to increase. And once the market increases, we know that the quantity demanded will decrease. So there's going to be a shifting here. There's going to be a moving around. And eventually that shortage will be eliminated. We'll find a new equilibrium point. Conversely, if there's a surplus, the price is going to decrease, resulting in an increase in demand, eliminating the surplus. Well, the market, as we just talked about it, is a free market. However, sometimes the market's not always so free. Governments sometimes intervene and they set mandatory or artificial prices. They can utilize price floors or price ceilings. Now, a price floor is a government-mandated minimum price that can be charged for a good or service. Again, a price floor is a government-mandated minimum price. The floor, as low as you can go is the floor, right? It's the minimum price that can be charged for a good or service. And we have a little bit of a problem if the government sets that floor above the market, or in other words, above the equilibrium point, above the market price. And if the floor is set above the market or the equilibrium price, a surplus will develop. Let's look at the figure in your viewer's guide titled Surplus of Video Conferencing Time. You look at the figure, we have demand curve and a supply curve, and I've marked the original equilibrium point. You'll notice where E is, that's the intersection of a price of $1.30 and 6,000 hours. So that was the original equilibrium price. Now, if the government comes in and mandates a floor of $1.50, now $1.50 is above that equilibrium point of $1.30. If they mandate a floor of $1.50, what's going to be the impact? Well, what I've done is I've drawn a line over from $1.50 over to both the supply and the demand curves. And if you follow that line across until it reaches the demand curve, then we can see that at a price of $1.50, the demand is only going to be 5,000 units. But how much are the suppliers willing to supply? If you follow the line from $1.50 over to the supply curve, you'll notice it intersects the supply curve where the quantity is equal to 8,000 units or 8,000 hours. So at a price of $1.50, suppliers will be willing to supply 8,000, but consumers are only demanding 5,000 hours. That's going to result in a surplus of video conferencing time of 3,000 hours. What if the government set a floor of $1.20? Well, $1.20 would be underneath the equilibrium or the market price. And therefore, that's not really going to have any impact at all because the market's already above that price. The floor is a minimum, not a maximum. That's not going to cause a problem. Well, what about price ceilings? A price ceiling is a government-mandated maximum price that can be charged for a good or service. Again, a price ceiling is a mandated maximum price that can be charged. And here we're going to run into problems if the government sets a ceiling that is below the market equilibrium. If the government sets a ceiling price that is below the market equilibrium, a shortage will develop. Again, if you would look in your viewer's guide, I have a figure titled Shortage of Video Conferencing Time. And again, we start with an equilibrium point where we have, at the price of $1.30, 6,000 hours being exchanged. Well, if the government comes in and they set a price ceiling of $1.10, which means no prices can go above that, that means the market can't be at $1.30 because $1.10 is the maximum. So if you draw a line from $1.10 over to your supply and demand curves, let's look at how that price change would influence or affect the demand and the supply. Well, the first curve it hits is the supply, so let's look at that. When that $1.10 price comes over, we intersect the supply curve, that's at about 3,500 hours. So suppliers of video conferencing time are willing to supply about 3,500 hours. But if you continue the line across from $1.10 all the way over to the demand curve, you'll notice that the quantity demanded by consumers will be equal to about 8,500 hours. So what we have here is a shortage. We have 8,500 hours being demanded. We have 3,500 being supplied. We have a shortage of 5,000 hours. Let's talk a little bit about how shifts in the supply and the demand curves interact with each other and their impact on price and output. We have a lot of different possible combinations here. I'm going to start with looking at changes in demand and holding the supply constant. If demand increases and supply is held constant, what's going to happen to the price? Well, you've got more people demanding the goods, but there's not additional supply. It's the same amount of supply. The price is going to increase. If demand decreases, however, and supply remains constant, then it's going to result in a decrease in price because suppliers aren't getting rid of all the goods that they would like to. So they're going to have to lower the price in order to reach a new equilibrium. Let's look at changes in supply, and let's hold demand constant. If we were to increase supply but hold demand constant, what would be the impact on price? Well, if you increase supply and and hold the demand constant, there's going to be a resulting decrease in price. Why? Because there's more goods out there in the market, but demand hasn't changed. In order for the people, the suppliers, to get rid of those goods, they're going to have to lower their price. If we have a decrease in supply and demand remains constant, then we're going to have to increase our price. Or they're not going to have to increase it. The price is going to increase because there's less supply. What if both increase? If supply and demand increase, we know that more goods would be demanded, more goods are available, and therefore we know output is going to increase, but we don't really know what the effect is on the market price. It really depends upon what the slope of the demand and the supply curves are. Same is true with decreasing supply and demand, in that we really don't know what the effect on the market price is going to be. If you have a decrease in supply and a decrease in demand, the only thing that we know is that the output is going to decrease. but we don't know the change in the price. Again, that's dependent upon what are the slopes of the demand and supply curves. A couple more possibilities. What if we have a decrease in income, a increase in demand, a decrease in demand, and a decrease in supply? If there's an increase in demand and a decrease in supply, it will result in an increase in the market price. Just think about it. If demand increases, if you didn't do anything to supply, that's going to increase the price. If supply decreased and you didn't do anything with demand, the price is going to increase. So the combination of the two is also going to result in an increase in market price. However, we wouldn't be able to figure out whether output is going to increase or decrease. That would be dependent upon the slopes of the curves. What if there is a decrease in demand and an increase in supply? Well, if there's a decrease in demand and you didn't change anything else, what would happen? A decrease in demand would result in a decrease in market prices. What if there's an increase in supply? If supply increases and everything was held constant, there would be a decrease in market prices. So when you combine the two, there has to be a decrease in market prices. But the effect on the quantity of output is going to be indeterminable. Welcome back. I hope you tried these. Let's go over them together. The first question says, if a law establishes a maximum price for product Y in a competitive market and the ceiling price is above the market or equilibrium price for product X, what? Let's stop and think about it before we read any of the answers. Remember, a ceiling price is a maximum price, so the price cannot go above it, and a floor would be a minimum price. Here, the ceiling price is set above the market. So what we're saying is that you can't go any higher than that ceiling. Well, the market is not higher than that ceiling, so there's not a problem, is there? So look at answer A. It says the law has no effect on the market of good Y. It's not going to have any effect because it does not cause a problem. It would cause a problem if the ceiling was below the equilibrium price. Only when the ceiling is below will there be an effect, and that would result in a shortage. Look at the second question. If the demand for cigars in Miami is relatively elastic, and Miami imposes high taxes on cigars that result in higher cigar prices, then in Miami, A, the quantity of cigars demanded would increase. No, if cigar prices go up, the demand is going to decrease. So A is not correct. B, the demand for cigars would increase. No, the demand for cigars is not going to increase. It would decrease. C, the demand curve for cigars would become vertical. In other words, that's perfectly inelastic. Why would a change in price cause the demand curve to become vertical? How about D, expenditures on cigars would fall? And that's the correct answer. If you remember when we talked about the total revenue approach to measuring elasticity, we said that when prices go up, if total revenues, or in this case expenditures, go down, then the elasticity of demand is elastic. It is elastic demand. Number 3, if the coefficient of elasticity is 2, then the consumer demand for the product is said to be what? Well, we said that when we have a coefficient that is greater than 1, then demand is elastic. And so the answer is letter B. Now, you might want to make a little bit of notes here. Letter A says unit elastic. Well, remember, that is where the coefficient is exactly equal to 1. Letter C says inelastic. Well, remember, inelasticity, or being inelastic, the coefficient would be less than 1. D says perfectly inelastic. Well, in that situation, the coefficient would be 0 because demand is constant at all prices. So again, the answer to number 3 is B. The next question says, if the average household income decreases and there is no change in the price of a normal good, and normal is important here because that's going to have the opposite effect than an inferior good, then the what? Letter A says supply curve will shift to the right. Well, when income decreases, that has no effect necessarily on supply curve. That would impact the quantity demanded. It would cause the demand curve to shift. So A is not right. B, the quantity demanded will move farther up the demand curve. But when there's an increase in income or a decrease in income, as in this case, there's a shift of the curve. It's not moving up or down the curve, but an actual shift of the curve to the left or the right. So B is not correct. C, demand will shift to the right. Well, demand will shift to the right if income increases, not decreases. Because if we had more income, we could buy more. But income here decreases. So the answer is letter D, demand curve will shift to the left. Number 5, this is an increase in the price of a complementary good will do what? Well, remember, complementary goods, they tend to move in the same direction. And if you have an increase in the price of a complementary good, then what's going to happen to the demand for that good? Well, the demand for that good is going to decrease, right? So it's also going to have an effect on the joint commodity or the complement commodity. Let's read through the answers to see what we have. Letter A says shift the demand curve of the joint commodity to the right. No, that means that we would be demanding more. Well, if the price of a complementary good has increased, we'd be demanding less. So A is not correct. B will decrease the price paid for a substitute good. No, we're talking about complementary goods, not substitutes. C, shift the supply curve of the joint commodity to the right. Okay, the supply curve to the right. Well, an increase in the price of a complementary good is not necessarily going to have a determinable impact on the supply curve. D, shift the demand curve of the joint commodity to the left. Yes, there's going to be a decrease in the demand for the complementary good, or for the complementary goods, because there's an increase in the price of one good. There'll be a decrease for that decreased demand for that good as well as its complement. Number 6, if shoes are part of the consumer's basket of goods and the consumer price index increased by 6% for the year while the price of shoes increased by 2%, then what? You know, if you don't read the whole question, you might get misled here. If you just looked at the price of shoes increasing by 2%, you might be thinking, oh, well, the prices are going up, so the demand is going to go down. Well, what you have to understand is that we are given the consumer price index, which is for a basket of all goods. And all goods went up in price by 6% in overall. But the price of shoes individually, just as a type of good, increased by only 2%. So relative to all the other goods, the price did not go up as much as the others. So in effect, that's sort of like a decrease in price. And what that really means is that now shoes are more attractive, that relatively speaking, the price is less, so the demand curve will actually shift to the right. The answer is letter C. The next question says Y and Z are substitute goods. What would cause a shift in the supply curve to the right for Y, which happens to be a normal good, not an inferior good? So what's going to cause a shift in the supply curve to the right, which means that suppliers are going to be willing to supply more at the same price? Well, they're usually going to do that, if you recall our discussion earlier. They will be willing to supply more at the same price if their costs decrease. If technology causes improvement, wages go down. And if you look at answer D, it says cost-saving technological improvements in the production process for Y. And that will cause a shift in the supply curve to the right. So the answer to number 7 is letter D. The next question says the market for product A is elastic and purely competitive. If the market price of product A increases, what is the effect on total revenue? Well, we said that if a product is elastic, if the demand for that product is elastic, using the total revenue approach, total revenues would actually decrease if the price of that product increased. So the answer is A, decreases. The next question, we have a demand schedule for Kendall Tomatoes. And apparently Kendall Tomatoes has 3 customers, Michael, Kevin, and Gabriel. And we have the demand for Kendall Tomatoes at different price levels. And it says, assuming that these 3 are the only customers of Kendall Tomatoes, which of the following sets of prices and levels of output would be on the market demand curve? Well, let's look at letter A. One set data point is $4.03 units. Well, if you go up to the table, at a price of $4, Michael's demand is 1, Kevin's is 2, and Gabriel's is 0. So the total demand is 3, so that first data point would be on the demand curve. Let's look at the second data point in letter A, $3.12. Well, if we go to the price of tomatoes when it's $3, Michael will demand 3, Kevin will demand 6, and Gabriel will demand 2. Well, 3 and 6 and 2, that's 11, not 12. So A is not the correct answer because one of those data points, the second one, does not fit on the curve. Look at letter B. Letter B says $4.10 units. Well, we already determined in letter A that at $4, the demand would be 3 units, Michael 1 and Kevin 2. So we know that in B, the first data point's wrong. So that can't be the correct answer. Let's go to letter C. Letter C, the first data point is $3.11. Well, when we analyzed letter A, that's what we came up with, the demand for $3. Again, if you go to the price of $3, Michael demands 3, Kevin demands 6, and Gabriel 2. 3 plus 6 and 2 is 11. So that data point fits. How about the second data point in letter C? $4.03. Yeah, that's the same correct one that we did in letter A. At price of $4, Michael will demand 1, and Kevin will demand 2, and Gabriel 0. So that's $4.03. Letter C is the correct answer there. So D should be wrong. Shouldn't have to go through it, but sometimes a good idea to make sure that the other answers are wrong. Let's real quick take a look at it. $2.50 and 17. Well, at $2.50, Michael demands 4, Kevin 8, and Gabriel 5. That is 17. How about the second data point? $4.10. No, we said $4.10 wasn't right. At $4, the demand is 3. So D is wrong. The answer to this question is letter C. The next question asks, an improvement in technology that in turn leads to improved worker productivity would most likely result in A, wage decreases, B, wage increases, C, a shift to the right in the supply curve and a lowering of the price of the output, or D, a shift to the left in the supply curve and a lowering of the price of the output. Well, if we have an improvement in technology that leads to improved worker productivity, we say that that results usually in lower costs and a shift to the right in the supply curve. And the only one that has that in the answer is C, a shift to the right in the supply curve and a lowering of the price of the output. Now, why would the price of the output lower? Well, because usually when you have technology increases, increased worker productivity, you're able to manufacture the units at a lower price. And so C does fit with the question here. With A and B, just because we have improved technology and improved worker productivity, that can't tell us in what direction wages might go. Okay. And D is wrong because it's a shift to the left as opposed to a shift in the right in the supply curve. The next question says, an increase in the market supply of coffee would result in A, an increase in the price of coffee. Well, if supply went up, prices normally would go down, right? So A is not right. B, decrease in the demand for coffee. Well, just because there's an increase in the supply, don't really know whether or not there would be a decrease in the demand. Why would that impact it other than an increase in the market supply of coffee would usually result in a decrease in the price of the coffee. But how does that impact the demand for coffee? How is it going to decrease it? Well, if the increase in market supply of coffee, that would result in a lower price, that would result in increased demand, right? Because as price goes down, demand is inversely related to it. And so answer D is the correct answer because quantity of coffee demanded will indeed increase because of the decrease in price. C is wrong. It says increase in the price of tea. Coffee and tea, I guess the assumption here is that they might be substitutes. If there's an increase in the market supply of coffee, there would be a lower price for coffee, which means more people would buy coffee and less people would buy tea. And if less people are buying tea, then there would be a decrease in the price. So C can't be right. It is indeed letter D. In the next question, it says, in any competitive market, an equal decrease in both demand and supply can be expected to always what? Well, if there's an increase in demand and in supply, we said that we wouldn't know what the effect would be on prices. So A, B, and C all tell you a change in prices, but we can't determine that. The only thing that we do know is that with a decrease in demand and supply, there will be a decrease in the number of units that are exchanged, and that would be C, a decrease in the market clearing quantity. Number 13, it says if a legal price floor of $5 is declared in the diagram below, what will be the result? Well, if we look at that diagram, we can see that where the demand and supply curves intersect, the equilibrium price was $3.50 and the quantity was 70,000. But if there's a law that establishes a price minimum, a price floor of $5, we need to draw a line going from $5 over, and when it connects the demand curve, you can see that demand is only going to be 60,000 units. And if you extend the line from $5 on over to the supply curve, you'll see that suppliers would be willing to supply 80,000 units. So supply is 80,000, demand is only 60,000, and therefore there's going to be a surplus of 20,000 gallons. So the answer to number 13 is A. Let's review some terms. Utility is the satisfaction derived from a good or service. This is totally a subjective kind of concept. So from a consumer's perspective, their utility might be different from another user's utility. But it's simply the amount of satisfaction that they get from buying a good or a service. Now, marginal utility is the additional utility obtained from one more unit. Now, you want to make sure that you understand this concept of marginal because we're going to use marginal, the term marginal, many times. Marginal, if you remember from like cost accounting, is similar to incremental. It's the increase. It's the difference. It's the amount from that next unit. So again, marginal utility is the additional utility, not total, but the additional utility obtained from one more unit. So if I already have 10 units of something, the marginal utility of the 11th unit is just the utility that I derive from that 11th unit. I mean, don't include any of the utility from the previous 10 units. The concept of diminishing marginal utility says that each additional unit provides less satisfaction. Again, diminishing marginal utility says that each additional unit provides less satisfaction. You know, when I go out and I get my New Zealand lobster tail, that first New Zealand lobster tail is just absolutely magnificent, and I really enjoy it. And that second one is really good too, but it's not quite as good as the first. And by the time I get to that fifth lobster tail, I'm not getting that much satisfaction from it. I'm just getting way too stuffed. I think you understand the concept of diminishing marginal utility, a little bit less satisfaction from each additional unit. Now, an individual's objective under this utility theory is to maximize their utility given that individual's income. Okay? An individual's objective under utility theory is to maximize their utility when they want to make themselves as happy as they can given their available income. Now, the objective is achieved, and this is important. The objective is achieved when the utility obtained from the last dollar spent on each commodity purchased is the same. So we're going to derive equal satisfaction from each of the last dollars that we spend on each commodity. Okay, I'll say that again. The objective is achieved. We've maximized our utility when the utility obtained from the last dollar that we've spent on each commodity purchased is the same. Now, one of the ways that we can represent this utility is through the use of something called indifference curves. Now, an indifference curve is a curve on a graph of various combinations of x and y, or whatever the two goods or services are. We'll just use x and y. It's a combination. It's the various combinations of those two goods that give equal utility. Okay, so it's a curve, and some of the characteristics of that curve, it's nonlinear. It's not a straight line. It is curved. And we have a lot of indifference curves. And all the indifference curves that an individual have are parallel to each other. So they're not going to intersect at all. Each indifference curve is negatively sloped with the convex to the origin. And then each curve represents a different level of utility. So the further to the right and up that we go represents a higher level of utility. Now, what are we going to use these indifference curves or utility curves for? Well, what we're going to try to do is eventually we're going to figure out where the utility is maximized by looking at the indifference curves, and when the highest possible indifference curve becomes tangent to the budget constraint line. Let's talk about that budget constraint line. The budget constraint line consists of all the possible combinations of two commodities, remember X and Y, that an individual can purchase given a set level of income and at given prices. Again, the budget constraint line, it consists of all the possible combinations. 0 of X, so many of Y. 1 of X, so many of Y, etc. All these possible different combinations that an individual can purchase given their level of income and at given prices for X and Y. As I mentioned a minute ago, an individual's utility is maximized where that budget constraint line is tangent to the highest possible indifference curve. Then you're going to know exactly how many X and Y you should buy based upon your income to maximize your utility. I'd like to turn now to different factors of production. You should be aware that there are 4 factors of production in economics. Land is a factor, labor is a factor, capital is a factor, and management or entrepreneurial activity is a factor. So we've got 4 factors: land, labor, capital, and management activity or entrepreneurial activity. Now, each of these factors can sort of be measured by their return or their cost. Land, the return or the cost there is rent. For labor, it's wages. For our capital, it's interest. And for management or entrepreneurial activity, it's profits. But what we're going to talk about now is various cost classifications. And it seems like there's just so many terms here, but it's really important that you have an understanding of each of these terms. And that's why I have them in the presentation. I want to make sure that you understand these and that you're prepared in case when you get to the exam, you come across questions that include these in the questions. Let's start with fixed costs. Now, remember what fixed costs are. When we talk about a cost being fixed, or variable for that matter, what we're talking about is the total amount of costs. Okay? Fixed costs are fixed because the total fixed costs remain exactly the same regardless of how much output there is, regardless of the activity. Okay? Again, total fixed costs are fixed because the amount of fixed costs don't change. The amount of fixed cost does not change as output or the quantity changes. Now, what about fixed cost per unit or average fixed costs? Well, to get average fixed cost, you would take the total fixed cost and divide it by your quantity, by your output. Now, that is going to change. It's the total fixed cost doesn't change, but the average fixed cost or the fixed cost per unit does change with output, because what you're doing is spreading the same amount of total fixed cost over a different number of units. So as we go up the x-axis, As X increases, or as Q, the quantity increases, the average fixed cost is going to decrease. We're spreading the same amount of fixed cost over an increasing quantity of units, resulting in decreasing fixed cost. As activity decreases, the fixed cost per unit is going to increase. As activity increases, that denominator gets larger and larger, the average fixed cost, is going to decrease. How about variable costs? Well, variable costs, again, are variable when we talk about the total cost of these. And the total variable cost will vary as activity changes or as output changes, as Q changes. But the average variable cost is usually constant. The average variable cost, in other words, take total variable cost and divide it by the quantity of output, and that is a constant figure. I used to really love to confuse my students and say fixed costs are fixed and variable is variable, but sometimes fixed are variable and variable are fixed. And that's because it depends if you're looking at the total or if you're looking at the per unit. Again, total fixed costs are constant, they're fixed, but the fixed cost per unit varies. Total variable costs vary, but the variable cost per unit or average variable cost vary. How about total costs? Well, total cost, of course, would be the sum of the variable cost and the fixed cost. That's all we have to do. To get total cost, we'd sum up the variable cost and the fixed. Another term you need to know is the average total cost. What you do here is take the sum of the variable and the fixed and divide it by the output. Remember, the average variable cost is constant, but the average fixed cost decreases with activity. So your average total cost is going to decrease with activity. As long as activity is increasing, your average total cost will also decrease because you're spreading those fixed costs over more and more units. Now, one way that economists look at cost is by talking about cost in the short run versus the long run. Cost in the short run, what we're assuming here is that at least one input is fixed. In other words, short run is such a short period of time that there's a cost that can't be changed. It's fixed. On the other hand, when we talk about cost in the long run, we're talking about such an extended period of time that we have enough time to vary all the inputs in such a way that all the costs are variable. So in the short run, we have variable and fixed cost. We have variable and at least one in the short run. In the long run, all costs are considered to be variable. Other ways of classifying costs. We have explicit costs. Explicit, meaning straight out, obvious. These are actual expenditures. Okay? Explicit costs are actual expenditures, as opposed to implicit costs. Now, implicit costs are not actual expenditures, but they're amounts that would have been received or paid if resources had been used for other purposes. It's sort of like an opportunity cost. It's amounts that would have been received if resources had been used for other purposes. In other words, implicit cost is because you've given up something. You used a resource for one thing, so you gave up the use of that asset, or resource for something else. Some more cost terms. Let's talk about opportunity costs. To give a good formal definition of opportunity costs. Opportunity costs are costs that are foregone by not engaging in an alternative activity. Again, it sounds very similar to those implicit costs. Okay, opportunity costs are costs foregone by not engaging in an alternative activity. Economic costs is the income an entity must provide to attract resource suppliers. The definition of economic costs is the income an entity must provide to attract resource suppliers. Well, what about economic profit? How do we determine economic profit? Not accounting profit, not accrual basis profit, but economic profit. Economic profit is equal to total revenue minus all economic costs. Remember, we gave factors of production a while ago. We said land, labor, capital. Okay, these are factors of production. Okay, so these are all economic costs. Economic profit is total revenue minus all economic costs. That's cost of land. Remember, that's rents. Labor, that's wages. Capital, that's interest. And I want to point out here the difference between economic profits and accounting profits. And the difference is that in accounting, accountants do not subtract out the cost of investors' capital. Oh yeah, we'll subtract out the cost of the land and labor, but not the cost of investors' capital. Now let's talk about more marginal concepts. I have a number of marginal concepts I want to make sure you're aware of. Again, remember, marginal is incremental. It's an increase. Let's start with marginal revenue. Marginal revenue is the revenue that's provided by selling an additional unit of product. Okay? What is the revenue from selling one more unit of product? That's marginal revenue. Marginal cost is the cost of producing one more unit. Again, it's incremental concept. It's marginal. The cost of producing an additional unit of output, one more unit. So your marginal profit is the difference between your marginal revenue and your marginal cost. We're just going to take marginal revenue minus marginal cost. How about marginal product? What's marginal product? Marginal product is additional output obtained by adding one more unit of an input. So if we added one more cook to the kitchen, how many more meals could we put out in an hour? That's the additional output obtained by adding one more unit of input. Marginal revenue product, not marginal product, but marginal revenue product. I know there's just a ton of terms here, and you're should be able to know what these are. You should be able to identify these. Marginal revenue product is the additional revenue provided by using one more unit of input. Similar to the marginal product. Marginal product was additional output. It was in terms of units, like meals. But marginal revenue product is actually revenue, additional revenue provided by using one more unit of input. Okay. Marginal resource cost. What's marginal resource cost? The marginal resource cost is the change in total cost of a resource from using one more unit of resource. So these last three terms, marginal product, marginal revenue product, marginal resource cost, we're talking about adding one more unit of input, one more unit of resources. Now, you need to be aware of the term diminishing returns. Diminishing returns are experienced when additional units of variable inputs contribute less and less to total production. So even though we're adding one more unit, we're not getting the same amount of output out of that additional unit. It's diminishing returns. We're getting less for each additional input. In other words, marginal production is declining. Diminishing returns is where marginal production, marginal product is declining as we add more and more units. Let me give you an example. If we have 100 units of input, results in an increase in output of 150. Okay. Let's try this again here. We have 100 units of input, and with those 100 units, we get out 150 units of output. But then we add one more unit, and that one more unit results in an increase that is less than the previous unit resulted in. Say 145, we're experiencing less output for each unit. Again, if we have 100 units, if the 100th unit, make sure I said this properly here, if 100th unit, just the one unit, the 100th, results in an increase of output of 150, okay, one unit of input gives us 150 output, then the next unit, if I put in a 101st unit, and that results in an increase of only 145 more units, I have diminishing returns. Okay, so you're getting less for each unit of input. A couple of sort of just overall things that you need to know, just statements that you really ought to memorize. First thing that I really want you to make sure that you have in your notes and you spend time on, in case it comes up in questions. When do we maximize profits? Well, maximization of profits occurs when marginal revenue is equal to marginal cost. Again, we will maximize profits when marginal revenue is equal to marginal cost. In other words, an increase in one more unit sold, that revenue is equal to the cost of that one more unit sold. At that point, we'll be maximizing profits. It doesn't matter what the market structure is. It doesn't matter, we haven't talked about market structure, but if it's a monopoly or a monopolistic competition, doesn't matter. We're going to maximize profits when marginal revenue is equal to marginal cost. Also, another sort of statement here that I'd like for you to make sure you know, in case you see this. A firm should demand additional resources until the marginal revenue product is equal to the marginal resource cost. Okay? You should demand additional resources until you reach the point that marginal revenue product is equal to marginal resource cost. Let's talk about long-run costs. In the long run, the cost curve, the long-run cost curve, it's U-shaped. And what that shape represents is that initially, companies experience economies of scale. In other words, the average costs are decreasing over time. Again, they're spreading out those fixed costs over more and more units. But eventually, they experience diseconomies of scale, which results in the average cost increasing. And that's what makes it a U-shape. They start out going down, and then the average costs start to increase because of diseconomies of scale. Why would economies of scale exist? 3 reasons I want you to make sure you're aware of. Increased specialization and division of labor, better use and specialization of management, and more efficient machinery. Now, diseconomies of scale tend to result from the difficulty associated with managing a large-scale entity. One last blanket statement I want to make sure that you know. It's one of these things I want you to memorize. When we talk about marginal and average cost curves, whenever the average total cost is at a minimum or a maximum, that average total cost will be equal to the marginal cost. So hopefully you can take all these blanket statements. I know it's a lot, but I ought to spend a little bit of time of memorizing these. It'll come in handy when you're answering questions and preparing for the exam. Let's talk about market structures. There are 4 major market structures that I want to spend some time talking about. The first being pure competition. And really is going to help if you understand a lot of the assumptions about pure competition. When we talk about pure competition, we have a large number of buyers and sellers. Okay, large number of buyers and sellers. And all these competitors are selling a homogeneous, or in other words, a standardized product. So all these, lots of buyers and sellers, and they're all buying and selling a standard product. And in a purely competitive environment like that, there's free entry and exit into the market. Also, we assume in pure competition that there's perfect information, that there's no price controls, no ceilings, no floors. There's no non-price competition. In other words, no advertising or brands. Now, in a pure competition, in the short run, the producer is a price taker. They take whatever price they can get for their product. And in the long run, they're not going to make any economic profits at all. Okay? In pure competition, there's no economic profits. And the allocation of the resources in pure competition is completely optimal. It's the best that they can be. And that's because the price is equal to the marginal cost. Again, here in the long run, the company's not going to make any economic profits. And the allocation of resources is considered to be optimal because price is equal to marginal cost. Now, in a pure competitive environment like this, companies are going to produce a quantity such that the average cost is at its lowest point. Okay? Production is going to occur at a quantity where the average cost is at its lowest point. And the market price is going to be equal to the marginal revenue, which is equal to the average revenue. Okay? Again, in a purely competitive market, the market price will be equal to the marginal revenue, which will be equal to the average revenue. Okay? This is the best possible situation. Resources are optimally allocated. No one's making any economic profits. And this is going to result in the largest quantity of goods of all the market structures. It's the largest quantity of goods that are going to be produced. Let's talk about pure monopoly. For example, at one point in time, telephone service in the United States used to be a monopoly. There was one seller of telephone service. And that's the first assumption of a pure monopoly, is that there's only one single seller. And that monopolist has a unique product. Also in a pure monopoly, there's blocked entry. Okay? It's hard to get in, or almost impossible to get in. There's perfect information, like we assumed in pure competition. And with a monopoly, there are significant price controls, as opposed to pure competition. Remember, in pure competition, there was no price controls. But with a pure monopoly, there are significant price controls. And we also assume that there's goodwill advertising. Remember, we said in pure competition, there is no real advertising or brand competition. Okay, so again, the assumptions for a pure monopoly: single seller, unique product, blocked entry into the marketplace, perfect information, significant price controls, and goodwill advertising. Now, to maximize profits in a pure monopoly, the producer will produce at a point where the marginal revenue is equal to the marginal cost. Remember, I said that previously. I have said that to maximize profits, this is one of the things that you ought to just memorize. To maximize profits, marginal revenue should be equal to marginal cost. At that point, profits will be maximized. Doesn't matter what structure. Profits will be maximized there. Of course, in a pure competition, there are no profits, so it's hard to maximize no profits. But in a pure monopoly, there are profits, and they're maximized where marginal revenue is equal to marginal cost. Except one condition. The marginal revenue can be equal to the marginal cost, but if the price of the product is less than the average cost, then we're going to stop production. Okay? Again, if price is less than the average cost, then we're going to stop production because we're not making any profits at all. Okay? If the price is less than the average cost. In terms of the short run, in a pure monopoly, the demand is negatively sloped, and the marginal revenue curve is less than the demand, and it's negatively sloped. In the long run, in a pure monopoly, blocked entry allows an entity to earn an economic profit. Okay, so there is economic profits in a pure monopoly. Also in a pure monopoly, the price is going to be greater than the marginal cost. Again, the price is going to be greater than the marginal cost. And this is going to result in an under-allocation of resources. Remember, in a pure competition, it was optimal allocation of resources. But in a pure monopoly, there's only one seller. Resources are going to be under-allocated. Okay. Also, in a pure monopoly, production is less than ideal. The output is less than ideal. Remember, in a pure competition kind of market, the production or the output was the maximum. It was best. It was ideal. It was optimal. Okay. Pure monopoly, it's less than ideal. Also, in a pure monopoly, the price is higher, and output, like I said, is lower than in a competitive market. Okay? The price will be higher than in pure competition, and the output is going to be lower. And the next concept that I want to talk about, the next market structure here is monopolistic competition. Now, in monopolistic competition, we assume that there are a large number of firms, and the products are differentiated. Again, there's a large number of firms, and the products are different. It's relatively easy to enter into the market. There are some price controls, and there is considerable non-price competition. In other words, brands and advertising. Again, the assumptions for monopolistic competition are a large number of firms, they're differentiated products, it's relatively easy to enter into the market, there's some price controls, and considerable non-price competition. What about profit maximization? Well, as I told you earlier, profits are maximized when marginal revenue is equal to marginal cost, unless the price is less than the average cost. We have the same exception here. If the price is less than the average cost, we're going to cease production. In terms of the short run, the demand is negatively sloped, but it's not as negatively sloped as it is in a pure monopoly. In other words, demand here in a monopolistic competition, it's more elastic than it is in a monopoly. Also here in the short run, marginal revenue is less than demand, and it's negatively sloped. Okay, so in the short run, demand is negatively sloped, less than it is in pure monopoly, and therefore demand is more elastic, and marginal revenue is less than demand is negatively sloped. What about the long run? Well, with monopolistic competition in the long run, their limited entry allows an entity to earn a normal profit, not an economic profit, but a normal profit. And in this situation, in the long run, the price will be greater than the marginal cost. So again, we have an underallocation of resources. The only time that you really have the proper or optimal allocation of resources is under pure competition. Okay? With pure monopoly, monopolistic competition, you have underallocation of resources. The production is less than ideal. Okay? The price is higher than pure competition, and the output is lower than pure competition, but they're still better than in a monopoly. In other words, the price in monopolistic competition is lower than a monopoly. The output is higher than in a monopoly. The fourth structure that I want to emphasize is oligopoly. Okay? A good example of oligopoly is airline services. In an oligopoly, you have few sellers, just a few sellers, and there are barriers to entering the market. These could be natural barriers, or they could be created barriers. And when I say natural barriers, I just mean there's a cost advantage to them. They're just better able to control those costs. By created barriers, I'm talking about things like advertising and patents. Okay? So in an oligopoly, we have few sellers, and we have some barriers to entering the market. Some of them are natural, some are created. In an oligopoly, rivals' actions are observed. Okay? They watch each other. But their products can be differentiated or standardized. Okay? They can be differentiated or standardized. Remember, with a pure monopoly, they were unique. With monopolistic competition, they were differentiated. Okay? In purely competitive environment, they were standardized. Okay? Now they can be differentiated or standardized. The one other characteristic of oligopoly that you ought to know is they have sticky prices. What does that mean? Well, there's price leadership occurring here. In other words, if one airline lowers their prices, then the other airlines also tend to lower their airline prices, ticket prices. These firms are so closely related in the competition, and that's why they're called sticky prices. Okay? They follow the leaders for the most part. Now, there's another market structure that's not as major, and it's really more specific in detail. It's a monopsony, and I just wanted to let you know what a monopsony was. Okay, and that's where one buyer exists for all sellers. Okay, usually it's because of like geographic location. There's only one buyer for all of them. You could talk about monopsonistic demand for employment, where there could be just one employer in an area, and everyone gets their job at the local Walmart or whatever that one employer is. Let's look at this group of questions together. The first question says, in the economic theory of production and cost, the short run is defined to be a production process, A, which spans a time period of less than 3 months in length, Oh, we didn't say anything about less than 3 months in length. What we did say was that in the short run, there was at least one fixed cost. Let's look at B, in which all inputs employed are variable. No, that's definition of the long run. C, that is subject to economies of scale. Well, that may be the case, that may not. It may be in the long run or not. D, in which both fixed and variable inputs are employed. Yes, with at least one fixed input, that's the definition of the short run. The next question says, all the following are true about perfect competition except that. You've got to always watch out for words like except and always and never and but. A, firms are price takers. Well, is that true about perfect competition? Yes. B, there are a large number of buyers and sellers. That's true about perfect competition. C, there's a standardized product. Yeah, we said in perfect competition, all the products are the same. They're standardized. D, in the long run, an increase in profits will have no effect on the number of firms in the market. Well, that's not true. Remember, we said in perfect competition, in the long run, there would be no real economic profits. If there's any profit at all in the short term, then there will be an increase in the number of firms in the market because they're going to want in to try to get into that profit. And eventually, in the long run, there will be no profit. So D is the exception and the answer. Next one says all of the following are characteristics of monopolistic competition except that. Okay, so 3 of these are characteristics of monopolistic competition and 1 is not. Let's start with letter D. It says price is higher than in pure competition. That's true. That's true. In pure competition, the price is the lowest. Monopolistic competition is higher. That's a true answer. That's not an exception. C, firms tend to earn normal profits. Yeah, we said that's true. In monopolistic competition, firms do earn normal profits. B, the firms tend not to recognize the reaction of competitors when determining prices. That's true. We really don't look at that. Remember, that was an oligopoly when they do look. That was sticky prices, oligopoly. But B is true of monopolistic competition. A, the firms sell a homogeneous product. No, that's pure competition where they sell a homogeneous product. Monopolistic competition, they sell a differentiated product. So the answer is A. That is the exception. The next question. An industry that is oligopolistic would be best characterized by what? A, many firms selling unique products. No, we said not oligopoly that there would be few sellers. B, a single firm selling a unique product. No, that's not correct either. It could be a differentiated or a unique product. C, significant barriers to entry. Yes, there are significant barriers to entry in an oligopoly. Okay. They could be natural or created. D, horizontal or flat demand curves for the output of individual firms. No, that's not the characteristics of an oligopoly. And the answer is C. In the next question, they're asking us about the law of diminishing returns and which of those 4 possible answers is a best description of the law of diminishing returns. Let's remember what diminishing returns are. We said that diminishing returns are experienced when additional units of variable inputs, additional units of input, contribute less and less to total production. Let's see, A, a small furnace is less efficient than a large furnace. Well, going from small to large, that is an economy of scale kind of thing. That is an increasing return. The small furnace is less efficient. The large furnace is more efficient. That's good. That's not the right answer. B, a manufacturing company purchases its supplier of materials. No, that would result in economies of scale, not diminishing returns. C, at the No Place Like Home restaurant, 4 cooks can prepare 160 meals in the evening, while 3 cooks can prepare 150 meals. Well, we don't see the difference between 2 cooks and 3 cooks. But 3 cooks can prepare 150 meals. On average, that's about 50 meals a cook. But 4 cooks can only prepare 160 meals. On average, that's 40 meals per cook. So overall, we seem to be getting less out of that fourth cook. C is an example of the law of diminishing returns. Let's look real quick at D just to make sure it's not a correct answer. John's landscaping can mow an acre in 10 minutes and 2 acres in 15 minutes. So by adding just 5 more minutes, John's landscaping is able to do twice as much, twice as many acres. Okay. For the first 10 minutes, they mowed 1 acre. And for 5 more minutes, going up to 15, they mowed an additional acre. So it took them less time to do 1 more acre than it took to do the first acre. That's economies of scale, not diminishing returns. So the answer is C. The next question reads, a corporation's net income as presented on its income statement is usually A, less than its economic profits because opportunity costs are considered in calculating net income. No, we don't consider opportunity costs in calculating net income. So A can't be the right answer. B, the net income is more than its economic profits because economists consider interest payments to be costs. Well, both accountants and economists consider interest payments to be costs. That's not going to cause a difference between economic profits and net income. So B's not right. C, equal to its economic profits. Well, usually that's not going to be the case. It shouldn't be the case. Remember, the difference between accounting income and economic profits is that economic profits, they also subtract out the cost of the capital. Look at letter D. It says net income is higher than its economic profits because opportunity costs are not considered in calculating net income. And that is the correct answer. In accounting, we do not consider opportunity costs, the cost of the capital. Next question. The competitive model of supply and demand predicts a long-run shortage only when, well, the one situation that we came across where there was a shortage was where the maximum price was set below the equilibrium price. And that's letter B. Okay. Again, whenever the maximum price, the max, is below the market, there's going to be a shortage. Next question. It says Clegg Company's average cost is decreasing over a range of increased output. What is Clegg experiencing? Well, this is just the definition of economies of scale. We said that economies of scale is when average cost is decreasing. The answer is B. Next question deals with the monopolist. It says a monopolist tends to, in comparison with firms in a perfectly competitive market, produce same, more or less, sell at a higher price or a lower price. Well, remember, in a monopoly, there's an underallocation of resources, and the amount of output, the production is less. So we can immediately eliminate A and B because monopolists will produce less. Now, what about prices? Well, they sell at a higher or lower price. Well, they're going to sell at a higher price. Remember, they're the only ones in the market. They can sell at a higher price. They don't have any competition. So the answer is D. The next question asked, how does a company maintain a natural monopoly? Well, this is really asking the difference between a natural and a created one. When you create one, you can create it by things like advertising and patents. But a natural monopoly just exists typically because you are the best at doing it, or it's only cost efficient for one to do it. And if you look at letter C, it says technological or economic conditions permit only one efficient supplier. So C is the answer. The next question says companies in monopolist and monopolistic competitive markets maximize profits when? Well, I told you this. I said this is one of those blanket statements you just got to memorize. You maximize profits when marginal revenue is equal to marginal cost. I said it didn't matter what market structure you were in. That's the answer. Letter B. Marginal cost is equal to marginal revenue. Next, we have a fact pattern that goes with the following 3 questions. We have information regarding the number of units produced and the average selling price for different levels of workers. If we have 20 workers, 21 workers, or 22 workers. The first question for this fact pattern asks about the marginal physical product. It says, what is the marginal physical product when one worker is added to a team of 20 workers? So if we add one worker to a team of 20, that would give us 21. So we're obviously looking at the first two lines of this. What happens when we go from 20 workers to 21? Now this is where it's important that you memorized all those terms we talked about previously, and that is the marginal revenue, marginal product, etc. What is marginal product? Which is what they're asking about. The marginal physical product is the additional output. It's the additional output obtained by adding one more unit of an input. So by going from 20 workers to 21 workers, how many more units did we produce? Well, with 21 workers, we produced 45, where with 20, we had only produced 40 units. So we were producing 5 additional units based upon that one more input, that one more worker. The answer is C, 5 units. The next question deals with the marginal revenue per unit. It says, determine the marginal revenue per unit when one worker is added to a team of 21 workers. Not from going from 20 to 21, but adding to 21 workers. So we're going to go from 21 to 22. And again, recall, what is the marginal revenue product here? It's the additional revenue provided by using one more unit of input. So by using one more worker, how much more revenue are we going to get? So we need to use the average marginal revenue product over 3 units, because if you look from 21 to 22, we're going up 3 units, not 1 unit. So we can't really get the exact marginal revenue per unit from going from 47 to 48, but we can get the information from going from 45 to 48, determine what the marginal revenue product is over those 3 units, and just average it out. So what we need to do is figure out what is the selling price at 21 units, or excuse me, I'm sorry, 21 workers. We produce 45 units. Well, at 45 units, we are able to sell them at an average selling price of $69. So if you sell 45 units at $69, that's $3,105. Well, how much sales revenue do you have when you produce 48 units, when you have the 22nd worker there? Well, you're selling those 48 units at an average price of $67.50. So the revenue for those 48 units would be $3,240. All we have to do is take the difference between the revenues for 48 units of product, subtract out the revenues for 45 units of product. In other words, the $3,240 minus the $3,105. We know that the increase in revenue is $135. But remember, that's over 3 units, not 1 unit. It's over 1 unit of workers, but not 1 unit of product. Okay. So if we take the 48 and minus the 45, that gives us 3. 135 divided by 3 is $45. Okay. Next question asks about the marginal revenue product. Okay, the marginal revenue product. And remember, the marginal revenue product is the additional revenue by using one more unit of input. And one more unit of input is the 22nd worker. So here all we're looking for is the difference between the 3240 and the 3,105 that we computed in the last question. In other words, $135. So the answer is letter C. Again, it's just the additional revenue by using one more unit of input, which is the 22nd worker. Now we have another fact pattern that goes with the next 2 questions. We have the total units of product there, 6, 7, 8, and 9, and average fixed cost and average variable cost, and then the average total. And the first question for this pattern, it says the total cost of producing 7 units is what? Well, remember, total cost is what? It's average plus variable. Well, we could really do this 2 ways here. We have the average fixed cost and we have the average variable cost, but we also have the average total cost. The average total cost. All we really have to do is take the 7 units of product, multiply it by the average total cost of $39.29, and we're going to get the cost of producing those 7 units is $275.03. That's letter C. Of course, we could have taken a longer way and added the average fixed cost, the 1429, excuse me, not added it, but multiplied that 1429 times 7, and then add it to the average variable cost of 25 times the 7 units. But why take the long way? Just take the average total cost of 39.29, multiply it by 7. The next question asks us for the marginal cost of producing the 9th unit. Again, marginal means the increase. The increase in cost, marginal cost of producing the 9th unit. In other words, as you go from unit 8 to unit 9, what's the extra amount of cost? In order for us to figure that out, we would have to know what the cost of producing 8 is, and then compare that to the cost of producing that 9 units, subtract the cost of producing all 9 we can subtract from the cost of producing all 9, we can subtract the cost of producing 8 to figure out what the cost of producing that 9th unit is. So what's the cost of producing 8 units? Well, 8 units times $37 of average total cost is $296. For 9 units, we had an average cost of $35.36. That would result in total cost of $318.24 for the 9 units. Subtracting the cost of producing 8 from the cost of producing 9 units, and we're going to get the difference of $22.24. The answer is C. Let's talk about macroeconomics. Remember, when we say macroeconomics, we're talking about the big picture as opposed to microeconomics, which looks at the small picture, the individuals and the firms. With macroeconomics, we're talking about dealing with aggregates. We're looking at the big picture, allocating resources to maximize social welfare. Again, macroeconomics deals with the aggregates and allocating resources to maximize social welfare. And we'll look at things like total production and total employment, these aggregate kinds of numbers. We need to discuss a number of measures that are used in macroeconomics. And you're going to notice that there's a progression here. We're going to start at the very top with a very big number, and we're going to go through various other measures that start with that bigger number and continue to subtract things away, and sometimes some things are added. But the numbers tend to get smaller as we go through this progression of measures. The first measure, the start of it all, is GDP, or the gross domestic product. Now, the gross domestic product is equal to the total market value of all final goods and services produced within a country. Again, GDP is equal to the total market value of all the final goods and services produced within a country. Say the U.S., for example. Now, I emphasize the final goods and services because something like an automobile engine is not a final good, and therefore it's not counted, at least not until it becomes part of the automobile, a finished car. And that way we avoid double counting. So it's just the total market value of all final goods and services. The other thing I wanted to emphasize is that it's all produced within a country. So if we're talking about U.S. GDP, then this would include goods are produced by foreign companies as well as United States companies, as long as those goods are produced within the U.S. borders. It doesn't matter who the manufacturer is, as long as it's being produced within the U.S., it's part of the U.S. GDP. The next measure is GNP, the gross national product. Now, the gross national product is equal to the total market value of all final goods or services, goods and services, that are produced with resources from a specified country. It's a little bit different than the GDP. Okay, it's all the goods and services produced with resources from a specified country. So this is going to include goods and services produced outside the United States, but using U.S. resources. And this is not as common of a measure as in years past. GDP is a little bit more common of a measure, a macro measure. The next macro measure we need to talk about is net domestic product. As I said, we typically are going down through a progression here. The net domestic product, NDP, is equal to the gross domestic product minus depreciation. Okay, so NDP is equal to GDP minus depreciation. Sounds like we're mixing up a bunch of alphabet soup here, but it is important that you have an understanding of all these measures. So you're going to have to spend some time, some effort, making sure that you can identify and compute all of these measures. Again, we start with GDP. Next basically is NDP. We're going to take GDP and subtract out depreciation. The next measure in the progression is national income. So we're going to start with the previous measure, net domestic product, and we have to make some adjustments to get to national income. National income is equal to NDP, the net domestic product, plus U.S. net income earned abroad minus indirect business taxes. Okay. Again, national income is equal to NDP, net domestic product, plus the U.S. net income earned abroad minus indirect business taxes. What are indirect business taxes? Things like sales taxes are indirect business taxes. The next measure in the progression is personal income. And of course, to obtain personal income, we're going to start with the previous measure, and that was national income. Personal income is equal to national income minus corporate income tax and undistributed profits minus Social Security contributions plus transfer payments. Now, what do I mean by transfer payments? Transfer payments, I'm talking about things like Social Security benefits, not contributions, but Social Security benefits that are received, and dividends. So again, personal income is equal to national income minus corporate income tax and undistributed profits minus Social Security contributions plus these transfer payments. Then we get to disposable income, which again starts with the previous measure. That's personal income. The disposable income is personal income minus personal income taxes. Okay. Disposable income is equal to personal income minus personal income taxes. And basically what disposable income measures is it's what people have left over that they can use to consume on goods and services, make interest payments, and save money. So basically we're spending or saving, consuming or saving. You can sort of think of the making interest payments as spending. But that's what disposable income is used for, consumption and savings. One final macro measure is the real per capita output. And real per capita output is equal to GDP divided by the population and then adjusted for inflation. So there's quite a few measures there, and you're going to need to take some time and learn how to compute all of those. Next, I'd like to talk about business cycles. And when we talk about a business cycle, it really would help for us to look at a graph. And so if you go to your viewer's guide, I have a graph in there that's labeled the phases of the business cycle. And you'll notice that it has sort of a squiggly line that looks sort of a little bit like a cursive N. And what we want to do is look at this business cycle, this curvy line here, and talk about the different parts of that business cycle. The first part that I'd like to highlight, if you go down to the bottom where the line first starts towards the origin, and you go up, as you reach that top, as you reach the top of the mountain there, so to speak, that's the peak. That's the highest level of economic activity in a particular cycle. Okay? Again, that peak there is literally called the peak of the business cycle. And this involves the highest level of economic activity, and this is where pretty much the full use of resources is taking place. Now, as you go over that peak and start heading down, okay, sort of think about over the peak but not down to the very bottom. In between there, on that way down, is the part of cycle there is called a contraction or a recession. And basically during this period of time, we notice a drop in the level of business activity, employment is decreasing, and inventories typically grow. Okay? So we have a recessionary or a contraction contractional kind of period of time. Again, we have a drop in business activity, employment is decreasing, and inventories are typically growing. As you reach that very bottom, that's called a trough. And that trough is the lowest level of business activity in a particular business cycle. And obviously way down here, not as much is going on, therefore we're not really utilizing our resources. We have underuse of our resources. And then we start to go back up again, and as we head back up the last part of that curve, the N, so to speak, that's called the expansion or recovery. And this is a period of time where we have a rising level of economic activity. Okay. Let's go back and describe some of these areas in a little bit more detail. Let's start with the trough. I'd like to give you a number of characteristics about that trough part of the cycle, the very bottom. Okay. Remember I said that this was a low level of business activity. So there's a lot of things that are occurring at low points here. In the trough you have low level of outputs, employment is low, income is low, prices tend to be low, costs are low, profits are low, and investment is low. So we have low output, low employment, income, prices, costs, profits, and investment. But the one thing that's high at this point in time is pessimism, because everything's looking sort of bad. Business activity is at a real low, and people aren't feeling very good, and so pessimism is high at that point. Let's talk about the recovery or the expansion period of the cycle. What's happening here? Well, during the recovery, we usually have low interest rates. A lot of times the interest rates are low, trying to spur on or activate some of that recovery, get some business activity going. Also during the expansion, recovery period of time, we're replacing depleted inventories. Investment starts to increase. Demand also starts to increase, as well as employment and income. A lot of the things that were at lows at the trough are starting to now increase. So in the expansion period, we have low interest rates with the replacement of depleted inventories. Investment, demand, employment, and income are all increasing. What about the peak, which is just the opposite of the trough? The trough was the lowest point. Peak is the highest point. So if you can remember a lot of the characteristics for the trough or the peak, then you can just do the reverse for the other. Okay? At the peak, a number of things are at highs. Output is at a high. Employment is at a high. Income, prices, profits, and investment, they're all at highs. And of course, if all these things are at highs, what's at a low? Pessimism is at a low. But on the other hand, you can look at it this way. Be optimistic. Optimism is at a high. We're at the peak. Things are going really well, so people are optimistic at the peak. In the final section of this business cycle that I want to give a little bit more detail on is the contraction or the recessionary period. What's happening during the recession? Well, during the recession, output, employment, and income are all at their peak or have reached their peak already. And at this point, consumer demand begins to taper off. And because demand begins to taper off, prices begin to level out. They're no longer at that high. And inventories are beginning to increase because the demand has tapered off, not as much as being purchased. Also during the recession, costs tend to increase, and the profit margins diminish. Because the costs are increasing, the demand is tapering off, businesses aren't willing to pass on increased costs to the customer because they'll just lose more sales. So the profit margins diminish during this period of time. Also during a recession, demand slackens, as I mentioned, the consumer demand tapering off, and firms reduce their excess inventories. Output begins to become cut, and therefore so is income and employment. Also during the recession, investments are discouraged, and the outlook becomes pessimistic in nature. The next area of macroeconomics that I'd like to discuss with you is indicators. And there are two kinds of indicators we typically talk about. You may hear in the news if you're ever listening to one of the business channels or the nightly news or reading the Wall Street Journal. Leading indicators are used to forecast future trends. Again, leading indicators are used to forecast future trends. They're trying to give us an indication about what's to happen, what's coming up. You may be familiar with a private research group called the Conference Board. And the Conference Board computes a number of composite indices that use these leading indicators. I don't want to try to give you an exhaustive list because there's a lot of them that are used, but I'd like to give you an idea of some of the leading indicators that are used by the Conference Board and others. Some leading indicators would include the average hours worked per week by workers. Another leading indicator is the weekly initial unemployment claims, stock prices of 500 common stocks, new housing permits, new orders for durable goods, changes in the money supply. Again, these leading indicators include average hours worked per week by manufacturer workers, weekly initial unemployment claims, stock prices of 500 common stocks, new housing permits, new orders for durable goods, and changes in the money supply. There are also a number of trailing indicators. Now, obviously, they're not doing any predictions. They're not forecasting. Trailing indicators are indicators that change after the change in the phase of the cycle as we're moving from the peak down or from the trough up and starting to expand. Okay? These are going to give you the indication after the change in the phase. Some examples of trailing indicators include average prime rate charged by banks, the average length of unemployment in terms of weeks, and the change in CPI for services. Again, three examples of trailing indicators: the average prime rate charged by banks, the average length of unemployment in weeks, and the change in CPI for services. What I'd like to discuss with you now are a couple of the major models of economic analysis. Let's begin by talking about the classical model. Under the classical model, equilibrium occurs only at full employment. And if it's not at full employment, it's assumed that the market will correct itself. Again, equilibrium is assumed to occur only at full employment. And if full employment doesn't exist, the market is assumed to correct itself. Well, how does the market go about correcting itself? Well, the driving force behind the market is seen to be as competition. Competition will move the economy towards equilibrium point. For example, if there's any unsold inventory, then prices will be decreased so that the inventory can be sold. We also assume that the competition eliminates any unemployment because of the competition between workers. In contrast, the Keynesian model of economics assumes that the market can reach an equilibrium point, the economy can reach an equilibrium point with significant levels of unemployment. Not full employment, but unemployment, with some unemployment. And it's also assumed that the economy cannot take care of itself. It's not self-regulating as it is in the classical model. And therefore the government needs to come in and act in order to pull the economy out of recessions. Now, two very important variables that exist in these economic models are consumption and savings. You'll recall in previous parts of the class that disposable income is income to the consumer that the consumer can either spend or save. As disposable income increases, you have more money. So what can you do with it? Well, you can spend it or save it. Well, do you always spend everything that you get in income increases? No. We're going to assume that some of it is going to be saved. So what we have, the economists use, are two measures of the changes in disposable income and their impact on consumption and savings. The first measure, let's talk about the marginal propensity to consume, MPC. marginal propensity to consume. And what that measure is simply a ratio of the change in consumption spending to the change in disposable or after-tax income. Again, the marginal propensity to consume is the ratio of the change in consumption spending to the change in disposable or after-tax income. So the ratio is going to fall between 0 and 1. For example, let's assume that we have an MPC of 0.4. What that says is that for every dollar of increases in disposable income, we're going to take 40 cents of that and consume it. We're going to spend it on something. So what are we going to do with the other 60 cents? Right, we're going to save it. And that leads us to the next measure, which is the marginal propensity to save. The marginal propensity to save is the ratio of the change in planned saving to the change in disposable income. And as you probably have already realized, when you have a dollar increase of disposable income and 40 cents of it is going to be spent and 60 cents of it is going to be saved, that's all that there is. So the sum of the marginal propensity to consume and the marginal propensity to save must be equal to 1. So if you ever know one of those ratios, one of those measures, and you don't know the other, you can always subtract that other measure from 1 to get the measure you don't know. So for example, if you don't know what marginal propensity to consume is, you can simply subtract the marginal propensity to save from 1. Let's talk a little bit about savings and their viewpoints in the different economic models. Now, in the classical model, it's assumed that savings depends entirely on the interest rate. But Keynes believed that savings habits were based primarily on consumers' income. Again, under the classical model, the assumption was that savings depended upon interest rates. Under the Keynesian model, consumer savings depends on income. What about investments? Well, classical economists believe that the most important determinant of planned investment spending is the interest rate. Keynes, on the other hand, argued that profit expectations are the most important determinant of investment spending by businesses. The next item we need to talk about is the multiplier effect. You see, as expenditures are made, it results in a larger impact on the national output or national income. Again, this multiplier effect, what it does is it measures the relationship between a change in the aggregate expenditure and the resulting larger change in national output. The way that we compute the multiplier effect is simply to take 1 and divide it by the marginal propensity to save. Of course, if you don't know the marginal propensity to save, you could compute this multiplier effect by taking 1 divided by 1 minus the marginal propensity to consume. Now, the larger this multiplier, the larger the marginal propensity to consume, then the larger the multiplier. Or another way to look at it is the smaller the marginal propensity to save, the larger the multiplier. So the marginal propensity to consume and the marginal propensity to save have opposite effects on that multiplier. Remember, they're equal to 1 minus the other measure. So they're going to have opposite effects when they get in that denominator of the multiplier effect. Let's talk about money supply. Money supply can be measured in different ways. The first measure is M1. M1 is the most liquid definition of money. And in M1, we'll include currency, traveler's checks, and checkable deposits. When I talk about currency, of course, I'm referring to paper money and coins. When I talk about checkable deposits, I'm talking about checking accounts at banks. I'm talking about NOW accounts, automated transfer service accounts, and share draft accounts. M2 is equal to M1, but it includes more variables. So to get M2, what we'll do is we'll take M1 and we'll also add savings accounts. We'll add small time deposits. These are deposits less than $100,000. and we'll also add in money market funds. So M2 is equal to M1 plus the savings deposits, the small time deposits less than 100,000, and money market accounts. Now, when I refer to savings deposits or savings accounts, I'm talking about interest-bearing accounts that do not allow for automatic transfer services. If you have a savings account that allows for automatic transfer services, that's part of the M1 supply. Time deposits, or the small time deposits I was talking about, I'm talking about CDs here, certificates of deposits. These are funds that earn a fixed rate of interest and must be held for a specific period of time. Money market funds are deposits held in accounts invested in a broad range of financial assets. Okay, so M2 includes saving deposits, time deposits like CDs, and money market funds. M3 is the largest measure of money supply. It's going to include M2, plus we're going to add in large negotiable CDs. These are the CDs that are over $100,000. And we'll also include Eurodollars in the M3 measure. Now, Eurodollars are simply U.S. dollars that are deposited in foreign banks, and therefore they're really outside the jurisdiction of the United States. Again, Eurodollars are U.S. dollars. They're deposited in foreign banks, and therefore they're out of the jurisdiction of the United States. Well, how does money get created? Well, first, somebody takes some new money and they deposit it in a bank. Now, when a customer deposits money in the bank must retain a certain percentage in reserve. This is known as the reserve ratio. So, for example, if I deposit $1,000 and the reserve ratio is 20%, then the bank is going to have to maintain or keep on hand $200 of that $1,000 deposit. The rest, the difference, the $800, are considered excess reserves, and that money can be loaned out. Now, when a bank loans out money from its excess reserves, it's creating money. It's increasing the money supply. Now, the effect of this increase on the money supply is measured through what we call the money multiplier. Now, the money multiplier is very easy to compute. It's simply the reciprocal of the reserve ratio. So the money multiplier is equal to 1 divided by the reserve ratio. So let's look at a little example. Let's say that we have an increase in deposits at a bank of $1,000. The reserve ratio is, let's say, 10%. Then we can measure the effect that this deposit has on the overall money supply in the banking system. What we can do is get the money multiplier, compute the money multiplier. Remember, that's 1 divided by the reserve ratio. If the reserve ratio is 10%, 1 divided by 10% would be 10. So if we have an increase in deposits of $1,000, we can multiply that by the money multiplier of 10, and that would result in an overall money supply increase in the banking system of $10,000. Well, who controls the money supply? I hope you know it's the Federal Reserve, Federal Reserve Board. They control the money supply. Now, the Federal Reserve has general controls that affect the overall supply of money. They also use some selective controls that we'll talk about. Now, the most important of all the controls that the Federal Reserve uses are open market operations. And what I'm talking about here is when the Federal Reserve buys and sells government securities. And by buying and selling government securities, they're impacting the money supply. When they purchase securities, it encourages the expansion of the money supply. They're putting more money into the banking system, and of course that gets impacted by that money multiplier. When they sell securities, that leads to a contraction of the money supply. They're taking money out of the money supply. So for example, if the Federal Open Market Committee buys $50,000 of securities, they're putting $50,000 into the banking supply, but the money multiplier, if we assume that the reserve ratio is 10%, say, then the money multiplier, remember, is 10 times. So by putting $50,000 in there, buying $50,000 of securities, then they're going to increase the money supply by 500,000, the $50,000 times the money multiplier of 10. So you can see there's an importance to these excess reserves. The effectiveness of the Federal Reserve Board's efforts to either limit or expand the money supply depend on the status of these excess reserves. Again, if they purchase securities in the open market, they're trying to expand the money supply. And if they sell, they're reducing the money supply. Well, what is the discount rate? You may have heard of the discount rate before. Well, the discount rate is the interest rate at which depository institutions can borrow funds from the Federal Reserve banks. Okay. Discount rate is an interest rate that reserve banks can borrow from the Federal Reserve, from each other. Okay. This is usually very short-term kind of borrowing, like overnight. Now, the Federal Reserve can affect these discount rates, and if they lower the discount rate, then the Fed is signaling that they want to encourage the expansion of the money supply. If the Federal Reserve raises the discount rate, it gives the opposite signal. In other words, they're trying to contract the money supply. Some other rates that you might ought to be familiar with include commercial loans and federal funds rates. Okay. You've probably, I'm sure you've heard of the prime rate. Make sure you know what the prime rate is. The prime rate is the rate at which individuals and firms with the best credit can borrow. Okay. Prime rate is the rate at which the individuals and firms with the best credit ratings can borrow. The federal funds market rate, is a fairly well-organized market where the banks borrow. And again, we talked about the federal funds rate a little bit earlier. That's the rate at which each of these federal funds banks can borrow from each other. Let's talk about price indexes. Now, a price index is simply a number, a method that we can compute that allows us to compare the average price of anything in one period of time with its price at another point in time. In other words, we can compare, let's say, for example, how much a loaf of bread costs today to how much a loaf of bread cost 1 year ago. So price index just measures the price for a good in one period relative to a base period. And you can develop price indices or price indexes for a variety of items. We could group goods together. We could group goods and services together and compare prices in one period to prices in another period. Now, the way that you determine the price index is you simply take the price of whatever good or goods that you're interested in a given year, divide that by the price of goods in the base period, and then if you want to, you can multiply it by 100. Some people do, some don't. Let me give you a numerical example, just to make sure that you're following me here. If the price of goods or a good in 1 year, this year, is $1,200, and if we bought the same good, let's say 1 year ago, our base period, and that good would have cost us $1,000 then, what would be the price index for the current year? Well, we would be comparing the price of that good, $1,200, to the base period price of $1,000. So we have $1,200 divided by 1,000, and we would get 1.2. If we multiplied it by 100, we would get 120. But either way, it gives us the same information. If we don't multiply it by the 100, and we just have 1.2 or 1.20, what you can do is subtract out 1, that's what you start with, and the difference, 0.2 or 20%, indicates how prices have changed. In other words, from our base year to the current year, there's been a 20% increase. If you had multiplied it by 100, you would be comparing, or you would have a price index of 120. To figure out how prices have changed since the base period, you would subtract out 100. So 120 minus 100 would be 20, and that indicates that prices went up by 20%. So you really can compute that using the 100 in there or not. It's up to you. Now, price index, a commonly used price index in our economy is the CPI, the Consumer Price Index. Now, the Consumer Price Index compares the price of a group of basic goods and services as purchased by urban residents. Again, the CPI is an index that basically compares the price of a group of basic goods and services as purchased by urban residents today. Compare that to some base period. Now, you might be interested as to what goes into the CPI. I don't think the exam is going to ask you any percentages. But some of the things that go into the computation of the CPI include food and beverages, housing, apparel, transportation, medical care, recreation, education and communication, as well as some other items. Now, the CPI does have some limitations that you ought to be aware of. Basically, what the CPI does is it measures the relative change in the cost of living. How have prices changed from relative to some base period? And so, by doing that, what it does not measure is the actual cost of living. It does tell us how the cost of living has changed, but not what the actual cost of living is. And it's really not a completely pure index. In fact, it's recognized that there's usually a little bit of upward bias in there each year. Now, the other common index that you probably ought to be aware of for the exam is the Producer Price Index. The Producer Price Index, or PPI, is a measure of the average prices received by producers and wholesalers. So the Consumer Price Index is looking at how prices change for consumers. The Producer Price Index is looking for how prices change for the producers, what they're able to receive for their products. The first four questions relate to this fact pattern for NIVIC. And in these questions, we are asked to compute a number of these macroeconomic measures that we've previously discussed. The first question asks us to compute the net domestic product. You recall that the net domestic product is equal to GDP minus depreciation. So all that we have to do here is take the 4,500,000 talents of GDP, subtract the depreciation of 500,000 talents, and we'll get 4 million talents. The answer is D. The next question, we are requested to compute national income. You'll recall that national income is defined as net domestic product plus any income earned abroad minus any indirect business taxes. So what we're going to do is we'll start off with the net domestic product we got in the previous question, the 4 million talents. We're going to subtract out $100,000 of income earned abroad. We're going to add the 100,000 talents of income earned abroad. We're going to subtract out the 175,000 talents of indirect business taxes, and we get our answer of 3,925,000 talents. The third question in this pattern asks for us to compute personal income. You'll recall that personal income is defined as the national income minus the corporate income taxes, minus any undistributed corporate profits, minus any retirement contributions, and plus any transfer payments. Well, here we're going to take the national income that we computed in the previous question, the 3,925,000 talents. We're going to subtract out 100,000 talents for the corporate income taxes. We're going to subtract out 50,000 in undistributed corporate profits. We're going to subtract out 300,000 in the retirement contributions, and we'll add the 600,000 talents of transfer payments, and we'll get the answer of 4,075,000 talents. The last question in the pattern asks us to compute disposable income. Recall that disposable income is defined as the personal income that we just computed minus any personal income taxes. So we're going to take the 4,075,000 talents of personal income, and we'll subtract out the personal income taxes of 150,000 talents. So our answer is B, 3,925,000 talents. The next question says the recessionary phase of a business cycle is characterized by what? How about A, high levels of economic activity? No, in a recessionary phase, remember that economic activity is decreasing. B, shortages of resources? No, here we're actually going to beginning to have increases in supplies of resources because we're not operating at full capacity. C, potential national income will exceed actual national income. Or D, the reverse situation. Well, it's going to be C, the potential national income is going to exceed the actual national income, again, because not all our resources are being used. So we're not operating at full capacity, therefore we're not realizing the full potential. The full potential is greater than actually what's occurring. Answer is C. The next question asks us about the multiplier effect. What does it explain? Well, remember, we said the multiplier effect is basically explaining how a change in an investment can impact the larger number, the national output. Well, that's letter A. A small change in investment can have a much larger impact on gross domestic product. For the next two questions, we have another fact pattern, and this deals with gross domestic product. What you have to remember about gross domestic product is that it's a measure of all the final, remember it's a market value of all the final goods and services produced in a country. Well, consumption and investment represents what's being done in that country, but it also includes net exports because you're exporting from our country or whatever the national country is into another country. So GDP, the equilibrium GDP, occurs when consumption, investment, and net exports all add up to be the real GDP. So the first question asks us, what is the equilibrium point for gross domestic product? And if we look at the data, we have to go through and see where consumption and investment added to net exports is equal to the real GDP at that level. And when we go through that list, go down to 420 real GDP, you'll notice that the consumption and investment is 412 and the net exports are 8. When you add that together, you get the real GDP of 420. So the answer is letter B. In the next question, it says, what is the equilibrium real GDP if net exports are increased by $6 at each level? Well, we have to go back to this data, and we're going to have to add $6 to the net exports, which is going to break all the net exports equal to 14. Then we'll add for each level the consumption and investment and see where that equals the real gross domestic product. And we're going to come up with 460. Because at 460, we have consumption and investment of 446 plus the net exports now of 14. So again, the answer is C. In the next question, it asks, if the marginal propensity to consume is 0.35, a $30 increase in net exports will cause an increase in equilibrium real GDP of what? Remember, net exports is a part of real GDP, and when you increase expenditures, then that's going to increase or have a bigger impact. So what is the impact of this? Remember, marginal propensity to consume being 0.35, that makes the marginal propensity to save 0.65. And so we're going to get the multiplier. We'll take 1, divide it by the 0.65, the marginal propensity to save, multiply that by the $30, and that's $46 rounded. So the answer is letter B. The next question asked about what action would the Federal Reserve Board take to implement an expansionary monetary policy? Well, if they want to have an expansionary monetary policy, they want to increase the money supply. Let's look at the choices. Letter A says increase the reserve requirement and decrease the discount rate. Well, if you increase the reserve requirement, remember what that does to that money multiplier. You're going to have 1 divided by a larger reserve ratio. Well, that's going to make that multiplier smaller. So that's not expansionary. A is not correct. If we look at B, B says purchase U.S. government securities and decrease the discount rate. Well, when the Federal Reserve purchases U.S. government securities, they're putting in money into the money supply. That's going to be expansionary. What about the discount rate? It says, and decrease the discount rate. Well, Federal Reserve, when they decrease the discount rate, they're trying to expand monetary policy. They're trying to expand the money supply. So that's correct. Letter B is the answer. If you look at C and D, it's usually a good idea. Make sure they're wrong. I feel pretty good about B. Let's look at C real quick. It says increase the reserve requirement and the discount rate. Well, we said in letter A, increasing the reserve requirement is going to not have an expansionary monetary effect. It's going to decrease the monetary supply. So C is wrong. In D, it says increase the discount rate. Well, if you increase the discount rate, that's not expansionary. That's contractionary. It's going to contract the money supply. So the answer is B. The next question also deals with money and the banking system. This is a banking system with a reserve ratio of 25%, and a change in reserves of $750,000 can increase its total demand deposits by how much? Well, again, use the multiplier. We're going to take 1 divided by the reserve ratio of 25%. Your multiplier is 4. So you take 4 times the change of reserves of $750,000, and you get $3 million. The answer is C. The next question deals with Carlton Bank. It says Carlton Bank has deposit liabilities of $100,000. It has reserves of $45,000 and a required reserve ratio of 25%. Let's stop and think about that. If they have $100,000 of deposits on hand and a required reserve ratio of 25%, the only amount that they are required to keep on hand is the 25% of the $100,000, which is $25,000. So they have $20,000 of excess reserves. Let's read what the question says. It says, therefore, Carlton Bank and the banking system can increase loans respectively by how much? Well, since Carlton has $20,000 of excess reserves, they can loan that money out. So that immediately cancels out B and D. They can't be right because they say $45,000 and $50,000 as the increase in loans by Carlton. They can only loan out $20,000, so it's got to be A or C. Well, what's the effect on the banking system? Well, again, the multiplier, 1 divided by 25% is 4. When they loan $20,000 out, that has an impact on the banking system of 4 times that amount, which is $80,000. So the answer is A. Let's talk about international economics. One of the issues that we're interested in this area is what should we be producing for exchange with other countries? And there are a couple of concepts for us to look at. One is called the absolute advantage. The absolute advantage is the ability to produce a good or a service using fewer resources than other producers use. Again, the absolute advantage is the ability to produce a good or service using fewer resources than other producers use. Another concept that we talk about is comparative advantage. This is the ability to produce a good or service at a lower opportunity cost than other producers. Again, comparative advantage is the ability to produce a good or service at a lower opportunity cost than other producers. Ideally, parties should produce the good in which it has the lower opportunity cost. If you go to your viewer's guide, I have an example of 2 nations and their ability to produce cotton and wheat. We have countries Southland and Northland. Now, if you look at the data, for Southland is able to use 3 units of resources to produce 30 bales of cotton. and they can use 2 units of resource and produce 60 bushels of wheat. Northland, using 3 units of resource, can only produce 15 bales of cotton, and using 2 units of resource is able to produce 40 bushels of wheat. So in all, with both countries using 6 units of resources to produce cotton, they get 45 bales of cotton. And in producing wheat, using 4 units of resource, they're able to produce 100 bushels of wheat. Well, let's look at these concepts of absolute advantage and comparative advantage with relation to this data. Let's start with absolute advantage. Let's figure out who has the absolute advantage in producing cotton. Remember, the absolute advantage is the ability to produce a good or service using fewer resources than other producers. Well, let's look at Southland. Southland can produce 30 bales of cotton using 3 units of resource, but we need to know how much they can produce using 1 unit of resource. So take the 30 bales of cotton, divide it by the 3 units of resource, they're able to produce 10 bales of cotton for each unit of resource. What about Northland in producing cotton? They produce 15 bales of cotton using 3 units of resource. So per unit, they're only able to produce 5 bales of cotton. So Southland has the absolute advantage. They're able to produce 10 bales of cotton per unit of resource, whereas Northland can only produce 5 units of resource. Again, Southland has the absolute advantage over Northland in producing cotton. How about the absolute advantage in producing wheat? Again, let's start with Southland. Southland's able to produce 60 bushels of wheat when they utilize 2 units of resource. So per unit, that would be 30 bushels of wheat. Northland is capable of producing 40 bushels of wheat when they use 2 units of resource. So per unit of resource, that's 20 per unit of resource. So Southland has the absolute advantage over Northland in producing wheat. They're able to produce 30 bushels of wheat compared to Northland's 20 bushels of wheat. So Southland has the absolute advantage in producing both cotton and wheat. And that's a little bit of a problem because we want to have countries producing what they're best at, but some countries are better at producing a lot of goods. They're more efficient. So what we can do is look at the comparative advantage. Ideally, what we'll do is have the countries produce those goods that they have a comparative advantage in. And when we look at comparative advantage, only one country will have a comparative advantage in a resource when we're looking at a 2-resource situation like this. And then the other country will have the comparative advantage in the other resource. So under comparative advantage, the parties will produce the good in which it has the lowest or lower opportunity cost. So what we're going to have to do is compute the opportunity cost of these countries in producing cotton and wheat. Well, let's look at producing cotton. And what we really need to do, it's a lot easier if you look at the output based upon just 1 unit of resource. So for Southland, when we talk about cotton, they were able to produce 30 bales of cotton using 3 units of resource, so that translated into 10 bales of cotton per unit. Well, they could also use that unit of resource to produce bushels of wheat. How much wheat could Southland use? Because if we're going to talk about the opportunity cost of cotton, remember that's the cost of not producing wheat. Well, with wheat, they're able to produce 60 bushels using 2 units of resource, or 30 bushels per unit of resource. So for Southland, using 1 unit of resource, they could either produce 10 bales of cotton, or they could produce 30 bushels of wheat. If we wanted to express this in terms of the opportunity cost of producing cotton, again, the opportunity cost of producing cotton, the cost of producing cotton is 30 bushels of wheat to 10 bales of cotton. Because that's what happens. If they use 1 unit of resource, they could make 30 bushels of wheat or 10 bales of cotton. So the cost, the opportunity cost of producing cotton is 3. It's 30 divided by 10. What about the opportunity cost of Northland to produce cotton? Well, again, let's put this cotton and wheat production in terms of 1 unit. How many bales of cotton can Northland produce using 1 unit of resource? They had 15 bales of cotton when they used 3 units of resource, so that translated to 5 bales of cotton using 1 unit of resource. When they produced wheat, that was 20 bushels of wheat for 1 unit of resource. It was the 40 divided by 2 units. So how do we compute the opportunity cost of producing cotton for Northland? Again, we're going to take the 20 bushels of wheat that they could produce using a unit of resource, divide it by the 5 bales of cotton that they could produce using the 1 unit of resource, and the opportunity cost of producing cotton, more or less, is 4. So who has the lower opportunity cost of cotton? It's Southland. Southland has an opportunity cost of cotton of 3 compared to Northland's 4, so Southland should produce cotton. We said that the parties should produce the good in which they have the lowest opportunity cost. So Southland will produce cotton. Therefore, Northland must have a comparative advantage in producing wheat. But let's make sure. Let's figure out the opportunity cost of producing wheat for both the countries. Let's start with Southland. What's the opportunity cost of producing wheat? Well, in that case, they would have to give up the 10 bales of cotton they could produce in order to produce the 30 bushels of wheat using 1 unit of resource. So the opportunity cost is 1 over 3. With respect to Northland, the opportunity cost of wheat would be the 5 bales of cotton divided by the 20 bushels of wheat they could produce using 1 unit of resource. That's 1/4. Which one of those opportunity costs is smaller, 1 over 3 or 1 over 4? It's 1 over 4 is the smaller number. So Northland has the lowest opportunity cost of producing wheat. So Northland should produce the wheat. So you can see that comparative advantage is good in identifying who should produce what unit, because there's only one country that will have a comparative advantage in a particular product. Well, if we use that comparative advantage and Southland produces cotton and Northland produces wheat, and they use all their resources for producing those items, how much cotton and how much wheat will be the result? Well, if Southland produces nothing but cotton, remember they were able to produce 10 bales of cotton for every unit of resource. If they were to, say, have 5 units of resource, because remember they had 3 units that they were using for cotton and 2 for wheat, they had 5 units of resource before. Now they can take those 5 units of resource. Instead of doing some cotton and wheat, they can produce all cotton. They would get 10 bales of cotton for each unit of resource. They would make 50 bales of cotton. Northland, on the other hand, had a comparative advantage in producing wheat. So they're going to take all their resources and make wheat. And in the original data, Northland was using 3 units of resources for cotton and 2 for wheat. Now they're going to take all 5 of those resources and make wheat. Well, they were able to produce 20 bushels of wheat for every resource. So using all 5 units of resource, they'll make 100 bushels. So how many bales of cotton and bushels of wheat are there after the countries begin to specialize? Well, now they're making 50 bales of cotton and 100 bushels of wheat. So overall, there's more production when the countries produce the item that they have a comparative advantage in. So using comparative advantage, it's better for everyone because there's more units being produced. Well, if countries are making products and working with each other and they're exchanging, there has to be a way of making that exchange easier. In other words, there needs to be some foreign common medium of exchange. And if countries are using different currencies, then we need to come up with an exchange rate. And the exchange rate is the rate at which one currency can be exchanged for another currency. Now, when a currency can buy more of another currency, for example, if the US dollar can buy more Swiss francs or any other Mexican pesos, if they could buy more with $1 US, then the U.S. dollar is said to have appreciated. If, on the other hand, the U.S. dollar can buy less pesos, that dollar is said to have depreciated. Well, where do the exchange rates come from? Well, we have different kinds of exchange rates. Floating exchange rates is where the market determines what that exchange rate should be. Okay, a floating exchange rate is where the market itself determines what that rate should be. On the other hand, a fixed exchange rate is an exchange rate that's fixed by a particular government. Again, a fixed exchange rate is fixed by a particular government. Now, we could have some sort of cross between these two systems and have what we call a managed float. A managed float. And managed float, the market is the primary determinant of the exchange rate, but sometimes governments intervene to maintain stability. When talking about foreign exchange, we have more rates to talk about. We have spot rates and forward exchange rates. What is a spot rate? A spot rate is the exchange rate paid for currency right now on the spot. Again, a spot rate is the rate of exchange for currency right now. So if I went out right this moment and exchanged US dollars for pesos, that would be done using the spot rate. The forward exchange rate is a rate agreed upon to be paid at a specified point in the future. If I knew I was going to have a transaction and I would have to pay a certain amount of pesos in the future, I could enter into a forward contract using a forward exchange rate. And we could agree, I would agree with the bank or wherever I was getting the pesos from, at a certain rate, at a certain period of time. That's the forward exchange rate, the amount that will be exchanged at a specified period of time. And these two usually are not the same. Usually, the forward rate and the spot rate are different. What happens if the forward rate is greater than the spot rate? Again, the forward rate is greater than the spot rate. Well, in this case, the currency is said to be at a premium. The forward rate is at a premium. That's more than the spot rate. And what that says is that they're expecting the value of that currency to increase. Again, if we have a forward rate greater than a spot rate, then it's at a premium, and the value is expected to increase. And the opposite would be where the forward rate is less than the spot rate. And that currency, the forward exchange rate, would be at a discount to the spot rate. In other words, investors are expecting the currency to decline in value. Now, these exchange rates are affected by interest rates. Whether these forward rates are less than or more than the spot rate is often determined by the relationship between interest rates in one country to that of the other country. So what kind of relationships exist there? If the domestic rate is greater than the foreign interest rate, again, the domestic interest rate is greater than the foreign country's interest rate, then this forward exchange rate is going to be at a premium. And the opposite is true. If the domestic rate is less than the foreign interest rate, then it's going to be at a discount. Some other items of importance here in the area of international economics is the balance of payments. When we're talking about exchanging between these countries, sometimes some countries import more than they export. And so we have a difference in the accounts. There's a difference in how much the countries owe each other. There's a couple of accounts that we need to talk about. One is called the current account. Now, the current account includes the balance of goods and services, net of any interest and dividends, and any unilateral transfers. Again, the current account includes the balance of goods or services, the net interest and dividends, and net unilateral transfers. So what is the balance of goods and services? Well, the way you need to look at balance of goods and services is this. It's the imports, which you can say that they're debits, less exports, which are credits. In other words, the imports, that's what's coming in. Exports, that's what's going out. Now, there is a difference between this balance of goods and services and something else called balance of trade. Remember, the current account is the balance of goods and services and the net of interest and dividends and net of unilateral transfers. But the balance of trade is a little bit different, and you may come across that term. It's the same thing as the balance of goods and services, except it excludes the services. So if you come across a question and it says the balance of trade, then you're going to just look at the imports minus the exports, not including the services, just goods. But in the current account, we typically are using the balance of goods and services. So you want to include the services in the imports and exports. Well, what about the interest and dividend? Okay, how do we handle that? Well, if interest is being paid out because, for example, you're paying interest on a foreign loan, well, that's like an export. That's going out. And what we're really looking at in this current account is where's the money going? Is it coming in or is it going out? So if you're making payments for interest and dividends going out overseas, then that is basically a credit. If it's coming in, then that's a debit. Same with the unilateral transfers. These are things like foreign aid. When the United States sends aid to foreign countries, we're exporting our money. If we're sending pension payments overseas for some reason, that's an export. That's a credit. Now, the capital account is another account that deals with the balance between countries. And what the capital account looks at is the result of the exchange in fixed or financial assets. In other words, things like equipment and securities. Next topic that we need to talk about with international economics is trade barriers and control strategies. And I just wanted to mention a few here. Some of the relationships that exist between countries and this balance of trade. Some countries will have import quotas. In other words, this is a limit on the imports. And this is a strategy to try to keep the difference or the balance in trade more balanced. Countries will use these import quotas. And, for example, if the U.S. imports more goods from like Japan than they're exporting, the United States might decide to use import quotas and limit the number of imports coming in from Japan. Tariffs is another control strategy. And what a tariff is, it's simply a tax on imports. Okay? So it's a tax on imports, which means that the imports are going to cost more to the consumer in this country. So if there's a tariff, say, on Japanese automobiles, then that's going to increase the price that U.S. citizens pay on those Japanese automobiles. Another control strategy is export incentives. Things like subsidies. Sometimes a country like the United States may make payments to producers in the United States to send goods overseas. They'll pay them a little bit of money to add on to the price because the price overseas isn't large enough, and that's considered a subsidy. Let's do this group of questions together. We have a fact pattern here for the first three questions that deals with North Korea and South Korea and their ability to produce corn and potato chips. Using 1 unit of resource, we're told that North Korea could produce 5 bushels of corn, or they could produce 1,000 units of potato chips. South Korea, on the other hand, can produce 10 bushels of corn using 1 unit of resource, or 1,500 units of potato chips. Well, let's just do a little bit of analysis on our own before we get into the questions. Let's look at who has the absolute advantage in producing corn and who has the absolute advantage in producing potato chips. Remember, absolute advantage is how much you can produce using 1 unit of resource. Whoever can produce more using 1 unit of resource has the absolute advantage. North Korea is able to produce 5 bushels of corn using 1 unit of resource, but South Korea can produce 10. So South Korea has the absolute advantage in producing corn. They also have the absolute advantage in producing potato chips because they're able to produce 1,500 potato chips compared to North Korea's 1,000 units. We're a little bit luckier in this particular problem because the data is already given to us on a per unit basis. I've seen other problems, like the example we've done previously, where it wasn't based upon the 1 unit of resource and you had to figure out what the amount of production would be for 1 unit of resource. What about the comparative advantage? Who has the comparative advantage in producing potato chips? Well, remember, the country that has the comparative advantage in producing potato chips has the lowest opportunity cost of producing the chips. And to compute the opportunity cost of producing chips, you have to compare the bushels of corn you would have to give up to the number of units of chips that you would be able to produce. So looking at North Korea, they would give up 5 bushels of corn in order to produce the 1,000 units of potato chips. In other words, that's an opportunity cost of 1/200. For South Korea would have to give up 10 bushels of corn in order to produce 1,500 units of potato chips. So 10 divided by 1,500 would be 1/150. And of course, 1/200, the opportunity cost for North Korea is lower than the opportunity cost for South Korea of 1/150. So North Korea has the comparative advantage in producing potato chips. What about producing corn? Well, again, the country that has the comparative advantage in producing corn is going to have the lowest opportunity cost, which means if you're going to produce corn, you're going to give up producing potato chips. So what is the opportunity cost for North Korea? Well, North Korea would give up 1,000 units of potato chips in order to produce 5 bushels of corn. That's an opportunity cost of 200. For South Korea, they would have to give up 1,500 units of potato chips in order to produce 10 bushels of corn. 1,500 divided by 10 would be 150. So South Korea has the lowest opportunity cost and therefore has the comparative advantage in producing corn. Well, knowing this, we should be able to answer these questions. The first question, it says, in trade between North Korea and South Korea, what? Well, we already saw that South Korea has a comparative advantage in producing corn, and that is the answer in B. Let's look at the other answers to make sure that they were wrong. A says North Korea has an absolute advantage in producing corn. We said that South Korea had the absolute advantage in producing both corn and chips, so A is not right. C, North Korea has a comparative advantage in producing corn. Well, no, that's the opposite of the correct answer, which is letter B, which we've already computed. D, South Korea has a comparative advantage in producing chips. No, we said that North Korea had the comparative advantage in producing chips. So B is the only correct answer in that question. In the next question, it says, if there were free trade between the two countries, which one of the following statements would be true? A, only North Korea will gain from free trade. No, theoretically, everyone is going to gain from free trade because then we're going to have the maximum amount of output. You saw in our previous example that after specialization, there was more bushels of cotton, bales of cotton and wheat being produced. Okay, so specialization is going to benefit everybody. There would be more output. B, South Korea would specialize in the production of both chips and corn. No, South Korea is going to just produce the corn because they have the comparative advantage in corn. North Korea had this comparative advantage in chips, so B is not correct. C, South Korea will export chips to North Korea. No, South Korea has a comparative advantage in corn. They're not going to be exporting any chips to North Korea. North Korea can produce chips better. North Korea is going to specialize in the chips. The answer must be D. North Korea will specialize in the production of chips. Now, the third question is a little bit more difficult. It says, assuming free trade between the South Korea and North Korea, the relative prices of the corn and the chips would be what? Well, the answer here is going to be B. It's going to be between 150 and 200 chips for 1 bushel of corn. Now, why is that correct? Well, recall that North Korea's opportunity cost to produce 1 bushel of corn is 200 units of chips. South Korea's opportunity cost for producing 1 bushel of corn is 150 units of chips. Thus, the lowest price that South Korea would charge would be 150. And North Korea wouldn't pay more than, North Korea would only be willing to pay around 200. So the answer is B. Next question says, what is the consequence of tariffs on imports of a product? Remember, we said that tariffs is a tax sort of on these imports, and that makes the cost of the final consumer higher. And the answer is C, a higher cost for the consumer of the imported product. A is not correct because it's not going to result in higher consumption. The cost is going to be higher. And because the cost is higher, we know that there would be less demand. So A is not correct. B, there would be lower profits on rival domestic products. Well, the tax on imports is not really going to affect the domestic products. And in fact, by taxing or providing a tariff on these imports, that makes the domestic products a little bit more competitive in that they don't have to reduce the price in order to compete with the imports. So the profits are not going to be affected on rival domestic products. D said lower cost for the consumer on rival domestic products. No, it's not going to result in any lower cost. It's still going to be charging the same price. So the answer is C. The next question says, given a spot exchange rate for the US dollar against the euro dollar of 1.209 and a 90-day forward rate of 1.1956, what? Well, we said that when the forward rate is lower than the spot rate, that forward rate was at a discount. And that's the answer to C. The forward euro dollar is at a discount against the dollar. The next question says, if the US dollar British pound exchange rate is $1 for 0.58 British pounds, a product priced at 45 pounds will cost a US consumer how much? What we have to do is convert the pounds into US dollars, and the exchange rate is $1 for 0.58 British pounds. All we're going to have to do is multiply the 45 pounds times $1 divided by 0.58 British pounds. The pounds will cancel out, leaving us $77.58. The answer is B. The next question. What would be the likely result of a decline in the value of the US dollar relative to the currencies of the trading partners of the US? Well, if the value of the US dollar is declining, that means that the foreign currencies are getting stronger. And what that means is that US exports to other countries will become cheaper for those foreign countries because their dollar is stronger. They're able to buy more items of US exports. So the US exports will increase. The answer is C. The last question says, generally, how are balance of payment deficits and surpluses eliminated? Well, we have typically in the currency markets flexible exchange rates or floating exchange rates. And just by the market mechanism of the floating exchange rates, this is how balance of payment deficits and surpluses are eliminated. The answer is C. A says by adopting a common monetary unit. Well, that's not going to help reduce any deficits or surpluses because some countries will still import more or export more to certain countries. B said by adopting tight monetary policies. Well, that's not going to necessarily affect the exchanges between countries. It might impact a little bit in this country of the change, but not necessarily in the other country. D says by taxing imports as necessary for import and export quantities to match. Not a really great thing to do. Usually tariffs and other control strategies sometimes backfire and don't work the way that they are intended to. It's not really the best way to do it. C is the best answer. Just let the market reach its own equilibrium. Well, that's the end of our discussion on economics. On behalf of all of us here at BISC, I'd like to encourage you to study, do lots and lots of questions. There's a very high correlation between doing lots of questions and doing well on the exam. We'd like to wish you the best of luck
Hello, welcome to the Financial Management Review. My name is Ron Harris and I'm the Chief Financial Officer of High Tech POS, a startup software company that's based in Raleigh, North Carolina. Over the past 25 years, I've been involved in various aspects of financial management. I was a finance leader at GE and GE Capital. I started the investor relations function and ran it for a company called Convergys Corporation, which is one of the largest BPO companies in the world. In addition to being the CFO at High Tech POS, I'm a consultant and instructor of finance for the University of Florida's Leadership Development Institute. My academic training in finance included an MBA from Washington University in St. Louis, where I was a Consortium for Graduate Study and Management Fellow. In today's review, we're going to focus on time value of money. We'll talk about concepts such as present value and future value. We'll look at time value interest factors, and we'll see the importance of compounding in a lot of financial management problems. One of the primary principles in time value of money is the fact that $1 today is worth more than $1 tomorrow. And that's a fact because the dollar today can be invested immediately to start earning interest. If someone gave you the option of getting $373.38 today or $373.83 in the future, but said you could not earn any interest on that money, you would pretty much be indifferent whether to get the $300 today or get the $373 in the future. Now, if they said you could earn 7% interest per year, and then you would say, I'll take that $373.83 right now because a year from now it would be worth $400. And that's the power of the time value of money. One way to look at it is to say that discounting from future value back to the present value is like moving along a timeline where you would go from one value to the other, and the difference would be the amount of interest that you can earn. If, for example, you had $79.38 and the interest rate was 8%, over a 3-year period, that $79.38 would grow to $100. Conversely, if you were going to be given $100 3 years from now and the interest rate was 8%, you could discount that back to the present value of $79.38. So $1 today is much more important and more valuable than $1 in the future. As you prepare for the CPA exam, you're going to find that there's going to be several types of time value problems that you're going to be asked to solve. You can be asked to solve the present value of a single sum in the future. Some problems are going to include uneven cash flows over multiple future periods. You may find problems that have even levels of cash flow for a specified number of future periods, and that's called an annuity. And then there's a special type of annuity where you've got even level of cash flows forever, and that would be called a perpetuity. And of course, you can get a problem that would be a combination of all the above. And just as you'll see these problems asking you to find the present value, these same problems could give you the present value and ask you to find the future value. And so we'll be working on each one of these types of problems as we help you prepare for the CPA exam. So what do you need to know relating to time value of money? Historically, the CPA exam has provided an assortment of time value factors rather than giving you a complete table. Candidates must determine the correct factor to use in a given situation. And the selection, manipulation, and use of correct factors will be tested. Now, the exam will supply you with a present value interest factor, which will show up as PVIF, parentheses, in periods, which is the number of periods, at some interest rate that will be given. And that number will show up as a 0.xxx. So that number will always be less than 1. Conversely, the future value interest factor, which is FVIF, will include the number of periods and the interest rate, and it will equal some number that's greater than 1. It will always be greater than 1. Now, there's a couple of formulas that we're going to go over, but don't worry, you're not going to have to memorize these formulas. The exam will provide you with the interest factors. You won't have to look it up in a table. You will not have to calculate it by memorizing these formulas, but you will have to be able to determine which interest factor you're going to use, because they may give you multiple interest factors and you'll have to select the correct one. So let's start with the present value interest factor. The PVIF is equal to 1 divided by 1 plus R raised to the T. If R is 8% and T is 3 years, that becomes 1 plus 1 plus 0.03 raised to the 3. The present value interest factor then, once you do the math, actually becomes 0.79383, a number that's less than 1. And I told you the present value interest factor will always be less than 1. Conversely, the future value interest factor is the reciprocal of the present value factor. So the FVIF, future value interest factor, is 1 plus R raised to the T. Remember, present value was 1 over 1 plus R raised to the T. So again, if R equals 8% and T equals 3 years, the future value interest factor equals 1 plus 0.08 raised to the 3rd. And when you do that math, you get the number 1.2597, a number that's greater than 1. And future value interest factor will always be greater than 1. So as you saw in the example we just talked about, there were several variables that you were given. There are 4 variables that will be included in every time value of money problem. You will see the number C, which will represent cash inflows or outflows. Excuse me, you'll see the letter C, which will represent cash inflows or outflows. T will represent time period. R, interest rate. And then you'll get an interest factor. If the question is asking for a present value, you'll get a PVIF, which is the present value interest factor. If it's asking for a future value, you'll get a FVIF, which is future value interest factor. For every single problem, you will be given 3 of the 4 variables. It will be up to you to solve for one of the missing variables. Let's look at cash flows for a moment. Cash inflows, T to the T, represent benefits, receipts, cost savings, expected future payoffs, or borrowings. While cash outflows, which would normally show up as a negative C to some time period, represent expected future cost, payments, investments, or lending. Interest rates, which are shown with the letter R, can be looked at and actually would include various different names like yield, discount rate, hurdle rate, effective rate, and it represents a reward for delayed payment. You may hear the question may ask you, opportunity cost of capital, find the opportunity cost of capital. Well, that also could be referred to R. And what that opportunity cost of capital is the return foregone by investing in the project rather than investing in some securities. And lastly, you may hear rate of return offered by a comparable investment alternative, all of which would be used as the interest rate in a particular time value of money problem. So don't just think you're going to see interest rate. You could see any of these terms, and you have to understand that it represents the interest rate or discount rate that you use in your problem. Now, compounding is one of the most fantastic concepts in finance, and it represents the fact that each interest payment is reinvested into your investment. So, for example, you will see annual compounding, which means only one compounding period, and that will be usually the quoted rate or the average percentage rate. And the number of compounding periods when it's annual is N. Now, a lot of problems will ask you to figure out the interest rate when it's semi-annual, quarterly, monthly, or even daily. In that case, you take the APR, the annual percentage rate, and you divide it by 2 if it's semi-annual, 4 if it's quarterly, 12 if it's monthly, and either 365 or 360 if it's daily. At the same time as you adjust the interest rate, you also have to adjust the compounding periods. So if it's a semi-annual compounding, you would adjust the APR by dividing it by 2, but also you would multiply the number of periods by that's 2, which represents the semi-annual compounding periods. Another concept around interest rates is effective annual rate. And the effective annual rate equals 1 plus the annual percentage rate divided by N, which is the number of periods, and that number raised to the N minus 1. Again, N being the number of compounding periods. And let's look at an example. If you assume semi-annual compounding with a 10% average percentage rate, the effective annual rate would therefore be 1 plus 0.10 divided by 2 raised to the 2 or squared, and that would be subtracted from that would be the number 1. So 1.05 squared is 1.1025, and when you subtract 1, the effective rate now becomes 10.25% versus the annual percentage rate of 10%. And that's because of the convention of compounding. The effective annual rate will always be greater than the annual percentage rate unless there's only one compounding period. As you add more and more compounding periods, the effective annual rate exceeds the annual percentage rate. Now that we know about the variables included in a time value problem, and we know how to find the interest factor, let's look at a problem, a present value problem. So the present value equals the present value interest factor times future cash flow. So if the future cash flow is $100 and the time period equals 3 years, and we can earn 8% annually over that 3-year period, it becomes a simple problem. Present value equals the present value interest factor at 8% for 3 years times $100. That interest factor, as we calculated earlier, is 0.79383. I'm not showing you the formula here or talking about the formula only because in the CPA exam, you're going to be given an interest factor, not a formula. So 0.79383 is the present value interest factor that we would multiply by 100 to get a present value of $79.38. Sound familiar? Let's look at future value. the future value of a number equals the present value of cash flows, so the value of cash that you have right now, times a future value interest factor. So let's say if the present value of the cash flow is $79.38 and that the number of periods that you're going to have it for is 3 years and you're going to earn 8% annually. The future value would therefore equal the present value, which is $79.38, times the future value interest factor, which is 1.2597, and that will be given to you. And that, when you do that multiplication, you get the number of $100. So as you can see, the future value is the present value times the future value interest factor. So let's look at a couple of problems now from each of the different types of present value or future value problems that you can expect on the exam. Let's start with the net present value of uneven cash flows. So if you have a project, let's call it Project A, and it's a 3-year project that requires an initial investment of $50,000. The hurdle rate, don't be surprised, remember hurdle rate, interest rate, the hurdle rate for the project is 8%. You could be asked to calculate the net present value of Project A. So some additional assumptions would be, because there are uneven cash flows, that the cash flows occur in year 1 at $20,000, year 2, $30,000, and year 3, $40,000. Now the present value interest factor for 3 years at 8%, we would actually look at the present value interest factor for each year and use it to discount that cash flow back to the present. So the present value interest factor for year 1 is 0.9259, for year 2 is 0.8573, and for year 3 is 0.7938. So when you have a series of uneven cash flows, you multiply that cash flow by the present value interest factor for that time period. And because of the additive principle, where you can add present values to come up with the net present value, in this case, the formula would be a minus cash flow today, or an investment of $50,000, plus the present value of each one of those cash flows. And when you plug in the present value interest factors and multiply it by the uneven cash flows for each of those years, you come up with $25,900 as a net present value. And that, again, what you've done is you've taken the present value of those, the sum of the present values of those uneven cash flows, subtracted it from it, the $50,000 that you had to invest now at time period 0, and you come up with $25,900 net present value. Let's look at one where we've got a lump sum. Jennifer wants to deposit enough money in a CD at the Bank of Wyoming at 4% to have $3,000 in 3 years. Well, the future value interest factor for 3 years at 4% is 1.1249. The present value interest factor for 3 years at 4% is 1 divided by 1.249, the reciprocal, or 0.8890. What amount will Jennifer need to deposit now? I purposely gave you the future value interest factor and the present value interest factor in this problem because the exam may give you multiple interest factors and you'll be required to select the appropriate one. Now, because we're trying to figure out how much Jennifer needs to deposit right now, we're trying to find the present value of some amount that, what is the present value of $3,000 that she's going to want 3 years from now. So present value equals the future value times the present value interest factor, which in this case is 0.8890, PVIF is always going to be less than 1, times the $3,000, which is the future value 3 years from now, and you get $2,667. So Jennifer will have to invest $2,667 today, earning 4% over the next 3 years to have $3,000 3 years from now. Now, we can look at a future value of a lump sum problem. And let's say, for example, David deposits $7,500 in a CD at a bank for 4 years at 6%. The future value interest factor for 4 years at 6% is 1.262477. That number will be provided to you in the problem. And again, they may even show you in the CPA exam additional interest factors so that you'll be required to select the right one. So in this case, we know the future value interest factor for 4 years at 6% is 1.262477. So what will the total of the CD be at maturity? Well, this is a future value problem, and so we'll take the present value of the cash flow, which is $7,500, times the future value interest factor to come up with $9,468.58. So over 4 years at 6%, your $7,500 CD will grow to almost $9,500. Let's make it a little bit more interesting, and let's introduce the concept of quarterly compounding. Well, now let's say Jennifer wants to deposit enough money in a CD at 4% to have $3,000 in 3 years, but now the Wyoming Bank is offering a product with quarterly compounding. Let's say the problem gives you a future value interest factor for 3 years at 4%, which we saw as 1.1249, or you'll have a future value interest factor for 12 periods at 1%, which is 1.1268. Additionally, we'll have a present value interest factor of 4% for 3 periods, which is 0.8890, or we'll have a present value interest factor of 1% over 12 periods, and that number is 0.8874. You can see both present value interest factors are less than 1, and both future value interest factors are greater than 1. So what amount will Jennifer need to deposit now if she goes to the Wyoming Bank and agrees to purchase the CD that has quarterly compounding? Well, first of all, we would use the present value interest factor times the future value, and the interest factor that we would select would actually be the present value interest factor over 12 periods at 1%. The reason why is because of the quarterly compounding. We would take the number of periods and multiply it times 4. So 3 periods times quarterly or 4 compounding periods equals 12. And we would actually divide the discount rate or interest rate by 4. And so we would get 1%. And that's why we selected the present value interest factor, 12 periods at 1%. When you do that math, you get $2,662.20 as the present value that you would need to deposit to get $3,000 at 4% with quarterly compounding. Now let's look at the future value of an amount with semi-annual compounding. David deposits $7,500 in a CD at Wyoming Bank for 4 years at 6%. Interest is compounded semi-annually. That means that you reinvest the interest at the 6-month period, and then you reinvest it again at the end of 12 months. So you've got 4 years, 6% compounded semi-annually. The future value interest factor of 4 years at 6% is 1.262477. whereas the future value interest factor for 8 periods and 3%, you multiplied the number of periods by 2, divided the interest factor by 2 because of semi-annual compounding, and you get a slightly different future value interest factor of 1.26677. Well, what is the total of the CD at maturity at the Wyoming Bank in this problem? Well, you take your $7,500 times your future value interest factor, 8 periods at 3%, and you get 1.26677, and the answer is $9,500.78. So you see here that your $7,500 grows to slightly over $9,500 over that period. The concept of time value of money is a foundational aspect to financial management. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to continue our review on time value of money by focusing on the topic of annuities. An annuity is an asset that pays a fixed sum each year for a specified number of years. Examples of annuities would be a house mortgage, a mortgage loan with equal payments, or it could be an installment credit agreement. But the key there is that there's a fixed sum of payments for each period specified. And there are actually two types of annuities that we're going to look at. There's the ordinary annuity, and the payment occurs at the end of the year or the end of the period. And this is known as annuities in arrear or annuity in arrears. Annuities due is the other type of annuity, and in that annuity, payments occur in advance, aka annuities in advance. Let's start by looking at ordinary annuities or annuities in arrears. As we saw in our discussion about present value in our earlier time value of management review, we look at the same thing. We have to find an interest factor for an annuity. So we look at present value interest factor, PVIFA. For an annuity, the formula would be 1 minus 1 plus R raised to the T, and that divided by R, where T again is the number of payments, R is the discount rate. Now what you're going to see on the exam, you won't see this formula. You will see PVIFA, the number of periods represented by T, and R, the discount rate, and then you'll get some number. And again, on present values for annuities, here the number will be greater than 1 and will vary in size depending upon how many years the annuity goes out for. So in the present value of uneven or the present value of a lump sum, you had the interest factor was always less than 1. That will not be the case in the present value of annuities interest factor. So again, to come up with the present value, you take the present value of an annuity in arrears equals the payment, which is a lump sum, which would be the same amount each period, times a present value interest factor, PVIFA, for a certain number of periods at a certain rate. So let's look at a problem on present value of an ordinary annuity. Let's go back to Jennifer. Some of you might know Jennifer. I know a Jennifer, so that's why I continue to go back to Jennifer. Jennifer just received a 4-year automobile loan, and this was her first car loan. The terms of the agreement require monthly payments, excluding taxes and insurance and so forth, but the monthly payments is $450. The annual percentage rate, that's the rate that's quoted on the loan, is 12%. Some additional information that you need to know is that the payments are due at the end of each month, so it's an ordinary annuity. The present value interest factor is for 4 periods at 12% equals 3.0373. The present value interest factor of annuity for 48 periods at 1% and that equals 37.9740, or you have the present value interest factor for 48 periods at 1%, and that equals 0.553676. What is the starting balance of the loan? So to solve this problem, first of all, you have to select the correct present value interest factor. Because this loan has monthly payments, what we have to do first is we have to take the APR and divide it by 12 to come up with the adjusted interest rate or discount factor that we're going to use. And at the same time, we have to multiply the number of periods by 12 to come up with the adjusted number of periods. So the present value interest factor of an annuity that we're going to be using will be 48 periods at 1%. And all you do is the same thing as you had done on other present value problems. You multiply the payment or cash flow, in this case $450, times the 37.9740 to come up with $17,088. And that's the amount, the starting amount of the loan that Jennifer is going to take out in order to have a $450 payment for 4 years. Now, the future value of annuity works similarly, but the formula is, of course, slightly different. The future value interest factor of annuity, the FVIFA, equals 1 plus R raised to the T minus 1, and that divided by R, where again, T equals the number of payments, R equals the interest rate, and you will see FVIFA for T periods at R interest rate. The formula for that would be future value of an annuity in arrears would be the payment times the FVIFA, future value interest factor of an annuity, at T periods raised to an R interest rate. The other way you would see this is a little bit of a twist on solving the problem, is first you would take the payment and you would find the present value interest factor of annuity, and then you would take that and discount it back to the out to the future. So you would first find the present value of that stream of flows, then multiply it by a future value interest factor to come up with the future value of the annuity. The first way was one step where you use the future value interest factor of an annuity factor. The other way is you do two steps. First, you find the present value of that annuity stream, then you multiply it by the future value interest factor, and you come up with the future value of that annuity. Let's look at a problem on future value of an ordinary annuity. David invests $502 at the end of the next 9 years at an interest rate of 13%. How much will he have at the end of the period? Well, the problem, like you'll see it in the CPA exam, you might get multiple or several interest factors, and you have to select the correct one. In this case, we know that the interest rate is 13%. We know that it's 9 periods, and we're trying to find the future value of an ordinary annuity. So the FVIFA for 9 periods at 13% is 15.4157. So you take the payment of $502, multiply it by the future value interest factor of annuity for 9 periods at 13%, or the 15.4157, and you get $7,738.68. And so that's how much the future value of that annuity is. The alternative approach, again, you would find the present value of 9 annual payments and then calculate the future value of that amount at 13%. So in that case, you would use the present value interest factor of an annuity for 9 periods, 13%, and then multiply it by the future value interest factor and that's how you would get the same $7,738.68. You can solve the problem either way. Your job will be to figure out what's the best way given the information that's provided. Now let's make a slight modification to our annuity, and let's say that the payments occur in advance. So now we'll be looking at an annuity due, which is annuity in advance. So the first step would be to modify the present value factor used for an ordinary annuity. So the present value interest factor of an ordinary annuity, you adjust it by, instead of having T periods and R as your interest rate, you go T minus 1 periods. So the present value interest factor of an annuity in advance or an annuity due, PVIFAA, equals your present value interest factor of an ordinary annuity, but you adjust it to T minus 1 periods, and the interest rate continues to be R. So the present value of an annuity in advance, the formula looks like payment times present value interest factor of annuity, T minus 1, with R as your interest rate, plus you add a payment on the end. Or you can look at it as the present value of an ordinary annuity times 1 plus R, times 1 plus R. So that would be 1 plus the interest rate. So there's two approaches, and again, which approach you use will depend upon what information is provided to you in the problem. One thing to remember is that the present value interest factor of annuity is always greater than the present value interest factor of an annuity in advance is always greater than the present value interest factor of an annuity. This is always true because money received sooner, you're getting your payments in advance, is more valuable than money received later in the future when you're getting your payments in arrears or at the end of the period. Let's look at a problem for present value of an annuity due. Mr. Smith can make annual mortgage payments, not including taxes and insurance, of $4,800 a month. The interest rate is 8% and the mortgage term is 20 years. The other assumptions that you're giving is the present value interest factor of an annuity for 20 periods at 8%, which is 9.8181. You're also given the present value interest factor of an annuity at 19 periods at 8%, and that equals a slightly lower number of 9.6036. How much can Mr. Smith borrow making 20 equal payments at the beginning of the year? I had mentioned monthly payments in the question, but it's actually annual payments. So how much can Mr. Smith borrow making 20 equal payments at the beginning of the year? Well, the solution is we have to find the present value of an annuity in advance, which equals the payment, and in this case $4,800, times the present value interest factor of annuity in advance, and we know that we have to adjust the present value interest factor of annuity, the PVIFA, 1 period fewer in order to come up with the PVIFAA, and then at the end we add an additional payment. So when you go through that exercise, you get 4,000 times 9.60369. You use the present value interest factor of annuity for 19 periods, not 20 periods, plus you add to that one extra payment of 4,800, and you get 50,897.28. So that is the beginning amount that Mr. Smith has to borrow if he wants $4,800 payments once a year at 8% interest. Let's look at a future value of an annuity due, and to come up with the future value of an annuity due in advance, you modify the future value factor for an ordinary annuity, so you get FV FIFAA, which is the future value of an annuity due or future value of annuity in advance. You take the future value interest factor, FVIFA, and you add a period to it. So instead of taking it for T periods, you take it for T plus 1 periods at the interest rate of R. So the future value of an annuity in advance is the payment times the future value interest factor of annuity, the FVIFA, adjusted for an additional period, so T plus 1, at the quoted rate, and then you subtract the payment off of the end of that. So let's look at a problem on future value of an annuity due. Mr. Jones plans to save $300 a year for 3 years, and he's going to be making $25 payments at the beginning of each month. The savings plan yields 24%. We're given the future value interest factor of annuity for 36 periods at 2%, and that equals 51.9949. We're also given the future value interest factor of annuity for 37 periods at 2%, and that equals 54.0343. So how much will Mr. Jones have at the end of 3 years? Okay, he plans to save $300 a year by making $25 payments. So when we look at this problem, we say, what is the future value of annuity in advance if our payment is $25? We take the future value interest factor of annuity, we adjust it by adding 1 period, so instead of T periods, it's T plus 1 periods, and at the end, we subtract $25. So that becomes the $25 times the 54.0343, which is the future value interest factor of annuity for 37 periods, not for the 36 periods, but 37 periods. And the reason why it was 37 periods is, again, we have monthly payments. We were looking at 3 years, which was 12 periods, times the 12 payments per year, which gets us to 36, but we have to add an extra period, minus the $25, that extra payment. And when you do the math, you get $1,325.86. So the future value of annuity in advance, in this case, would be $1,325.86. Now there's a special type of annuity that you'll see on the exam, which is called a perpetuity. And a perpetuity is a security or asset that offers a fixed income or cash flow for each year, but it goes out indefinitely. And so the perpetuity formula through calculations turns out to be the present value of a perpetuity is C, which is the fixed cash flow, divided by R, which is the rate of return that you're going to receive on that perpetuity. Now, if you don't have the rate of return, but they tell you what the present value is, you can figure out the rate of return by saying the rate of return on a perpetuity is just C divided by present value. So expect to be asked how to calculate the present value of a perpetuity or how to calculate the return of a perpetuity. Let's look at a problem. Jennifer wishes to endow a chair in counseling at a school of social administration. The rate of interest is 7%, and her aim is to provide $50,000 a year in perpetuity. What amount will she need to set aside today in order to have the $50,000 a year into perpetuity? Well, we know our formula is the present value of a perpetuity will be the amount of cash flows that we expect year over year over year into the future, which is $50,000, and we divide it by the 7%, which is the interest rate that we expect to earn, and you get $714,285.71. And that is how much Jennifer will need to put right now in order to generate $50,000 a year into perpetuity. Jennifer, you better start saving. Now, there's a special type of annuity also, which would be a growing perpetuity. And a growing perpetuity is a security or asset that offers a series of cash flows that increase each compounding period at a constant rate forever. So if we look at our perpetuity formula that we just discussed, the present value of a growing perpetuity equals the cash flow in the next period divided by R minus G, where G is the growth rate. And so if you know C0, you can calculate C1 by just taking C0 times 1 plus G. So don't be surprised or alarmed if they give you C0 and you're trying to solve for a perpetuity that it has constant growth, because you could calculate C1 by multiplying 1 plus the growth rate times C0. Let's look at a problem. The present value of a growing perpetuity. In this case, Jennifer wishes to endow a chair in counseling at the School of Social Administration. The rate of interest is 7%, and her aim is to provide $50,000 a year into perpetuity. The only difference this time is that she wants to cover inflation. So the payment must grow by 4% a year if your expected inflation is 4%. What amount will Jennifer need to set aside today in order to have $50,000 into a year into perpetuity when you know that inflation is going to be 4% a year? Well, this is a perpetuity with growth problem. You take the cash flow of 50,000 divided by 7% growth rate, interest rate minus the 4% growth rate, and you get 50,000 divided by 0.03, and that equals 1,666,666.70. So $1,666,667.70 is the amount that Jennifer would need to set aside today to complete the endowment. Let me illustrate annuities in a different way, and I'm going to show it to you graphically. When you think of annuities, you can look at annuities being the difference between perpetuities. If you have a perpetuity A, let's say, that starts at period 0 and obviously runs into infinity, that formula we talked about is just the cash flow over R, and it would go from now into infinity. But now if you look at another perpetuity, but it doesn't start until period T, what you first have to do is you have to find the formula for a perpetuity, which is C over R, but then you have to discount that back to the present by taking 1 over 1 plus R raised to the T and multiplying it by that perpetuity to get it into present value terms. Remember, that perpetuity didn't start until time T. The annuity, on the other hand, let's say it starts in time 0 and runs to period T. What you can do is you can take the difference between the two perpetuities to come up with the annuity. Let's look at a problem. Rick won $160,000 in a state lottery. He will receive an immediate payment of $30,000. Then he'll get 3 annual payments of $30,000 at the end of each year and a payment of $40,000 at the end of the 4th year. Now, Rick only has the following time value factors. That would be, he'd be given the ordinary annuity factor with 3% at 3 periods at 8%. He might be given an ordinary annuity factor at 4 periods at 8%. He could also be given annuity due, which is the present value interest factor of annuity in advance at 4 periods at 8%. Or he might be given the present value interest factor of annuity in advance for 5 periods at 8%. He has to select the appropriate one for this problem, because Rick is trying to determine what is the present value of the payments discounted at a rate of 8%. And see, you've only been given annuity due factors. So this makes you really think about how do I select the appropriate factors. Well, to solve this problem, you have to look at it as the combination of the present value of an annuity plus the present value of a single sum combined. Because you're going to be looking at payments from periods 1 through 5, and in this case that would be $30,000 occur in each of those 5 periods, times the present value interest factor of annuity in advance for 5 periods at 8%. You're going to add to that the payment in period 5 times the present value interest factor of annuity in advance minus the present value interest factor of annuity in advance for 4 periods. And the reason why you do that is because you're trying to find out what a present value interest factor would be for period 5. And you can do that by subtracting the 2 present value interest factors of an annuity for 5 period and take from that the present value interest factor of annuity in advance for 4 periods. So let's go through the math. If you take 30,000 times the present value interest factor of annuity in advance for 5 periods at 8%, that's 4.312127. That number becomes 129,364. You add to that the present value of that lump sum of $10,000, and you multiply that times the difference between the present value interest factor of annuity in advance for 5 years at 8% and the present value interest factor of an annuity in advance for 4 periods at 8%, and you get 0.73503. And if you had the table, you would see that's the present value interest factor for 5 periods at 8%. That number becomes $7,350. When you add the 2 present values together, which you know we can do because of the additive principle, you get $136,741. So as I mentioned before, in the CPA exam, you're going to be provided with the time value factors. You're going to be provided with information on interest rates and cash flows. And your job will be the selection, manipulation, and use of the correct factors. Good luck. Welcome back to the Financial Management Review. My name is Ron Harris. We're going to talk about bonds. We're going to look at a description of bonds, and we're going to see how they've been priced or how they're valued. We'll look at yield to maturity, and we'll also look at a special type of bond, the zero coupon bond. Bonds represent the right to receive any interest payments specified in the bond and the return of principal upon maturity. Related topics that you need to be aware of when you're talking about a discussion on bonds is par or face value. You have to know what the coupon rate is, yield to maturity, which also could be referred to as internal rate of return, coupon payments, which is the face value times that coupon rate, and maturity date or term to maturity. These are terms that you have to be familiar with. Cash flows of a bond are fixed at issue. So when the bonds are sold or issued, the cash flows that will occur are fixed. And the value of the bond is inversely related to interest rate that investors demand for that bond. So this inverse relationship will say as interest rates rise, the value of the bond falls. And as interest rates fall, the value of the bond rises. When you're pricing bonds, the value of bond is the present value of the expected future cash flows on that bond, discounted at the interest rate that is appropriate for the riskiness of the bond. So let's look at a formula for the present value or price of a bond. The price of a bond is the present value of the sum of coupon payments plus the present value of the face value. because there are actually two cash flows that you get when you have a bond. You get periodic coupon payments, plus you get the return of your principal at maturity. So the formula looks like this. It's the sum of coupon payments divided by 1 plus r raised to the t, plus the face value divided by 1 plus r raised to the t. How you will see that on the CPA exam, it will be PVIFA of at the t periods at r% plus the present value interest factor of a lump sum for t periods at r%. And coupon equals the coupon expected in period t. Face value is the value of your bond, normally in denominations of 1,000. R is the discount rate for your cash flows, and T represents the number of coupon payments. The best way to illustrate this would be with a problem. Now, the bonds are normally priced where they pay semi-annual coupon payments. So we're going to look at a problem that has semi-annual payments. At the end of 2012, David invested in a 4% 2018 U.S. Treasury bond. That's a Treasury bond that's maturing in 2018. The bond has a face value of $1,000. The short-term U.S. Treasury bonds rate in late 2012 was offering a return of 6%. So the return on a comparable asset is different than the coupon rate on the bond that David is buying. So the coupon payments are made semi-annually. You'll get a couple of different interest factors, but expect to get something like the present value interest factor of an annuity for 6 periods at 4%, the present value interest factor of annuity for 12 periods at 3%, the present value interest factor for 6 periods at 4%, or maybe even the present value interest factor for 12 periods at 3%. On the exam, you can expect to get multiple interest factors because you'll be required to select the correct one. Again, let's look at the problem. David is investing in a 4% bond that's going to mature in 2018. So the coupon rate is 4%. The face value is $1,000, but the yield on comparable securities that are being issued now is 6%. So what is the price that David has to pay for the bond? Well, the appropriate present value interest factor that he should use to multiply by his coupon payments will be the one that's for 12 periods at 3%. 12 periods at 3%. The face value will be multiplied by a present value interest factor for 12 periods at 3%. So when you do the math, you take $20 as the coupon payment, and you say, why $20? You take the $1,000 times 4%, you get $40, and you divide that by 2 for semi-annual. So $20 times the present value interest factor of annuity for 12 periods, 9.9540, plus the present value of the lump sum, $1,000 at 0.7014, and you get a price of $948. So you see that this bond is selling for less than face value. And the reason why is no investor would pay the full $1,000 for that bond when they could go out and get an interest rate higher than the rate that that bond is paying. So the bond ends up selling at a discount. Let's look at another semi-annual bond. This time, Jennifer is considering investing in a 7% 10-year U.S. Treasury bond. The bond has a face value of $10,000. Short-term U.S. Treasury bonds currently yield 5%. So we look at this problem, we say, okay, what are the coupon payments that are going to have to be made annually? we also look at what is the correct present value interest factor of an annuity that we should select, or should we select a present value interest factor? Not an annuity, but just a present value interest factor. Remember, a bond has two cash flows, an annuity, which represents the coupon payments, and a lump sum, which represents the return of the at maturity. So what is the price that Jennifer will have to pay? Well, in this case, Jennifer is going to take the coupon payments, which is $350. How did we get the $350? We took the $10,000 face value times 7%, and we multiplied it, which is $700, but we multiplied that by 2 for 20 periods because we have semi-annual payments. So $350 times the present value interest factor of annuity for 20 periods at 2.5%. We took the 5% coupon rate and we divided it by 2 to get 2.5. Then the lump sum component is the $10,000 face value times the present value interest factor, because we want to get the present value of a lump sum for 20 periods at 2.5%. And when we look at that, we come up with $5,456.21, which represents the present value of that annuity. And we take $6,102.71 when we calculate the present value of the lump sum, for a total of $11,558.92. You have to be mindful that we use the 5% yield as our discount rate because it's the current rate being paid in the market. And you see that the price of this bond is actually higher than the face amount because the bond is yielding a higher amount than the yield that's currently being offered in the market. So the seller of this bond would not sell it to you for less because it's more valuable because it has a higher return. So therefore, you end up paying a premium for this bond. Now let's look at yield to maturity, and that is the discount rate which causes the price of the bond to equal the present value of its cash flows. It reflects where interest rates are in the economy today. So when the price of the bond is less than the face value, then that yield to maturity is greater than the coupon rate. And we saw that in the last problem. The yield to maturity will always be expressed as an annual value. Now, I mentioned earlier that we were going to look at zero coupon bonds. Now, zero coupon bonds are priced a little differently. Zero coupon bonds, the present value of future cash flows, represent the price of the bond, just like in a normal bond. However, there's only a single cash flow for a zero coupon bond, and that cash flow is the return of the face value at maturity. The price is always less than the face value, so it's always going to be selling at a discount, and the interest that you earn will be the difference between the maturity value, the face value at maturity, and the purchase price. There's no annuity, just a single cash flow. Again, the interest is the difference between the price paid for the bond and the face value. So the formula for that would be face value divided by 1 plus r to the t, and that becomes the face value times the present value interest factor for t periods at r%. It's just like figuring out the lump sum component of a normal bond. So how are bonds quoted? Bonds are quoted either as discount, par, or premium. And we looked at two examples that show bonds that were priced at a premium and a discount. And on the discount, remember, the price was less than the face value. So on a $1,000 bond, it might be priced at $900, and that would represent a discount. If it was selling at par, that's where the price equals the face value, and that purchase price would be $1,000. And then lastly, as a premium, the price would be greater than the face value. Thank you for your interest. That ends the first section on bonds. Thank you. Welcome back to the Financial Management Review. My name is Ron Harris. We're going to continue our review of bonds. We're going to cover several topics related to bonds, including interest rate risk, duration, which is a measure of the interest rate risk. We're going to look at the types of bonds, and we'll wrap it up by looking at the term structure of interest rates. The value of a straight bond is determined by the level of and the changes in interest rates. As I mentioned before, there's an inverse relationship between interest rates and bond values. As interest rates rise, the value of the bond will decrease. As interest rates decrease, the value of the bonds will increase. Any increase in interest rates will lower the present value of the stream of expected cash flows. And remember, there are two cash flows related to bonds, most bonds. There's the stream of coupon payments, and then there's the lump sum return of principal at the maturity. In zero coupon bonds, there's just a single cash flow, which is the return of interest of the principal at maturity. The effective interest rate changes on bond prices will vary, and they'll vary because of three main factors. One, the maturity of the bond. Two, coupon rate of the bond. And three, the yield to maturity. Now, bond sensitivity will vary depending upon which of these factors you're looking at. So, for example, the longer the maturity of a bond, the more sensitive it is to changes in interest rate. Conversely, the shorter the maturity, the less sensitivity exists. With respect to coupon rates, the lower the coupon rate, the more sensitive the bond is to changes, and the higher the coupon rate, the less sensitive it is to changes. And then lastly, the yield to maturity. The lower the yield to maturity, the more sensitive the bond is to changes in interest rates. And finally, the higher the yield to maturity, the less sensitive bonds are to changes in interest rates. So instead of having to look at each one of those factors individually and determining, is it more or less sensitive, there's a measure called duration that could be used to determine and measure the sensitivity of the bond price to changes in interest rates. And it consolidates all three of those factors, maturity, coupon rate, yield to maturity, all into one measurement. It's a weighted maturity of cash flows on the bond. The weights are based on two things, the timing and the magnitude of those cash flows. And the formula is actually called the Macaulay duration, and it really just is based on yield to maturity as its primary variable. Now, the larger and earlier cash flows are weighted more than the smaller and later cash flows. The higher duration of a bond, the more sensitive it is to changes in interest rates. Other duration factors would include, for coupon bonds, duration is less than maturity. For zero coupon bonds, duration equals maturity. So again, one measure, duration, to measure the sensitivity of the price of the bond to changes in interest rates. Now, some bonds have special features, and these features can be added to make the bonds either more or less valuable. Two of those features would be convertibility and callability. Now, a convertible bond can be converted into a predetermined number of shares of stock at the option of the bondholder. That's a critical point to remember. It's the option of the bondholder on a convertible bond. And as a result of this option being given to the bondholder, the conversion options will help lower the interest rate paid on the bond. So the issuer is able to issue those bonds at a lower rate because they're offering this special feature of convertibility to the bondholders or the buyer. Convertible bond yields, therefore, are less than the yields on non-convertible bonds. The conversion becomes a more attractive option as stock prices increase. And the conversion becomes a more attractive option as stock prices become greater than the value of the bond. Now, the conversion ratio is a measure of the number of shares of stock for which each bond may be exchanged. The market conversion value equals the current value of the shares for which the bonds can be exchanged. So there's a conversion premium. If there is a conversion premium, it would equal the excess of the bond value over the conversion value of the bond. Bond value will be greater than conversion value when the issuer does poorly. So if the issuer is performing poorly, its stock price isn't going to increase, and you probably will never get conversion. Let's look at an example of convertible bonds. Now, you've got a convertible bond with a par value of $1,000. The market value of that bond is $1,300, and the current stock price is $25. The company will establish a conversion ratio, and that will be done up front. And let's say it was 50 shares. So you can convert your bonds into 50 shares of the company. And let's say the conversion price is $20. Well, the way you get that conversion price is you take the par value and you divide it by the conversion ratio. So in this case, you take $1,000 divided by 50, so the conversion price becomes $20. Next, you take that conversion ratio and you multiply it by your current stock price. So you take the $20 times the current stock price of $25, and you get a market conversion value of $1,250. Make sure you're familiar with how convertible bonds have conversion prices, they have conversion ratios, and how to come up with the market conversion value by taking the conversion ratio times the current stock price. But the price of a convertible bond is a combination of the same way we priced a straight bond, but the only difference is there's a value to that conversion option. Now, you're not going to be expected to calculate the value of the conversion option, but the value of the conversion option is the value of the bond if converted immediately. Again, the conversion value is the value of the bond if the holder converts it immediately. The value of that conversion option is estimated using what's called the Black-Scholes options pricing model, which is beyond the scope of this review. But just remember that that component, the conversion option, is a part of the price of a convertible bond. Now let's look at callable bonds. A bond that gives the issuer the right to call back the bond and pay a fixed price for it at the issuer's option. This one is at the issuer's option. The convertible bond was at the purchaser's option, the bondholder's option. The callable bond is at the issuer's option. If interest rates decline, the firm can refund the bond at the fixed price, which will usually be below market value. The initial period is normally call protected. So for a certain amount of time, the issuer is not able to call the bonds. That gives protection to the bondholder. Now, how do you value a callable bond? Again, you look at the value of a straight bond, and that is the present value of the coupon payment cash flows plus the present value of the face value at maturity. But in this case, you subtract the value of the call feature. So with a convertible bond, you added the call premium to the straight bond value. In the case of callable bonds, you subtract the value of the call feature. Some characteristics of a callable bond would be the yield is greater than that yield of a non-callable bond, and the call feature can be valued using an option pricing model. So you will not have to calculate the value of the call feature. Just be aware that it's subtracted from the straight bond value in order to get the value of a callable bond. So when would bonds be called? If interest rates fall, you'll see bonds calling, because then the company can reissue new bonds at a lower rate. If your bond rating increases, that means your ability to repay those bonds has increased, and therefore you'll be able to issue at a lower rate. So you may see the bonds being called then. And then lastly, the bonds may be called if you try to remove some unattractive covenants that are part of the bond indenture. So 3 reasons why you can expect a bond to be called. You should know each one of those 3. One of the important things about understanding bond and bond valuation is understanding what determines interest rates. And there are 3 primary factors that determine interest rates. There's the default premium, which relates to the default risk of the bond issuer. There's the maturity premium, which says there's a difference between longer and shorter term default-free rates. Usually the longer the maturity, the higher the rate, and vice versa. And lastly, short-term default-free rate. And this is captured in every bond pricing, and it looks at the overall level of rates in the economy. One of the ways that we look at that is through what's called the term structure of interest rates, which relates the time to maturity to the yield of maturity. And the shape of the yield curve, which actually is a collection of all the yields of bonds of similar grade across time and at various yields to maturity. And what you'll see is there's either a upward sloping yield curve, which is considered a normal yield curve, a flat yield curve, or an inverted yield curve. You will seldom see an inverted yield curve. But the shape of the yield curve is determined by a couple of factors. And one is it's determined by the expectations of future short-term interest rates and inflation. If there's expected inflation, you're going to see a yield curve that's got more of a normal shape. If we've got a situation of deflation, you're going to see a yield curve where short-term rates are actually higher than long-term rates, and you'll see an inverted yield curve. The yield curve is also influenced by supply and demand for short-term and long-term money. And then lastly, it's influenced by the greater risk of long-term lending and the liquidity premium that gets added to a longer-term loan. Thank you for your interest, and we'll continue our review of financial management in our next session. Thank you. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to continue our review of bonds by looking at how bonds are quoted. We'll look at a bond indenture, and we'll talk about bond ratings and reviews. How are bonds sold? Well, there's 3 markets for bond, 3 main markets for bond. There's the primary, the secondary, and then there's auctions. In the primary market, bonds are sold or issued for the first time. And bonds are brought to market by an underwriter, who is the one that actually sells the bonds. You'll hear the term a bond underwriter. These are usually large investment banks. The secondary market is where bonds that have been previously issued are resold again after the initial offering. The secondary market, bonds are sold through a huge network of independent dealers. And then lastly, the auctions are primarily used for federal government bonds, and they are sold to dealers and to individuals through that auction process. When bonds are quoted, there's usually a bid price and an ask price. The bid price is the price that the dealer is willing to pay for the bond, where the ask price is the price at which the dealer will sell a bond. It's an important measure to look at the spread between the bid and the offer or ask, and that spread is a function of liquidity. So the bid price is the price the dealer is willing to pay. The ask price is the price the dealer is willing to sell a bond for. Bonds are sold, purchased and sold over the counter. So there's no central exchange or place where you could go and walk into a store or a bank or an investment firm and buy the bonds over the counter like that. Directly through a teller. The bonds are bought and sold over the counter. There's no central place or exchange for bonds. Now, bonds, because you normally pay semi-annual interest, sometimes when you're pricing the bond, you have to include the accrued interest from the last interest payment. And when that happens, the price is considered to be a dirty price. So that price would include accrued interest from the last interest payment date. When you get a clean price quote, that's when the price of the bond excludes any accrued interest since the last payment date. So there'll be a clean price and a dirty price. Prices of bonds are normally quoted as a percentage of face value, and we mentioned that briefly earlier. So if a bond is quoted, if it's a par value, then the bond would be quoted at 100% or maybe 100. Even though most bonds are sold in denominations of 1,000, you'll still see the 100, which would be 100% if it's par. If the bonds are sold at a premium, you may see 105% or the bonds being priced at 105. And then lastly, if it's sold at a discount, you would say 95% if the bond sold for $950, or it would go at 95. But again, most bonds are sold in denominations of 100, but the bonds are quoted as a percentage of face. If you saw the headline that read, the 2-year U.S. Treasury jumped 8 basis points to 2.12%, you may wonder, well, what does that all mean? Well, bond quotes are many times expressed as yields, and that's so that they can have easy comparisons. So in the case of this headline, the 2-year U.S. Treasury jumped 8 basis points to 2.12%, would tell you that the 2-year Treasury bond is the bond being traded, and it jumped 8 basis points, and in bond speak, a basis point is 1 over 100, or 0.0001, which is 0.01%. And so a point is 1%. So the bond going up 8 basis points to 12.12% says that the yield to maturity has gone up 8 basis points, and again, it's the yield to maturity now at 2.12%. Now, how do they keep it all together? How do they know what the price is, what the coupon payments should be, the maturity? Well, there's a document that's required by law called a bond indenture. And that bond indenture is a legal document that provides the coupon rate, the maturity date. It includes covenants, either positive or negative, and that can include financial covenants, which would require you to have certain levels of working capital or certain levels of equity compared to debt. And also it would name a trustee who is really the overseer for the bondholders. So that's a bond indenture. Now, bonds get ratings, and the rate represents the ability that the issuer has to meet indenture terms. And there are 3 primary rating agencies: Moody's, Standard & Poor's, and Fitch. And there are others, but these would be the primary 3 rating companies. And let's look at how Moody's and Standard & Poor's would rate. Both have 5 categories of ratings going from AAA to BB. In the case of Moody's, it would be BA. In the case of Standard & Poor's, it would be BB. And each one of those ratings in between, and the ones at the top and at the bottom, can be modified to give a level of intensity to that rating. So, for example, if you're a AAA 1, then that rating is a little bit stronger than a AAA 3 under the Moody's ratings. Under the S&P ratings, your AAA will be a AAA plus, or AAA minus, or just a AAA, which gives a level of intensity or comfort to the bondholder if you've got a plus versus a minus in one of the ratings. The top 4 ratings for either Moody's or S&P, represent investment grade ratings, versus the bottom rating for Moody's or S&P represent non-investment grade ratings, or in terms you may have heard, or junk bonds. So a BA for the Moody's rating would be considered non-investment grade. A BB and below would be considered a non-investment grade for Standard & Poor's. The lower the rating, the higher the probability of default. And from time to time during the life of the bond, there could be periodic reviews by these rating agencies to either upgrade the rating or to downgrade the rating. All of this is for the protection of the bondholders. Thank you. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to cover in this session inflation and how the impact of inflation will determine how you do your long-term or retirement planning. Inflation represents the drop in purchasing power, and it's most often measured by a change in the Consumer Price Index, or CPI. When you're calculating the impact of inflation, you are actually looking at a future value calculation. Let's look at a quick example. If we had 4% inflation, or expected 4% inflation over the next 10 years, we would set up a future value problem that would say, let's say if we had $100, that the future value equals the $100 times 1 plus the expected inflation rate raised to the 10th, because we're talking about over a 10-year period. So in the problem that you'll see in the exam, you'll be given the future value interest factor for certain periods of time. In this case, you would look at the future value interest factor for 10 periods at a rate of 4%. You multiply that times 100, and you get $148. So $100 of goods today will cost $148 10 years from now at 4% inflation. Whenever you're trying to understand inflation and its impacts, there are really 4 key terms you must know. If you get this right, you'll have no problem working on or solving inflation-related problems. First, you have to know the nominal cash flows, and nominal cash flows represent the actual dollars to be received. Not purchasing power, but actual number of dollars received. Real cash flows, on the other hand, are expressed in terms of time zero, or today, and it represents purchasing power. At time zero, nominal cash flows will equal real cash flows. The third term that's important is nominal interest rates, and that represents unadjusted rates, unadjusted for inflation. Real interest rates are adjusted for inflation. So those 4 key terms you must have a good understanding of. Let's look at an example on inflation where David wants to purchase a special laptop, and he wants to purchase it 1 year from today. He has $1,000 to invest for a year at 7%, and inflation is expected to be 3%. So the price of the laptop today is $1,000, but with that 3% inflation, in 1 year, the laptop price is going to go up to $130. $1,030. So it's the 1,000 times 1.03. Now, will he be able to pay for that laptop since he only has $1,000 today? Well, if he invested today at 7%, he will end up with $1,070 1 year from now, but that will be in nominal cash terms. That will be the number of dollars he has. But in terms of purchasing power, what he will have is a little less than that. And the way you come up with the real interest rate is you actually take the equation, which is called the Fisher equation, which is 1 plus the real rate equals 1 plus the nominal rate divided by 1 plus inflation rate. So when you do that math and you have 1 plus the nominal rate, or 1.07, divided by 1 plus the inflation rate of 1.03, and then you subtract the 1 to isolate real rate, and the answer is 3.88%. So when you try to figure out what your purchasing power is, you say your present value of $1,000 times your real rate of 1.0388, and you come up with $1,038.80. And that's your real purchasing power, and David will have enough to buy that special laptop a year from now. When you're talking about retirement planning, inflation has a major impact in how much money you have to save now in order to have enough to hit your investment goals in the future. So let's look at an example where we've got a young lady named Jennifer, and she's 25 years old, and she wants to retire at age 65. And at 65, she wants a lifestyle that's based on $60,000 per year. $60,000 of purchasing power per year. Now, Jennifer hopes to live to be 100. So that means that she will have to have $60,000 a year for 35 years, which would be 100 minus the 65. Inflation is expected to be at 2% over that time, and the nominal rate is expected to be 7%. One thing to keep in mind as we go through this problem, we're going to avoid mixing nominal and real when we're dealing with the inflation problem, and I'll remind you of that as we go. So step one, I have to calculate the real interest rate, and we're going back to the Fisher formula, and we know we have to take the nominal interest rate divided by the inflation, and then subtract 1 from that, and we come up with 4.9% using the Fisher equation, and that's going to be the real interest rate. So now we want to calculate the amount in real dollars purchasing power that Jennifer's going to need at retirement. So our problem here is an annuity problem. And so we learned during the time value of money sessions how to calculate the present value of an annuity. In this case, we're looking at a 35-year annuity for $60,000 of cash flow in real dollars per year. And so that problem, we structure it by saying present value equals $60,000 times the present value interest factor of an annuity for 35 years at the real rate of 4.9%. When you do the math, you end up with $994,973.73. The next step that we may want to do is find the nominal dollars needed to get that $994,997.73 in real dollars in time of retirement. So what are the number of dollars that we need right now that will grow into our retirement number? And that becomes a future value. That would say, and I made a mistake there. I said that it would be the dollars we need right now, but it's actually the dollars we're going to need in the future in nominal terms that will be equated to the $994,997 of real dollars. And that becomes a future value problem. So all you do there is you say future value equals your present value times the inflation rate raised to the T. And in this case, we're talking about over 40 years. So if we have $994,973.73 today, we multiply that by the future value interest factor for 40 years at 2%, and we get $2,196,941.46. That represents nominal dollars that we would have to invest in order to get $994,973.73, which would give us our $60,000 a year. Now, let's talk a little bit about savings and as it relates to that 2.19 million that we just identified. How much does Jennifer have to save annually to have $2,196,941 when she retires in 40 years? Now, remember, that number is a nominal number. So this, again, is a future value of an annuity problem where R equals 7%, T equals 40 years. The formula is future value equals your cash flow or your present value times your future value interest factor of annuity over that time period and at that nominal rate. So to solve this problem, we already know what the future value is. It's $2,196,941. What we're solving for is C, because the factor is going to be given to us, and that future value interest factor happens to be 199.6351. So when you do the math and solve for C, Jennifer is going to need to invest in nominal dollars $11,004.79. Now, when you're younger, trying to invest $11,000 a year may be a little difficult when your income levels really isn't that high. So if we look at this and we say, well, if we know inflation is going to be 2%, maybe we should try to invest a smaller amount at first. It's going to grow at 2% every year. We'll increase our savings by 2% every year to come up with what will be the real dollars needed, and it'll spread the pain over a longer period of time instead of us having to save the $11,000 every year starting from year one. Because I'm going to assume that Jennifer will make more money in year 2 and 3 and 4 and so on. And so let's see how we could cut her savings down in the early years and just grow it at the inflation rate. So if Jennifer needed to save $994,973 in real dollars when she retires in 40 years, what could she invest at? What could she invest every year to get her there? Well, this is another future value of an annuity problem. This time we'll use the real interest rate, which is 4.9% over 40 years, with the future value being $994,973. We'll multiply the cash flow that we need every year times $117.89224, and we get $8,493.69. So instead of saving $11,000 in nominal dollars, if Jennifer saves $8,439.69 this year and then increases that amount each year by 2%, in 40 years, she will be up to the $994,973 in real dollars that she needs. Savings doesn't have to be as overburdening as you would think if you just take it a little at a time and if you never mix real and nominal. Thank you. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to talk about stocks during this session. One of the things we need to start off with is some basic definitions, and then we'll go into the beginning discussions around how you value stocks or how do you price a stock. Common stock, sometimes referred to as just stock and also its equity, represents ownership shares in a corporation. Now, the ownership can be in a publicly held company like a GE or Apple or Microsoft, or it could be shares in a closely held or private company like High-Tech POS, my company. Dividends represent the cash distributions from the corporation to the shareholders, usually distributed quarterly, but for this lesson, we'll assume that annual dividends are paid, and that's for simplicity, although the calculations still remain the same. And dividends really represent one part of shareholders' return. Retained earnings are the corporate earnings not distributed as dividends. They represent the cumulative earnings or losses over the life of the corporation. Now, capital gains or losses will be either realized or unrealized. The gain or loss represents the current stock price minus the price you bought it for. If the stock is sold, you'll have a realized gain or loss. On the other hand, if the stock is held, you'll have an unrealized gain or loss. But for our calculations, it really doesn't make a difference. For tax purposes, it's a big difference, but not for calculating the values that we're going to be calculating in this lesson. Remember, in our case, market value equals current price. So when we talk about the market value of a stock or the current price of a stock, they're both the same. Shares outstanding are the total number of shares of a company's stock that's been issued. For example, if you own 500 shares of stock in a company that has 10,000 shares outstanding, you own 5% of the company. That 5% ownership entitles you to 5% of the profits, and if you were to liquidate the company, 5% of the proceeds upon liquidation. The price-earnings ratio, sometimes referred to as a PE multiple or just PE, illustrates really the expensiveness of a stock. And it says, how much am I willing to pay per dollar of earnings? The way you calculate that is you take your stock price per share and divide it by the earnings per share. Now, when you're calculating the PE ratio, you can either use forward earnings, which would be projections that are usually supplied by Wall Street analysts, and they go out for 4 quarters, the average of the 4 quarters forward earnings, or you can use past earnings, which take into consideration actual earnings over the past 4 quarters. There's a concept relating to stock called, and it's a strategy that some investors use quite often, called short sale. Now, a short sale is when you borrow a stock, then sell it at a later time, and then buy it back and returning the stock to the owner, and then return the stock to the owner. So you buy the stock, you sell it, and then you see what kind of movement the stock price is going to have over that time that you're holding it, during the holding period, and then you sell it back to the owner. Now, the objective is to make money from the decline of the value of the stock while you have an open position in the short sale. So you're betting that ABC company's stock is going to go down in price. So you'll borrow it, sell it, watch the stock price go down, hopefully, and then make profit by selling it, by buying it back at the lower price, but selling it at a predetermined price. Any dividends paid while in your possession must be paid to the owner of the stock. That's a risk that you have to keep in mind when you're doing a short sale. So let's look at an example. You borrow shares and you sell them at $100. Let's say the stock price falls to 95, and then you repurchase at the new price at 95. You return the shares to the original owner at the $100, and so you've made money. 100 minus 95 equals a realized profit of $5. Now, there's a lot of risk associated with a short sale, because what if the price doesn't go down? If the price continues to increase, there's really no limit to the potential loss. You lose more and more money as the price of the stock continues to increase. If you just bought the stock outright, and let's say you paid $100, that would be the extent of your risk, $100 if it went to zero. But if the price continued to go up and tripled and quadrupled, you would be faced with higher and higher losses. So let's look at stock price, and how do you value a stock price? Well, like any other financial asset, the price equals the present value of all future cash flows. And there are actually two cash flows when you're talking about a stock, related to a stock. You've got dividends, and then you've got capital gains. So if you look at the return on stock, the return, or R, represents the dividends plus P1 minus P0, which actually equals the capital gain or capital loss, divided by the original purchase price. So dividends is your first cash flow, plus the capital gain is your second cash flow, divided by your original investment, and that's how you calculate return on stock. If you're uncertain what the actual stock price will be, you look at the dividend and the return for the next period. Let's look at this as an example. If you made an investment in high-tech company, let's say you paid $80 today for a share of stock in high-tech company. The expected price at price 1 is $85. You don't know with certainty, but you expect it to go up to $85. And the dividend the next period is $3. Your return would be $3, which is the current dividend payment, which is next period's dividend payment, plus the capital gain, $85 minus $80, divided by your original investment of $80, and you get a return of 10%. $8, which is a combination of capital gain and dividend payment, divided by $80 investment equal 10%. So if you break down the components and where's my return coming from, how much of it is from dividend yield and how much of it is from capital gain yield, you can take your dividend, $3, and divide it by your investment of $80, and you get a 3.75% dividend yield. And if you take the $5 of capital gain divided by your $80 investment, you get a 6.25% expected capital gains yield. Combine the two, and you've got your 10% yield. So now let's solve for price for high-tech company. So if PO equals dividend 1 plus price in period 1 divided by 1 plus R. So you know what you expect. You have an expected price in mind. You know what the dividend payment is going to be next year. That'd be $3 plus your $85 of your expected price. And that would be $88 divided by 1 plus R, or 1.1, and you get your price of $80. Now, this is the price that you need in order for you to earn the 10% that you're expecting. If you don't think the price is going to be $85 and someone wants you to pay some different initial price, you may have to rethink whether or not you want to invest, because you're trying to get that expected return of 10%. So now if you extend this and you say, okay, if at point 0, at time 0, PO equals price at point 0 is dividend 1 plus price 1 divided by 1 plus R, then a year from now, the price 1 is this dividend in year 2 plus price at year 2 divided by 1 plus R, and so on into infinity. And that becomes the basis for what's called the dividend discount model. The dividend discount model says the price of a stock equals dividends in period 1 discounted at 1 plus R plus dividends expected in period 2 plus 1 plus R to the squared plus dividends in period 3 divided by 1 plus R cubed, and so on. This is the most common way to calculate stock price. But you know, it's difficult to project dividends indefinitely. You can't always assume that a company is going to pay dividends indefinitely, nor can you project it with any real accuracy. So what you have to do is assume a terminal value at some point in time. And so to calculate a terminal value, your first thought is that the dividends occurring into perpetuity really would represent your terminal price. So if you look at price at time t, that equals your dividends plus your dividends in period t plus 1 period ahead, divided by R. So the same concept that you use to come up with the price in a particular period, you come up with the price for all future periods. Now, if dividends continue as a growing perpetuity, you adjust that terminal value equation and you say price T, or terminal price, equals dividend at period T plus 1 divided by R minus G. Doesn't that look familiar to you, like a growing perpetuity? The Gordon growth model says that the present value at time 0 equals dividend 1 divided by R minus G. And if you do a little bit of math, you can actually figure out the return and say return equals dividend 1 divided by price at time 0 plus G. Thank you for your interest, and I look forward to our next session. Welcome back to the Financial Management Review. I'm Ron Harris. Let's continue our study on stock. The dividend discount model is the simplest method used and probably the most popular method used for calculating the price of a stock. Let's look at an example of how you can use the dividend discount model. Let's look at high-tech company, and let's assume that it expects annual dividends over the next 5 years to be $3 in year 1 and year 2, $4 in period 3 or year 3, $3.50 in period 4, and $5 in period 5. And thereafter, let's assume that there's going to be a steady growth of 6% into perpetuity. Now, the investors expect a return of 10% on the high-tech POS stock. Well, looking at the dividend discount model, the current price of the stock equals the present value of future dividends. So we know what the dividend is in period 1 through 5. And as we learned at the end of the last review on stock, was you cannot always assume that you can forecast dividends into perpetuity. And so you have to come up with a terminal value. So the dividend stream represents one stream of cash flows, and then the other stream is the present value of the terminal value, and which is the price of the stock in period 5 discounted by the present value interest factor for 5 periods at 10%. So let's put that into our formula. The dividend in period 1 is $3, and it's discounted back at the present value interest factor of 1.1. The second period, the dividend is $3, and it's discounted at 1.1 squared. The third is $4, and it's discounted back at 1.1 cubed, and so on, until you get to the terminal value, and you have to say, well, what is the price in year 5? I have to figure that out before I can come up with the present value of that terminal value. And to do that, I know I have to figure out what's the dividend in period 6. actually 6 through infinity, because it's all contained in the price at period 5. So the price at period 5 is the $5 dividend in period 5 times 1.06, which represents the growth rate in dividends, and that's divided by the return of 10% minus your growth rate raised to the second power. So let's look at it again. It's $5 times 1.06 divided by the difference between the return and the growth rate squared, and that number is $132.50. So now we can take that terminal value and plug it into the dividend discount model and discount it back to the present by taking the 1.1 raised to the 5th, and we could come up with the present value of that terminal value. So when you do all that, you get a stream of present values that you can add together, and the present value of the $132.50 stock price 5 years from now is $82.27. Add that to the present values of the dividend in period 1, the present value of dividends in period 2, period 3, period 4, and period 5, and you come up with a price of $95.98. So in summary, this investor would be willing to pay $95.98 if it would get its expected dividend stream and earn 10%, which is its required rate of return. And that's the dividend discount model used to come up with the price of a stock. Now there's another way to calculate the price of a stock, because again, dividends may be too difficult to forecast and companies may not offer a continuous stream of dividends. So another way to calculate the price of a stock or the value of a stock is to forecast free cash flow. And cash flow available to stockholders and creditors, and what it represents is the earnings before interest but after taxes, but it's available to stockholders and creditors. Now, how do you get there? Well, first of all, you discount all future free cash flows at the weighted average cost of capital, and we'll talk about the weighted average cost of capital in a later session. And from that, you take out the total market value of debt to come up with free cash flow that's available for stockholders and creditors. Once you have that number, you divide it by the number of shares outstanding so that you can get an equity price per share. So that's your second method of calculating the price per share of stock. The last way that an analyst would value a firm would be by using comparables. There are two comparables that are commonly used. Excuse me. You can use the PE, which we mentioned earlier, as the share price divided by earnings per share, or you could use a market to book calculation to come up with a comparable. Actually, the share price and the market value are both the same. The difference is you're using earnings per share in the denominator of the PE versus you're using the book value of the company's assets in the market to book. Most people use the PE multiple as a valuation methodology. Now, how do you use it? Well, you find the appropriate ratio by observing comparable companies. And comparable companies could be some industry peers, or they could be financial peers. Financial peers being those companies that have similar growth, similar size, either in asset size or revenue size, similar operating leverage. Those would be examples of financial peers. And so what you would do is you would multiply the appropriate ratio by actual earnings per share or book value per share to get the price. So if you've got a 15 PE and your earnings per share is $1, your stock price would be 15 times the $1 or $1 per share. That's how you use comparables. Now let's look for a minute at preferred stock. Preferred stock works like a perpetuity because it provides a continuous cash flow, and it's a consistent cash flow indefinitely. Usually, preferred stock is non-voting versus common stock has voting rights and shareholders have control. Preferred stock doesn't provide its owners with that benefit. Now, the dividends on preferred stock, however, are not guaranteed. However, they usually are cumulative, which means any dividends that are not paid in a particular year on preferred stocks must be paid before common stockholders can receive any dividends. So dividends in arrears must be paid up before a common stockholder can get any dividends. Preferred stock, therefore, is less risky than common stock, but it's still more risky than debt because debt holders are able to drive a company into bankruptcy and will have priority over preferred stockholders and common stockholders in the event of a liquidation. But preferred stock does have less risk than common stock. Thank you. Welcome back to our financial management review and our discussion around capital budgeting. I'm Ron Harris. We're going to look at corporate finance in general, and then we'll look at some capital budgeting tools that's going to help you to solve problems that will come up as you try to plan for your capital expenditures. And we'll look at a problem which looks at the net present value of a realistic project. Corporate finance really has two major and separate decisions that have to be made. We look at capital budgeting, which really is the project selection process. You've got a portfolio of projects that you want to do, and you may not be able to do every single one of them for whatever reason, but you want to select the projects that provide the most value to the firm. So that's the capital budgeting selection process. And then the second question is, after you've decided what projects to do, now you have to figure out, how do I pay for those? Seems a little strange, but this assumption here is that companies will have enough sources of capital that if they've got projects that are going to create value, they'll be able to finance those projects. I wouldn't try that for your personal budget, but this is how most companies manage their capital budgeting and financing decisions. When you're thinking about looking at projects that create value, there's a couple of different measures that most companies are interested in. First of all, the project has to make money. Secondly, the sooner the money can come in, the better. And thirdly, they want to minimize the risk. So make money, make it faster, and do it without as much risk. Do it with less risk. Now, any project evaluation tool that you use needs to be able to measure all three of those preferences that companies have. We're going to look at 5 different capital budgeting tools that are used in industry, business and industry today. First is net present value, which actually is the best, and I've listed this in the order of preference. Net present value, then internal rate of return, profitability index, accounting rate of return, and payback period. When I worked at General Electric, one of my primary jobs was to manage the investment planning for General Electric lighting, GE lighting. And so we had millions and millions of dollars of budget that we had available for capital projects. We used 4 of the tools that we have listed here. The only one we really didn't pay a lot of attention to was accounting rate of return. But net present value, IRR, profitability index, and payback were all used in practice at GE. If you look at which ones are used the most, I would say net present value is the one that I would pick out of any of these others if I could only select one. But internal rate of return is good, as well as profitability index is very good. Now, not always will projects get selected based on the results of using these tools. Sometimes there'll be strategic considerations, past actions by management, some management gut feel or intuition will drive some investment decisions. And in some cases, there won't be enough quantitative data available, or there may be legal or regulatory requirements, like some of the requirements around disability, where you have to make some capital investments. And lastly, there may be some asset replacements that are caused by natural disasters. But those aside, these tools are the tools that should be used in capital budgeting. Let's look at net present value. Well, in net present value, we look at projected cash flows minus the present value of cash outflows. So cash inflows minus the present value of the cash outflows. Now, we discount those cash flows at the firm's cost of capital, which is also referred to as the opportunity cost of capital or the hurdle rate. The variables that are included in any present value analysis would be, you have to estimate the cash outflows or costs. You have to estimate the cash inflows or benefits. You've got to take the tax rate into consideration, because there is a tax shield on depreciation that you have to take into consideration. You have to look at inflation rates, the cost of capital or discount rate, which is R, and you got to look at the project life. And then lastly, in some cases, you'll assume that there's some value to the asset that you've invested in at the end of its usefulness, and it's the terminal value that also has to be considered in your net present value analysis. Now, the opportunity cost of capital is the rate of return that could be earned on alternative investments of similar risk. And this is the rate of return that's given up by the fact that you decide to do the project, as opposed to just taking those dollars and investing them in some security of similar risk. So we're always going to be using as our discount rate a risk-adjusted rate of return. And the formula, if you look at it, is one that we looked at earlier, and it's just the net present value equals the cash invested, which is represented by CO and has a negative sign, plus the cash inflows, each one discounted at its respective present value interest factor for that period. Now, the decision criteria would be, if the net present value is greater than 0, accept the project. If the net present value is less than 0, reject it, because you'll destroy value if you do go ahead and do the project. And then if the net present value equals 0, you're really indifferent. Should I do the project, or should I invest the proceeds in something else that's going to give me the same required return? Let's look at a problem in net present value. Let's assume that you're doing a project and its initial capital investment is $100,000. And let's also assume that the operational cash flows would be in period 1, $25,000, and then in periods 2 through 5, $30,000. So 4 periods of $30,000 of cash flows, inflows. These cash flows come at the end of the period. When I think about that, I think about an ordinary annuity, where you've got fixed cash flows over a specific period of time, and it occurs at the end of the period. The weighted average cost of capital, or the rate that we're going to use to discount our cash flows, is 6%. So if we look at our formula, we can see that cash flows of negative $100,000 in period 0, or now, $25,000 in period 1, $30,000 at the end of periods 2 through 5. We'll be given present value interest factors for each one of those periods, and what we'll do is we'll multiply the present value interest factors for those periods by the cash flows for that period, and we'll come up with a present value number. From that, we'll add those present values of those cash inflows together, and then we'll subtract the initial investment of $100,000, and in this case, you get $21,655 as your net present value. Now there's an alternative way that you could solve this same problem. If you look at the cash flows, you see that the $25,000 in year one is the present value of a lump sum. And so you just use the present value interest factor for period one at 6% to discount that first flow. But the present value of the next four cash flows, which they're all 30,000, would say that that's an annuity. So there you could use the present value interest factor of an annuity, an ordinary annuity, because the cash flow is at the end of the period, for 4 years at 6%. And then since the annuity starts in period at the end of period 2, you really have to discount it back, to period 1, you have to discount it back to its present value by taking the present value interest factor for one period at 6%. So you would take your $25,000 times 0.9434, that's its interest factor for period 1 at 6%. And then you would add to that the present value of an annuity, which is the $30,000 times 3.4651, discount it back using the present value interest factor of 0.9434, and you will get $21,654.26, the same answer that you got using the other approach. So should you do this project? I think absolutely do this project. Not only does the project return you your required return of 6%, it also gives you an additional $21,654.26. So value has been created by this project. Accept it. Remember, projects that increase the value of the firm, this project increases the value of the firm by almost $22,000, versus if you had invested in a return, in an asset that gave you your required return, you would have just gotten the 6%. Do the project. Thank you. Welcome back to the Financial Management Review and our discussion around capital budgeting. I'm Ron Harris. In the last discussion, we looked at net present value as the primary tool used in capital budgeting. Now we're going to turn and look at internal rate of return, profitability index, accounting rate of return, and payback periods, and learn a little bit about how they're used in capital budgeting and which ones are preferred versus the ones which aren't as preferred. Internal rate of return is the percentage rate of return on your investment project. If you recall, in net present value, it gave you a dollar amount. Well, internal rate of return actually gives you a percentage or a return number. And the decision criteria is usually to accept the project if the internal rate of return is greater than the cost of capital or the hurdle rate. Now, there are some complications with internal rate of return, but for the most part, it's a very reliable capital budgeting measurement tool. For example, the internal rate of return, there could be situations when you have more than one IRR. And the reason why or when that happens is when you have more than one change in the directions of your cash flows. So if you have an outflow and then a series of inflows and then an outflow in a later year, when you do the internal rate of return calculation, you'll get multiple answers and you will not know which one represents the real return on the project. Additionally, IRR can be misleading on mutually exclusive projects because you can't tell which project to accept. Now, a mutually exclusive project says you can do one or you can do the other, but you can't do both. For example, if you wanted to build a plant in Ohio and also build a plant in North Carolina to produce the same product, the same capacity, well, IRR won't tell you which one to do because you can't do both. You can only do one or the other. Now, Let's look at an IRR problem. Let's assume we had a project that we needed to spend upfront $10,000, and we had cash flows in years 1 through 5 of $3,000 a year. The cost of capital is 10%, so let's figure out what the IRR is on this project. Well, when you look at the net present value equation, we already know that the IRR is the discount rate that makes the net present value 0. So when you substitute 0 for net present value, and then you look at the rest of the equation, what you do is instead of having R as your discount rate, you substitute IRR, and IRR becomes the unknown. Now, in reality, you could use calculators or go to a IRR table and find out the IRR for various time periods. But for our purposes and for the CPA exam, you're really going to have to use trial and error to find IRR. So let's start, for this purpose, let's start with 17% as our discount rate, or assume that that's our IRR. So when we put 0 in for net present value, put in negative $10,000 for our initial cash or cash outflow or investment, and then we look at a $3,000 annuity over 5 years at an IRR, and we put in 17%, we find that the present value interest factor of annuity for 5 periods at 17% is 3.1993. We multiply that by our $3,000, our annuity payment over the 5 periods. We subtract from that $10,000, which was our initial investment, and we end up with a negative net present value of $402.10. So what that says is you would reject this project because 17% is too high a hurdle rate. So the IRR in this case is not 17%, because if it were, the net present value would have been 0. So step 2, what you do is you through trial and error, you put in 16%. So when you put in 16% and go through the exercise, you find the present value interest factor of annuity at 16% for 5 periods. Multiply that by your $3,000 annuity payment. Subtract out the $10,000 initial investment, and you get a negative $177.10. So you see that you're getting closer, but you're still not there. So through continued trial and error, you put in 50%, go through the same exercise, and voila. You get a positive $56.60. So now you know at 16%, you are at a negative $177.10. At 15% discount rate, you're at $56. So you know that your IRR is somewhere between 15 and 16%. On the exam, this most likely would be the answer, that the IRR is between 15 and 16%. You've done your trial and error, and you've narrowed it down. The actual IRR on this project is 15.2383%. The next tool that we use for capital budgeting is profitability index. And this is best used when you're faced with capital rationing. In other words, you've got a budget constraint. The more acceptable projects, there are more acceptable projects than are available. And so you have to draw the line and you have to force rank your projects. It's similar to net present value because in the denominator, which is the present value of all the cash flows from the cash inflows from the project, divided by in the denominator, the cash flows as the initial investment. If that answer comes out to be greater than 1, then you would accept the project. Similar, if net present value is greater than 0, you accept the project. But there's one stipulation. Because you've got budget constraints, you can't do every project. When I was at GE, one of the things we used to do was we would use the profitability index and we would draw a line once all the money was gone. So if we had net present value, if we had investments of $10 million and we had budget of $8 million, we would force rank each project based on the profitability index. And once we used up the $8 million, we would draw the line, and the projects that were below the line, the additional $2 million of projects, just wouldn't get done unless we could change some assumptions realistically. But it provided us with a method for force ranking projects because we had budget constraints. The next method is not one of the preferred methods, and it's called the accounting rate of return method. In this accounting rate of return method, we actually say that the average book rate of return is the average annual income divided by average annual investment. And we would compare this project return to the company's rate of return or hurdle rate. It's good to know, but not really that useful in practice because there are a couple of drawbacks. One, the accounting rate of return uses net income rather than cash flow, and net income can be manipulated. Secondly, it ignores time value of money, and we know that $1 today is worth more than $1 tomorrow. The last method is called the payback period, and this is a popular method used in industry, but it's not a preferred method because the payback period considers the time it takes for the cash flows for the project to recover its initial investment. What the firm has to do is it actually has to accept an arbitrary cutoff date. So let's say if it's 3-year cutoff, we want to pay back within 3 years. Well, what if the cash flows from that project, the larger cash flows, occur beyond year 3? And so that you are not able to recover your initial investment in periods 1 through 3, it would not make the cutoff. Although, what if it had huge cash flows coming in year 4, 5, and 6? From a net present value perspective and IRR perspective, it very well could be great projects, but you would reject it because it didn't meet the cash flow, it didn't meet the cutoff period. I will say, though, that the payback period is a useful method when you're under financial distress. We used it at GE when we were looking at productivity projects because we needed to get a certain amount of cost reductions every year, and we got those reductions through implementing productivity projects. So that's one that if you could get us a payback within 12 months, you had a good chance of getting it approved, although it may not be the highest net present value decision. The drawbacks, I think, and I mentioned some of them, the drawbacks of this method is it gives equal weights to all cash flows that occur before the payback cutoff, and it gives no weight to cash flows that occur after the cutoff period. And also, it ignores time value of money. So the preferred capital budgeting methods are net present value, internal rate of return, and profitability index. And net present value is the king of all capital budgeting methods. Thank you. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to turn our attentions to cash flow. We learned earlier that net present value is the preferred method for evaluating capital projects. And in using net present value, you have to discount the future cash flows of the project to come up with the net present value. Well, what are cash flows? In this session, we're going to review we're going to answer that question, and we're going to look at an actual project to show you how to come up with cash flows. Well, cash flow is C, or FCF, or free cash flow. You'll see any one of those terms in the CPA exam when we're talking about cash flow. And cash flow is what's available for stockholders and bondholders, as well as any other creditors of the firm. So it's the cash that's available for stockholders and bondholders. There's some rules you really need to remember when thinking about free cash flow. First of all, we discount cash flows, not accounting earnings. And when we discount cash flows, it has to be incremental cash flows associated with doing the project. If you've already spent money on a project and you try to include that cost in a new analysis, you've made a mistake because that cost is irrelevant. Anytime you have sunk cost, you exclude it from your analysis because sunk cost is irrelevant. Incremental cash flows are only relevant because they only occur if you do the project. If you don't do the project, you won't have the cash flow. It won't be incremental. So relative free cash flows include opportunity costs. For example, if I want to build a factory or sell the property. If I build a factory, then my opportunity cost is the lost cash inflow from selling the property. That should be included as a relevant cash flow in your capital budgeting analysis. Let's say, for example, you're opening a new retail store and you have to build up inventory as a result of adding this new store. Well, that incremental or change in working capital would be added to your cash flows. It would be a cash outflow at the start of the project, and then it will revert into or convert into a cash inflow at the end of the project life. One of the things you have to be mindful of is that you exclude financial costs from your free cash flow. And I know you want to reduce your cash flow by interest expense, but do not include interest payments in your free cash flow. It's covered within your cost of capital. A couple of relevant cash flows. Let's just go down the list so that we can make them more understandable and make it more clear what's included in cash flow. New asset purchase represents a cash flow. A new lease payment would be cash flow. Installation costs, training, setup and maintenance, like we mentioned earlier, incremental working capital, other operating costs, all would be considered cash outflows. Now, cash inflows would be incremental revenue, less the costs associated like new scrap, rework, spoilage, labor, inspections, handling, inventory carrying, terminal value, cost avoidance. If you're able to avoid some costs because you do a project, that would be irrelevant. That would be a cash inflow. Ignore sunk costs. Consider only incremental cash inflows and outflows. You could summarize all of those examples of cash flows that I just spoke about into three categories. There could be the initial investment, which is an outflow, and then there could be changes in net working capital, which is an outflow at point zero and an inflow at sometime in the future. And lastly, cash flow from operations, which represents your cash inflows between time zero and sometime at the end of the project in the future. When you think about cash flows and projects, they normally fall into several categories, but the type of projects that you're normally going to be looking for cash flows from are replacement projects, which would be the acquisition of new machinery or buildings, and that's driven by cost savings or sometimes tax consequences. Expansion projects would be another category, and that's driven by market expansion or entering new markets. And your objective there is you're trying to increase profits and cash flow. Improvement projects, they're generally strategic and they're trying to improve existing products. And then there's safety and environmental projects that really may not provide you with the best returns, but you have to do them anyway because they're normally driven by regulations. So how do you get the cash flow from those projects? Well, there are actually two methods of calculating cash flow. You could start with a top-down method, or you can use what's called the depreciation tax shield method, and we'll review both of those. The top-down method, you start with incremental revenue, and you subtract from that costs. And those costs are both variable costs and fixed costs. You further reduce that number by depreciation, so you come up with a number that's called earnings before interest and taxes, EBIT. Now you may say to yourself, wait a minute, depreciation's a non-cash item, so why am I subtracting it? Well, you'll see in a moment. To that EBIT number, you're able to use that number to calculate your tax liability. And so you wanted to reduce EBIT because the depreciation is a deductible expense, and now you can calculate the appropriate tax liability. So from EBIT, you calculate tax liability, and you come up with your income from operations that you're going to use in your tops-down method. You add back depreciation because it is a non-cash item, but you needed it earlier to calculate the right tax number. And therefore, you come up with a new number called cash flow from operations. That's the top-down method. Now, the depreciation tax shield method is a little bit different, but you'll get the same answer. You start with revenue and you subtract both your variable and fixed costs, and then you adjust that number, the difference between revenue and all costs, you adjust it by your tax rate, which is 1 minus your tax rate. Additionally, you add back your tax shield on depreciation. So you take depreciation times your tax rate, and you come up with your tax shield. So you add that, which is a benefit, to the previous number, and you get cash flow from operations. Let's look at that by looking at a critical project and evaluate what we should do. Well, unit sales are forecasted at 50,000 units. And the unit price that we think we can sell it for is $4 per unit. We have variable costs of $2.50 a unit, fixed cost of $12,000 a year, and the company is expecting a required return of 20%. That's the hurdle rate. And the life of the project is 3 years. So the capital investment for this project is going to be $90,000. We're going to use straight line depreciation, and the marginal tax rate is 34%. And this project is going to require some incremental working capital, let's say $20,000 a year. So using the tops-down approach to evaluate this critical project, we start with revenue, so the 50,000 units times $4, and we get $200,000 as the anticipated revenues for this project. The variable cost would be the $2.50 times 50,000 units that we manufacture, and that will be $125,000. Fixed cost, like we mentioned, is $12,000. And then the depreciation is going to be $30,000 a year. The initial $90,000 for the investment divided by 3 years gives us $30,000 a year. So when you start with your $200,000 of incremental revenue and you subtract out your variable cost, fixed cost, and depreciation expense, you get an EBIT of, or earnings before interest and taxes, of $33,000. You take that number and you multiply it by your tax rate, and you get a tax expense of $11,220. Once you do that math and subtract down, you get an income of $21,780. Now, you add back your depreciation. Why? Because it's a non-cash expense. And so when you add that back, you get $51,780 as cash from operations. Let's try that looking at the depreciation tax shield method and see what we come up with for operating income. Again, revenues are $200,000. Your cost, you combine your variable cost plus your fixed cost, and you get $137,000. Your earnings before interest, taxes, and depreciation is $63,000. And so you do your tax adjustment on your depreciation, and you get earnings. You do your tax. You do your tax adjustment, which is 1 minus 0.34 times your $63,000, and you end up with $41,580. Now, to that number, you add your tax shield, which is your depreciation times 0.34, and that's your depreciation tax shield of $10,200. And when you add that to the $41,580, you have an operating income of $51,780, and that's your cash flow. So when we look at it on a year-by-year basis, we can see that operating cash flow starting in year 1 is $51,780. In year 2, you have $51,780. And in year 3, you have $51,780. In period 0, you have the incremental outflow, which is your increase in net working capital of $20,000, and you have your initial investment of $90,000. That's an outflow. In year 3, you get that net working capital returned to you at the end of the project, which becomes a cash inflow of $20,000. Therefore, your project cash flows are $110,000 in period 0, $51,780 in period 1 and 2, and $71,780 in period 3. So we know our net present value formula, and when we discount the cash flows in periods 1 through 3 by their respective present value interest factors for period 1 at 20%, period 2 with 20% discount rate, and period 3 at 20% discount rate, and you get $10,647.69. You accept that critical project. Now let's figure out what the IRR is on that same project, because you can see that the net present value gave us a dollar figure. The IRR is going to give us a rate. So when we go through the process and we look to solve for IRR, because IRR is the net present is the discount rate that makes our net present value 0, and through trial and error, we find out that the IRR is between 25% and 26%. And the actual IRR is actually 25.76. And with a cost of capital or hurdle rate of 20%, we would accept that critical project on an IRR basis as well. So IRR and NPV both tell us that we should accept the project, because we made sure in this case that we got our cash flows right. Thank you. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to now turn our attentions to the capital asset pricing model. So what is CAPM? It's a model that represents a simple theory that says the only reason an investor should earn more on average by investing in one stock rather than another is that one stock is riskier. So if both stocks had the same risk, there should be no expectations to get a higher return. The model also assumes that the standard deviation of past returns is a perfect proxy for the future risk associated with a given security. Shareholders require a rate of return on equity capital that is a function of 3 things: the risk-free rate of return, the rate of return earned on stocks in general, we'll call it the market portfolio or market return, and the riskiness of a particular stock in which the investor may be considering investing. This CAPM can also be applied to capital projects. So it's not just used to come up with the cost of equity for a stock or a portfolio of stocks, but also for the cost of equity for a particular project. Now, you can use a rule of thumb to estimate the cost of capital by using the capital asset pricing model. You can use it to calculate the expected return of a risky asset. And like I mentioned, you can use it to find the discount rate for a new capital project or a new capital investment. To really understand the capital asset pricing model, you really have to break down the formula. And the formula for expected return for equity is the risk-free rate plus a risk premium, where the risk-free rate is shown as RF, and it's the rate of return on long-term U.S. T-bonds. And those T-bonds typically would be 10 years or longer. The risk premium would be the rate of return on a market portfolio, which would be RM, minus the risk-free rate. And the difference between the two represents the risk premium. And beta, which is multiplied by that risk premium, it measures the tendency of stocks to change with the market changes. Now, there are a couple of assumptions that any investor or anybody evaluating a project trying to calculate the cost of equity would have to use in order to apply the capital asset pricing model. And there would be investors aim to maximize economic utilities. The capital asset pricing model also assumes that investors are rational and they're risk averse. They assume that their portfolios are broadly diversified, so they've eliminated all of the risk associated with concentration into one investment, that they're price takers, and that so therefore investors are able to influence prices. They're not able to influence prices, but they can lend and borrow unlimited amounts of money under the risk-free rate of interest. They can trade without transaction or taxation costs. They can deal with securities that are divisible into small parcels. And they assume market efficiency, which means that all information is available at the same time to all investors. With all those assumptions, let's focus our attention on beta, because beta is the riskiness of an individual stock. And it gauges the tendency of a security's return to move in tandem with the overall market. So if beta is 1, stock has the same volatility as the market. However, if beta is greater than 1, you have what's called high systematic risk. And that means the stock is more volatile than the market. And if beta is less than 1, you have low systematic risk, which means that it is less volatile than the market. Beta is estimated by regressing stock prices against a level of some broad market index. And beta is therefore the slope of that regression line, and it measures a company's systematic risk. No matter how much you try to diversify your portfolio, it's impossible to get rid of all risk. So investors require a rate of return that compensates it for taking on risk. The capital asset pricing model is used to calculate investment risk and the appropriate return to expect. So let's look at market or systematic risk, and then we'll look at company risk or unsystematic risk. Market risk cannot be eliminated by diversification, and it's caused by changes in the market at large. And it includes interest rate risk. Company risk, on the other hand, is risk that the company will suffer losses in the future. And it can be eliminated by holding a diversified portfolio, so it's unsystematic risk. So let's look at a company called McDonald's. We all know about McDonald's. Well, if you look at McDonald's, you'll see that using the capital asset pricing model, that they actually have an expected return of about 9.84%. The way you get that is you just take the numbers and include it in and enter them into the capital asset pricing model. So the beta right now for McDonald's is at 1.2. The risk-free rate, or the rate on treasury bills, are about 3%. And the market rate in general is somewhere around 8.7%. So therefore, the risk premium is the market rate minus the risk-free rate, and it's 5.7%. So when you plug into the formula the risk-free rate of 3% plus beta of 1.2 times the risk premium of 5.7, that's how you come up with your 9.84% for the expected return on McDonald's stock. Now you can graph the capital asset model, pricing model on what's known as the security market line. And that line shows the relationship between beta and expected returns. Every investment must plot along the security market line. So if you have a beta of 1, then your return is the market return. If you have a beta of 2, then your return is going to be somewhere north of the market return. And conversely, if you have a beta of less than 1, let's say 0.5, your return is going to be half the return of the market return, because there's a direct relationship between beta and the expected return on stocks. Thank you. Welcome back to the Financial Management Review. My name is Ron Harris. So far, we've looked at present value problems and future value problems, and we recently finished going over some capital budgeting problems. And in each case, we were given the discount rate or the interest rate to use to solve those problems. Now that's okay because when you're in your early part of your financial management career, you'll usually be given a hurdle rate or discount rate to use when you're trying to solve these types of problems. However, as you move up into the executive ranks in finance, that I know each one of you will have the opportunity to do, in roles like the treasurer's role or the CFO's role, you're going to have to be the one to determine what is the actual weighted average cost of capital that we should use when we're evaluating projects. Now, before we start, let me just quickly review what we'll cover in this review. We're going to look at weighted average cost of capital. What is that? We're going to look at capital structure so that we can understand how do we come up with an appropriate capital structure. And then we'll actually look at how you calculate the cost of capital. So the weighted average cost of capital is the average of the cost of various sources of financing, each of which is weighted by its respective use in the given situation. The cost of equity, when you're looking at capital structure management, is always going to be greater than the cost of debt. And so you need to keep in mind that investors are adverse to risk. And as a result of that aversion, investors demand a higher rate of return on equity than on debt. And that's because invested in equity is riskier than invested in debt. So when you're talking about weighted average cost of capital, before you go right into the calculations, first of all, you've got to determine how much debt should I use in financing the company versus how much equity should I use. So capital structure management focuses on finding the appropriate combination of debt and equity such that combined weighted average cost of capital is optimized. Now, I wish I could just give you a formula that says use this formula and it will give you the exact capital structure and weighted average cost of capital that you're looking for. But unfortunately, there's no model to determine unequivocally what a proper debt to equity mix is for any entity. And that's important to know, because changes to capital structure weights can change the cost of capital. So really understanding how much debt versus how much equity you use becomes important, not only in determining the cost of capital, but also in determining what projects get accepted and also the overall riskiness of the firm. Now, the optimal capital structure maximizes the price of the stock by balancing risk and returns. And in this case, the stock price of the stock represents the value of the company. Optimal capital structure is where the marginal tax shelter and the benefits of that tax shelter are equal to the marginal bankruptcy costs. So when you use debt, you actually get a tax shelter benefit because interest expense is tax deductible. If you drew a graph and on the x-axis you use various debt to equity ratios, and on the y-axis you used interest rates, and then you plotted a line of what is the cost of equity at each one of those debt to equity ratios and what is the cost of debt at each one, what you'll see is the average cost of capital, the combination of debt and equity, will actually decline as you add more debt, but it will plateau at some level and for a short range will bottom out before it starts reversing upward. And the reason for that is as you add more debt, there's a marginal diminishing return to the benefit of adding debt. And then ultimately, as you increase the riskiness of the company and the default risk, the actual cost of capital, the total average cost of capital will increase. And so there's a continuous balancing act between how much debt to use versus how much equity. So when you're trying to determine the capital structure, there are several factors that you have to consider. I'm going to talk about 6 of those factors. First, you have risk. And risk falls under both business and financial risk. Business risk is one of the most important factors in determining an appropriate capital structure because business risk looks at the uncertainty inherent in the projections of your earnings or your net income or cash flows. The next one is the financial risk, and financial risk comes about because an entity decides to carry debt. So as you add additional debt, you're adding additional risk to the company. Next, you would look at the degree of operating leverage and the degree of financial leverage. Well, operating leverage is measured by contribution margin divided by EBIT, or earnings before interest and taxes. And you would be considered to have a high degree of operating leverage if a small change in sales results in a large change in operating income. With respect to financial leverage, you calculate that by taking earnings before interest and taxes divided by the earnings before interest and taxes minus interest. And you would be considered to have a high degree of financial leverage if a small change in earnings before interest and taxes results in a large change in common shareholders' return. The next 3 factors that go into determining the capital structure of a firm would be stock valuation factors, analysis factors, and dividend policy. Well, I've talked a little bit about the stock valuation factors when I mentioned that you're always balancing the interest tax shield versus the risk of bankruptcy. But analysis factors, there are several different things you have to think about. You have to look at the sales stability. You have to look at profitability of your asset structure. You look at your growth rates, even management point of view, because some management teams are more conservative than other management teams. Look at borrowing capacity, and you look at the control of owners. And then lastly, you look at your dividend policy. When you look at what's called a payout rate, if your payout rate is high, where you pay out a high percentage of your earnings in dividends, that actually reduces the uncertainty for stockholders. Versus the plowback says, maybe I want to return or keep in the business a large percentage of my earnings because I have high expectations for growth of the projects that I'm considering. So once you've determined what your targeted capital structure is, then you can start calculating the actual cost of capital. Well, let's look at the cost of each one of your sources of capital. So the cost of debt, well, that equals interest expense times 1 minus your tax rate to get your after-tax interest expense, and then you divide that by the average market value of debt. Next, you turn to, if you have it, you look at the cost of preferred stock. Well, the cost of preferred stock equals your preferred dividends divided by the average market value of preferred stock. Next, you look at the cost of common stock, which is determined by the dividends on your common stock divided by your average market value of the common stock. And to that, if there's growth, you add your expected dividend growth rate. And then lastly, the sources of capital that's generated internally, which is retained earnings, equals 1 minus the marginal tax rate times the cost of common stock. So combined, those are your 4 different sources of capital and the cost, how you calculate the cost of that capital. Now, depending on your target capital structure, you're going to have a certain amount of the value of your firm represented by debt and a certain amount represented by common stock. So the value of the firm equals the market value of equity plus the market value of debt. And we use the letter E for equity and the letter D for debt. And so to come up with the weight for debt, which is WD, you just take your total debt and divide it by the value of the firm, V. And then to come up with your weight for common stock, which is common stock, WCS, that equals the value of equity divided by the total value of your firm. So when you take the weights plus the cost of capital that you've calculated, you can put it into a formula that's known as the weighted average cost of capital. So the weighted average cost of capital is the weight of debt times R, which is the RD, which is the cost of debt, times 1 minus T, so that you get your after-tax weighted average cost of debt. Then you take your weight for preferred stock times R, or the cost of preferred stock, and you multiply them together to get your overall cost of preferred stock, your weighted cost of preferred stock, plus the product of the weighted cost of stock, which is represented by W subscript CS, times R subscript CS, which is the required return on your cost on common stock. So you take the 3, the after-tax weighted cost of debt plus the weighted cost of preferred stock plus the weighted cost of common stock, and that's how you get your weighted average cost of capital. Now, you must be mindful that there are a few mistakes that you need to avoid, or I like to call them the 4 don'ts when you're trying to calculate your weighted average cost of capital. First, never use or don't use the coupon rate on existing debt. Rather, use current interest rates on new debt. Don't use book values to estimate weights. When I was going over the targeted capital structure, we always used the current market values for that source of capital, not book values. Next, don't subtract current long-term bond rate from the historical average return on common stock to calculate the risk premium. Use expected future returns on stocks. And lastly, don't include non-investor funds as a source of capital. An example of a non-investor funds would be when you extend your payables to actually fund your receivables. That's not a capital source. So only use capital. That's a capital source, but it's not provided by investors. Only use capital from investors. the best way to illustrate the weighted average cost of capital would be to let's look at a problem. And let's look at high-tech company. High-tech company has 1 million shares outstanding of common stock. And currently their common stock is trading at $60.60 per share. Bank debt is 10 million at an 8% fixed rate, and the long-term bond, which is another source of debt, is 10 million and it's trading at 102. So the fact that it's trading at 102 tells me that it's trading at a premium, and the coupon rate is 8%. So I'm not surprised that when you look at this, you'll have to be able to understand that we've got bank debt and long-term bond debt that we have to consider. And the long-term bond matures in 12 years. So if you look at this problem, you have to also look at what's the beta of the firm, what's the risk-free rate, and in this case it's 3%, the beta is 1.1. The market rate is 8.7%, represented by RM. And so your market premium, which is RM minus RF, or your risk-free rate, and that's 8.7 minus 3.0, and the market premium is 5.7%. And high-tech company has a corporate tax rate of 35%. So what is the weighted average cost of capital? Let's do it in steps. Let's calculate it in steps. Step one, first you calculate the value of the firm. And as I mentioned earlier, the value of the firm equals the value of debt plus the value of market value of equity. So to calculate the value of debt, you add your bank debt plus the market value of the bonds. Bank debt was 10 million. The market value of the bonds is actually 1.02 times 10%. Remember, it was trading at 102%, so it was trading at a premium. So 1.02 times the 10 million. And when you add the two, you get 20.2 million. The market value of common stock, which is represented by E, equals the current price of the stock, $60.60, times the 1 million common shares outstanding. So it's 60.6 million. So when you add the market value of common stock, 60.6 million, plus the market value of the sources of debt, 20.2 million, you get the value of the firm of 80.8 million. So now that you've got the value of the firm, in step two, you calculate the weights for each capital source. And so the weight of debt, which is represented by W subscript D, equals your 20.2 million, which is your market value of your debt, divided by the market value of the firm, 80.8 million, and then you get 25%. Then when you turn to your weights for equity, you take the 60.6 million, which is the market value of equity, divided by the total market value of your firm of 80.8, and you get 75%. So our target capital structure for high-tech company is 25% debt, 75% equity. Step three, we calculate the expected return on common stock. And the expected return on common stock, what do? We turn to the capital asset pricing model that we talked about in an earlier review. So RE, or R for equity, equals the risk-free rate plus beta times the market premium. And the market premium is RM minus RF. So if the risk-free rate is 3% and the beta for high-tech company is 1.1 and the market premium is 5.7, when you plug those numbers into the capital asset pricing model, you get 3% plus 1.1 times 5.7, the market premium. And when you do that math, you get the number 9.27%. So our weighted average cost of equity using the CAPM is 9.27%. Next, we have to calculate the required rate of return on debt. In this case, it's a two-step process because we have two different types of debt. We've got your bank loan and we've got your bonds. And so when you look at the formula that's used for calculating the price of bonds, we go back to what we learned on how you price bonds, and you would see that the formula would become, and you don't have to memorize this formula, but the formula really looks at the two cash flows that come from a bond. And you've got your cash flow that's coming from the dividend payments, and it's coming from the cash flow, from your coupon payments, and the cash flow that's coming from the return of your principal. But what you're trying to do is you're trying to solve for R. So when you will always be given the tools to calculate this. You will not be responsible for calculating this. But when you put it in the formula that's given, you'll see that the yield on the price of the bonds is 3.87%, and that's R, but the yield to maturity, it turns out to be 7.74%. So your actual cost of debt will be 7.74%. You don't use the effective coupon rate. You actually use your yield to maturity. Next, you look at the weighted average cost of debt. And in this case, you say half of my debt is at 8%, which is the rate on the loan, and half of my debt is at 7.74%, which is the weighted average cost of the bonds. And so when you add it together, you get the weighted average cost of debt, which is 7.87%. Last step is you calculate the overall weighted average cost of capital. And the weighted average cost of capital is, again, the cost of the component times its respective weight. So we remember that the weight used for debt in our capital structure is 25%. So we take our weighted average cost of debt, which is 7.87%. 1 minus 0.35, which is our after-tax rate, so that we come up with our weighted average after-tax cost of debt, plus the 75% weight that we have in our targeted capital structure for equity, times 9.27%, which is the cost of equity, which we calculated using the capital asset pricing model. So when you add those two together, your weighted average cost of capital is 8.23%. So a couple of observations. What you see is that the stockholders are requiring a higher return than the creditors. And the reason for that is debt holders get paid first. Also, there's less risk to debt holders because debt holders actually could drive a company into bankruptcy if they default on those payments. And then lastly, stockholders get a required rate of return based on what the return that we calculate using the capital asset pricing model. Thank you very much for your attention. Welcome to the Financial Management Review. My name is Ron Harris. In this session, we're going to talk about working capital. We're going to look at and get an understanding of what is working capital and how do you manage two of the components of working capital, cash and accounts receivables. Working capital equals current assets, so that would be cash, marketable securities, accounts receivables, and inventory. Net working capital would be current assets minus current liabilities. When you're trying to manage the first component of working capital, cash, there's a couple of different ways to manage the balances. There's an approach called the transaction balances that represent the associated routine payments and collections of cash. Well, you start by developing a cash budget of inflows and outflows, and that would include the payments of capital asset purchases, inventory, and expenses. And then as you're building your cash flow budget, what you have to do is consider the timing and collections from customers, collections from debtors, and the collection of cash from capital asset sales. In addition to forecasting your transaction balances, you have to forecast your compensating balance needs. And compensating balances are specific minimum balances required by banks to improve yields on lines of credit that they may provide to you and to offset the associated service costs. Usually, a minimum monthly weighted average balance must be held on deposit. In addition to transaction balances and compensating balances, you also could have a need for precautionary balances of cash and speculative balances. The precautionary balances are to help you when you have uncertainty around the timing of your collections and outflows. And the speculative balances would be if you just want to have something extra in case a unique opportunity occurs and you want to take advantage of that opportunity, you'll have the cash. Now there's a couple of different tools that you can use when you're trying to manage your cash. And the first approach is synchronization. And that would be arranging your collections and your payments so that the receipts coincide with the outflows. Additionally, in addition to making sure you have the flows synchronized, you can actually impact the timing of the flows. You could speed up collections or you can slow down payments. You speed up collections by using lockbox service from a bank and as well along with electronic funds transfer, versus you try to slow down the payments by using an account called controlled disbursement account. It was really popular in the 80s and 90s, not as popular today because the Fed system, the clearing system, has improved so dramatically. It's really difficult to get any advantage from having an account in a remote location that you would call a controlled disbursement. Now, what you're trying to do with synchronization and the speeding up and slowing down of payments is really trying to generate some float. And float is the difference between the amount on the depositor's books and the balance according to the bank. If the balance according to the bank is greater than the balance on your books, you actually have additional funds that you have use of that you weren't expecting, and you actually have positive float. Now, if the alternative exists where the depositor's books are lower than the balance in the bank, or higher than the balance in the bank, then you actually have an overdraft, and that's not good. That's a problem. From time to time, you're going to have seasonal needs for cash, and so you hold marketable securities during slack periods, and you sell them during peak periods. Alternatively, you could use short-term borrowings from your line of credit at your bank to cover the peak periods, and you could repay those when you don't have the cash needs. Or an alternative strategy would be to combine the management of your marketable securities and use some short-term borrowings. One of the tools that are used to manage cash, actually to optimize cash, is called the Baumol model. And it is actually utilizing the similarities between the economic order quantity model that's used for managing inventory, and it's applied for cash management. It does have some simplifying assumptions that include stable, predictable cash flows, and it doesn't allow for too much seasonality or cyclical trends. So if you look at the variables that are included in the economic order quantity model that's used for inventory and the Baumol model that's used for managing cash, you see that each has three primary variables. You have fixed costs, demand for the period, and opportunity costs. So let's look a little bit deeper into these components. So the optimal or ideal level of cash is represented by C asterisk, plus F is the fixed cost of selling securities to replenish cash or the fixed cost of borrowing money. T is the total amount of new cash needed for transaction purposes over a relevant period, which could be a year, a quarter, or a month. And R is the interest rate on the marketable securities. So when you put those together, there's a formula that says the ideal level of cash represents the square root of 2 times T times F divided by R. You can use that formula to calculate your ideal level of cash. Let's look at a couple of different problems that may appear on the exam relating to cash management or accounts receivable management. Let's start with cash management. The Brooks Company's treasurer is considering purchasing a lockbox service from Wyoming Bank. Daily cash receipts are $400,000. If he utilizes this service, he'll be able to reduce his collection time by 2 days. The expected return on the collections is 8%, and the monthly lockbox fee is $2,000. So what will be the annual increase to earnings before taxes from using this lockbox service? Well, first you start by calculating the pre-tax interest on collections. So that would be the $400,000 of daily collections times 2 days times your 8% return, and that's $64,000. Next, you calculate real simply the annual lockbox cost, which would be $2,000 per month times 12 months, or $24,000. So your annual net benefit of using the lockbox service would be your $64,000 of pre-tax interest on collections minus your $24,000 of annual lockbox costs to give you a total of $40,000. $64,000 minus $24,000 gives you $40,000. Let's turn our attention to accounts receivables. Now, outstanding accounts receivables will equal your credit sales times the average time between sales and collections. Now, the optimal credit policy tries to match credit costs with profits from the related sales volume that occurs by offering terms. Easing credit policy stimulates sales, but it also increases your cost. Now, there's several variables that are associated with credit policies. They would include, you have to look at the credit standards of your customer, the credit quality of your customer, the credit period, which is the length of time that credit is going to be extended. You have to decide, am I going to offer cash discounts or not? You have to look at your collection policy. How am I going to handle those past due accounts? Interest income could come into play if you're able to charge a carrying charge on accounts receivable. And also, you can use a tool called aging schedule so that you can highlight any overdue accounts receivables. The final variable that you really have to look at is you have to perform an incremental analysis that really looks at what's the reaction to the new policy, the reaction of the customers as well as the reaction of your competitors. Now, the impact of a credit period increase, that really is the incremental sales that occurs from the period increase times the contribution margin associated with those sales. Now remember, you get more sales, but there are also some costs. So you have to subtract from that to get the impact. You have to subtract the cost of carrying new accounts receivables plus incremental bad debt losses that may occur, plus incremental fixed costs from the increased in the credit period. Now, the carrying cost of carrying new accounts receivables, that equals your incremental investment in accounts receivables. Let's look at credit policy, because that's a big component of your accounts receivable management. If you had policy where you were offering a 3% discount for anybody that pays their accounts receivable off in 10 days, and no discount if you pay beyond 10 days, but you have to pay by 30 days. Well, that's represented by 3/10 net 30. 3% if paid in 10 days, with the net receivable being due in 30 days. Now, some customers will pay on day 10 and take the discount. in this case, if you had a $1,000 receivable and they took the discount, they would have to pay within 10 days, and they would only pay $970. Now, others are going to pay on day 30 and forego the discount, so by day 30, they're going to pay the full $1,000. To find out just how much is it costing you for this credit policy is really a present value or future value problem. And so if you wanted to calculate how much is it costing me, you would actually take the $1,000 and divide it by 1 plus r raised to the 20th over 360 power. And that will equal $970. So if you rearrange the formula using algebra, you would get 1 plus r raised to the 20 over 365 power equals 1,000 over 970. Then you would see that r equals 3.09278%. So doesn't seem like a lot, but over 20 days, it doesn't seem like a lot. But if you actually looked at r and annualized it so that you, again, manipulate the formula, so r equals 1,000 divided by $970 raised to the 365 over 20, not 20 over 365, but 365 over 20 minus 1, you would say that the annual interest rate is 0.7435 or 74.35%. That seems like a high price to pay. So what you really have to do is look at the additional sales from the extended credit and see if those more favorable terms provide a greater return in terms of higher sales, because you have to offset that opportunity cost for those new terms, which is paying 74.35%. Let's look at another problem that is associated with managing receivables. And let's say we have a credit policy change where we lengthen the average collection period. Stiffening Company is evaluating a proposed credit policy change. The changes include decreasing the collection period from what it is currently 60 days to 27 days. Some of the assumptions that we have is we forecast total sales next year of $128 million. That's assuming we don't change the policy. If we change the policy and shorten the collection period, total sales next year will only be 75% of what they otherwise would have been, so 75% of the 128. There will be credit sales under the current policy will be 128 million times 0.75, or 75% of the sales will be credit. And then the number of calendar days that we're going to use for calculating this problem is 360 days. So what is the potential decrease in average accounts receivable balance of implementing the proposed policy? First, we want to calculate the accounts receivables under the current policy. So we would take our 128 million times 0.75, divide that by 360 times 60 days, the current collection period, and we get $16 million of accounts receivables under the current policy. With total sales of 128 million, credit sales under the current policy, which is 75% of total sales, is 96 million. The credit sales reduction under the new policy is going to be $32 million. So our credit sales under the new policy will be the $96 million of credit sales under the current policy minus $32 million of credit sales reduction because of the shortened collection period, and that will equal $64 million of credit sales under the new policy. So finally, what is the potential decrease in average accounts receivable balance of implementing the proposed policy? Well, accounts receivable reduction due to the new policy equals $64 million divided by 360 times 27 days, and that equals $4.8 million. So our accounts receivables with the new policy, we take the $16 million minus the $4 million reduction in accounts receivables of $4.8 million, and our accounts receivables, our average accounts receivable decrease as a result of the proposed policy will be $11.2 million. Thank you for your attention. Welcome back to the Financial Management Review. I'm Ron Harris. We're going to continue our review of working capital. Working capital management requires the balancing of profitability with liquidity. Working capital has a fluctuating layer and a permanent layer. Generally, the fluctuating layer of working capital is financed with short-term borrowings, while because of conservative management, the working capital that's permanent is financed with longer-term debt. And sometimes they use a combination of short-term and long-term to finance the variable and the fixed working capital requirements. When you're looking at your overall working capital policy, you can have a flexible policy or you can have a more restrictive policy. The flexible policy would say that you have large cash and marketable security balances. You would have large inventory investments, of very liberal credit terms, as well as a high level of accounts receivables. A more restrictive working capital policy would have low cash and marketable security balances, small inventory investment, would not allow any credit sales, and therefore wouldn't have any accounts receivables. One of the biggest components of working capital, depending upon your company, is inventory. And the goal of inventory management is to minimize the total cost of holding the inventory. And there's two components to that holding cost. It's carrying costs and shortage costs. And what you're really trying to do is you're trying to balance the cost of having a shortage, not having enough inventory available to either produce your product or to sell the product to meet demand, against the carrying cost, or the cost of actually having and holding that inventory. And you're trying to minimize the total cost by balancing carrying costs with short-term costs, with shortage costs. And if you look at a graph, you would see that the optimal carrying cost would be the optimal investment in inventory would be your investment in inventory on the x-axis with your cost of carrying or cost of shortage being represented on the y-axis, and you're looking at trying to find the point where the two cross, where carrying costs and shortage costs cross, and that will give you your minimum or optimal total cost of carrying inventory. Now, inventory carrying costs includes opportunity costs, because you could get a greater return. There's a possibility that you get a greater return on using the dollars that you've got invested in inventory into some other areas or into maybe some other projects. It also includes the cost of maintaining the economic value of that inventory, such as warehousing costs and refrigeration costs. It's important to remember that if carrying costs decrease, it's cheaper to hold inventory, and that will result in fewer but larger orders of inventory. Now, shortage costs include ordering costs. So the cost of placing an order for more inventory, you have to balance that with having more inventory. It also looks at the costs related to safety reserves. So for example, lost sales that may occur if you don't have enough safety stock or enough inventory to begin with. It may be the customer goodwill that you lose if you don't have inventory on hand when they want to buy it. And from a production standpoint, it may disrupt your production schedules so that you cannot meet the customer requirements. Now, if ordering costs decrease, there's going to be little incentive to minimize your orders. And that's going to result in more orders, but of smaller quantities. There's a tool that you can use to help you manage inventory, and it also could be used to manage production scheduling. But in this case, we're going to look at the tool of economic order quantity, which is the purchase order size that minimizes the total inventory order cost and inventory carrying cost. So when you look at the economic order quantity model, there's three main components to it. There's ordering cost, which is a fixed cost. There's the total dollars of sales, which is demand for a period. And then there's the per unit inventory carrying cost, which is your opportunity cost. What I did for you, because you could get a question on the exam that looks at production related quantities, and so I've actually shown here where you've got the setup costs, which is your fixed cost necessary for a production run, your unit demand, which is demand for the period, and then you've got your per unit carrying costs. Now, looking at the actual formula, economic order quantity equals the square root of 2 times your ordering costs times your average demand divided by carrying cost per unit. What's included in ordering costs would be things like quantity discounts, loss, shipping costs, purchasing costs, and if we were talking about production, it would be setup costs for a manufacturer. Your annual demand is influenced by inventory usage rates. So if you're turning your inventory faster, if demand is high, that's going to actually increase your economic order quantity. And then lastly, carrying cost per unit, and that again includes handling, insurance, interest on invested capital, storage costs, and spoilage and obsolescence. Let's say, for example, we had ordering cost of $100 and we had annual demand or some period demand of 10,000 units, and that our carrying cost per unit was $2. Well, you would just plug those numbers into the economic order quantity model, and you would get 2 times 100 times 10,000, divide that by 2, and your optimal order size, or your economic order quantity, would equal 1,000. Now, in addition to concerning yourself with your order size, you also have to know some other things about managing inventory. First of all, safety stock. Safety stock is extra inventory to cover demand uncertainty. So if the demand has some variability and there's some uncertainty around it, you may have to have some safety stock to prevent stockouts. You also have to understand what's the lead time, which is the time lag between placing an order and the receipt of the goods, because that will determine what your reorder point is. And that is, again, the estimated demand during your lead time. Now, if you have safety stock, that reorder point changes a little bit because it then equals the anticipated demand during the lead time plus the level of safety stock to get your reorder point. Let's look at an inventory management problem to try to understand some of the concepts we've just gone over. The Pickle Pharmacy Company wants to determine the optimal safety stock level for drug alpha. The total cost of safety stock, which equals the carrying cost plus expected stockout costs. Also, the annual carrying cost is 25% of inventory investment. Inventory investment averages about $10 per unit. Stockout cost is $2 per unit. And Pickle orders alpha product 20 times annually. Now, if Pickle has 100 units of safety stock and there's a 15% probability of a 30-unit stockout per order cycle. So the question becomes, and there's a lot of information here, but the question is, what is the annual cost of the 100 units of alpha safety stock. So to get the solution, let's take this step by step. Step 1, first you calculate the annual safety stock carrying costs, average, and that equals your average inventory investment times your annual carrying cost percentage times the units. And so it's $10 per unit, your average inventory investment, times your annual carrying cost percentage, which is 25% per unit, times 100 units, and you get $250 as your annual safety stock carrying costs. Then step number 2, you calculate the number of expected stockouts. Well, the probability of a stockout times your number of order cycles. So 15% is the probability of a stockout times 20 order cycles equals 3 times. Step 3 would be to calculate the stockout cost per occurrence and annually. So there you take your units per stockout, which we said is 30, times your safety stock per unit, which is $2 per unit, and you get $60 of cost per occurrence. And we just saw where we have 3 stockouts per year, so our cost is $180 annually for our stockout. Now, to get the total annual cost, you say your $250 of carrying costs plus $180 stockout cost gives you a total cost of safety stock of $430. Thank you for your attention.
Welcome back to the Bisk Online Review for Business Environment and Concepts. In this class, we're going to begin our discussion of planning and measurement. My name is Bob Manette. I'll be your instructor for this section, and I think you know that in planning and measurement problems, what we are dealing with primarily is manufacturing companies. And of course, any discussion of manufacturing companies will lead inevitably to a discussion on cost accounting. But before we get into cost accounting, I want to start with something a little bit more basic than that. I want to start with some absolutes. I want to start with some concepts that will always be true in any manufacturing company problem, regardless of the cost accounting system that's being used. For example, in all these manufacturing problems, you're always going to be dealing with the same basic flow of activity. It's never going to change. So let's go over it. In all these problems, we are dealing with companies that buy raw material, hire labor to work on the raw material to produce a finished good. That is always the flow of activity. They buy raw material, they hire labor to work on the raw material to produce a finished good. And if you stop and think about it, that flow of activity naturally leads to 3 inventories. If you buy raw material, hire labor to work on the raw material to produce a finished good, you naturally end up with 3 inventories. You end up with an inventory of raw material. You end up with an inventory of work in process. These are partially completed goods, goods you haven't had time to finish, and of course, you have an inventory of finished goods. So you always look for those 3 inventories. It doesn't matter which cost accounting system is being used. Now, one more absolute. In all these manufacturing problems, you will always be dealing with the same 3 basic elements of production. Let's go over them. Number 1 would be direct material. Direct material represents raw material costs applied directly to units. In other words, what your units are made of, essentially. Number 2 would be direct labor. Direct labor represents labor costs applied directly to units. There are people who work on the assembly line. There are people who work on units. That's direct labor. And then the third element of production is everything else. And we call everything else factory overhead. Factory overhead represents all the indirect manufacturing costs. Depreciation on the factory, insurance on the factory, property taxes on the factory, supervisors' salaries, supplies for the factory, utilities. What we do is lump all the indirect manufacturing costs under one heading, factory overhead. So those will always be your three basic elements of production, and they're never going to change in any one of these problems. Now, the first type of problem we're going to look at together is a problem the exam has always liked, and that is how a manufacturing company develops its cost of goods sold. And what you have to remember is that if you're trying to develop cost of goods sold for a manufacturing company, this schedule has three separate and distinct sections. And basically, the three sections follow the three inventories. The three sections are basically going to follow raw material, work in process, finished goods. It just follows the three inventories. Let me show you what I mean. Hopefully you've already downloaded the file for this class, and if you've printed out the problems, we're going to do problems 1 and 2. Notice in problem number 1, they want to know the amount of direct materials that were purchased. Well, let's think about how we develop cost of goods sold for a manufacturing company. The first section is called cost of materials used. And of course, when I say cost of materials used, I mean cost of direct materials used, not indirect materials like supplies. Remember, that's part of factory overhead. That's not what this first section is about. If I'm going to do cost of direct materials used, I start with the beginning inventory of raw material. Then I add the raw material purchases for the period. That gives me material available for use. Then I back out the ending inventory of raw material, and that gives me what I need, cost of direct materials used for the period. It's a pretty logical section. Now let's fill it in as far as we can. We know the beginning inventory of raw material, 15,000. We don't know the purchases, that's missing. So we don't know available, but we do know the ending inventory of raw material, 20,000, and of course the key to this whole thing is in the problem they gave us cost of direct materials used for the period, 95,000. Now I can start working backwards. If cost of direct materials used was 95,000 and the ending inventory of direct material was 20,000, I just added up. Available must have been 115,000, and now I can solve it. If the beginning inventory of direct material was 15,000 and available was 115,000, we must have purchased 100,000 of direct material during the period. So the answer to number 1 is D. Now the second section is called cost of goods manufactured. And in fact, some textbooks call this whole statement a cost of goods manufactured statement. But the middle section is called cost of goods manufactured. And of course, because it's the middle section, I deal with the middle inventory. Remember, the three sections just follow the three inventories. So I'm going to start with the beginning work in process inventory, which in this case was $7,500. Remember, these are partially completed goods, goods I didn't have time to finish. Then I add in the current production cost for the period. What's current direct materials used? 95,000. I got that from the schedule above. Remember, the schedules are connected. That 95,000 we just calculated above in the first section. Now, direct labor, we don't know that. That's what we have to work out in question number 2. Now, how about the overhead? Would I use the actual overhead costs, 72,000, or the applied 75,000? The exam loves giving you this choice. You're going to pick up applied. Anytime you're doing this cost of goods manufactured statement, put in the overhead applied to units. Remember, the difference between your actual overhead costs and your applied overhead, that's your overhead variance. We're going to talk about that in another class. But that overhead variance, some of that overhead variance would be allocated to cost of goods sold. Some of that overhead variance would be allocated to inventory. You don't deal with that now. So if they give you a choice between actual overhead costs and overhead applied in this schedule, you should always put in the overhead applied to units. So that's 75,000. Now, if you add all of that up, that's going to give you your total production costs, which right now I do not know. I do know the ending inventory of work in process, 10,000. And of course, notice what's given here is cost of goods manufactured. Cost of goods manufactured is 257,500. Now, again, I can start working backwards. If cost of goods manufactured was 257,500, and the ending inventory of work in process was 10,000, my total production cost, just added up, must have been 267,500. Now I can plug the direct labor costs for the period must have been $90,000. And the answer to number 2 is C. Let's carry through to the third section. The third section is called cost of goods sold. And if you're going to work out cost of goods sold, you start now with the third inventory, which is finished goods. Remember, the 3 sections follow the 3 inventories. So you start with the beginning inventory of finished goods, $32,500. Then you add the cost of goods manufactured that you just figured out above. Remember, the 3 sections are connected. So that was $257,500. That gives you goods available for sale, $290,000. Back out the ending inventory of finished goods, $25,000, and that would give you cost of goods sold, $265,000, which they did not ask for in this set, but they do fairly often. Just remember, just make sure you know how to do that entire statement, all 3 sections. Now I want to show you a couple of shortcuts. If you're in the exam, you get a problem like this, and they ask you for cost of goods sold, there's a quick way to work out cost of goods sold. You don't have to do out all 3 sections. I show you all 3 sections because, as you've already seen, there can be something missing somewhere in any of the sections. You have to find it and plug it somehow. But if they just want to know cost of goods sold, there's a fast way to get it. If you just want to quickly get the answer, start by adding up all the beginning inventories. You'd add up beginning inventory of direct material, beginning inventory of work in process, beginning inventory of finished goods. They add up to $55,000. Just add up the beginning inventories. Then add in what happened in the current period. Current raw material purchases, $100,000. Current direct labor, remember that came out to $90,000. Current overhead applied, not actual cost, overhead applied, $75,000. If you add that up, notice all I've done to this point is add. That gives me a total of $320,000 of costs. Then I just back out the total of all my ending inventories. I add up the ending inventories of raw material, work in process, finished goods, and oddly enough, they also add up to $55,000, but that would also give you cost of goods sold, $265,000. Sometimes it's good to know that shortcut if you just want to quickly figure out cost of goods sold. Also, that little shortcut will work for you if you want to quickly figure out cost of goods manufactured. If you're trying to figure out cost of goods manufactured, the shortcut also works, but now you just deal with the first 2 inventories. In other words, you'd add up the beginning inventory of direct material and work in process only. They add up to $22,500. Just add up the beginning inventory for just direct material and work in process. Adds up to $22,500. Then you add in the current period costs. Current raw material purchases, $100,000. Current direct labor, $90,000. Current overhead, $75,000. You add it up, that gives you a total costs of $287,500. Then back out the total of ending direct material and work in process, which adds up to $30,000. And that gives you cost of goods manufactured, $257,500. So there's a couple of shortcuts that might come in handy. Now also, when you downloaded the file for this class and you printed out the problems, you'll notice that there are 3 more problems for this class. Let's do 3, 4, and 5. 3, 4, and 5 also require you to think about how a manufacturing company develops the cost of goods sold. In question number 3, they want us to work out prime costs. Well, remember what prime costs are. Prime costs are direct material and direct labor. Those are your prime costs, direct material and direct labor costs. Well, we know the direct labor costs are $30,000. That's given. What you had to work out is the cost of direct materials used for the period. Not purchased, used. So let's work out our section. We're going to take the beginning inventory of direct material, $18,000, plus the raw material purchases for the period, $42,000. That gives you material available, $60,000. Back out the ending inventory of direct material, $15,000. And that gives you what you need, cost of direct materials used, $45,000. If I take the cost of direct materials used, $45,000, and the direct labor costs for the period, $30,000, that gives me my prime costs of $75,000, which is answer D. But prime costs are defined as direct materials used, not purchased, used, and direct labor costs for the period. Those are your prime costs. Now, in question number 4, they want to know conversion costs. Conversion costs are defined as direct labor and factory overhead. Direct labor and factory overhead. So we know the labor payroll, that's given. That's $30,000. What you had to work out is the overhead applied. And notice overhead is applied at $10 per direct labor hour. So you had to work out how many hours they must have worked. If you take the payroll, which is $30,000, divide by the hourly rate, $7.50, we know that they must have worked 4,000 hours. And if they're applying overhead at $10 per direct labor hour, you take that $10 times 4,000 hours, the overhead applied must have been 40,000. The payroll was 30,000. Conversion cost must have been 70,000, which is answer B. Conversion costs are defined as direct labor, and notice overhead applied, not actual overhead costs, overhead applied. Now in question number 5, we have to work out cost of goods manufactured. And once again, it helps if you know the 3 sections. And we know that when you're developing cost of goods sold for a manufacturing company, the 3 sections just follow the 3 inventories. So because cost of goods manufactured is the middle section, we deal with the middle inventory. We're going to start with beginning work in process, which was $9,000. Then you add in the current production costs. What was current direct materials used? $45,000. We worked that out in question number 3. Remember, the sections are connected. Current direct labor payroll, $30,000, that was given. Overhead applied, remember that was $10 an hour times 4,000 hours worked, $40,000. If you add that up, total manufacturing costs come out to $124,000. Then it's just a matter of backing out ending work in process, which is $6,000. That gives you what you need. Cost of goods manufactured, $118,000, which is answer D. But of course, my main point is, don't go in that exam and not know how to develop cost of goods sold for a manufacturing company. And the big thing to remember is the schedule takes 3 sections, and the 3 sections follow the 3 inventories. I will look to see you in our next class. Keep studying. Don't fall behind. Welcome back to our discussion on planning and measurement. And what we're going to get into next is the type of problems the exam can ask on decision making. Before we get into decision making problems, I want to step back and go back to variances for just a moment. Remember in our class on variances, we said that direct material and direct labor are considered purely variable costs. Why is that? Because the amount of cost we incur is directly related to the number of units produced or the number of hours worked. But we also said in that class that factory overhead, our 3rd basic element of production, is really both variable and fixed. And I'm sure you remember why. Factory overhead represents all the indirect manufacturing costs. And the fact is, some of those indirect manufacturing costs we throw under factory overhead would be variable, like supplies. Some of the indirect manufacturing costs that we throw under factory overhead would be fixed, like depreciation. So bottom line is factory overhead, our 3rd element of production, is variable and fixed. And what we're going to get into next in the area of decision making is mixed costs. A mixed cost is a cost element that is considered partly variable and partly fixed. For example, supervisor salaries. That would be a classic mixed cost. Why is that? Because no matter how low production falls, you always need some level of supervision. It's really hard to eliminate supervision. There's always some level of supervision, no matter how low production falls. So some part of it is fixed. On the other hand, if production skyrockets, supervision would go up. So there's a part of it that's variable. Maintenance is another good one. Hey, no matter how low production falls, there's always some level of maintenance, so some part of it is fixed. But if production skyrockets, maintenance would eventually go up. So some part of it is variable. And what you have to know for the exam is the high-low method of breaking down a mixed cost into its fixed and variable parts. Let's go to question number 1. Matt Company. Notice that when Matt handles 80,000 kilos, Matt spends $160,000 on handling costs. But when Matt handles 60,000 kilos, Matt spends $132,000 on handling costs. The question is, what would handling cost be if Matt handles 75,000 kilos? God only knows what Matt is dealing with here with these kilos. We don't have to get into that. But what does it really cost Matt to handle 75,000 kilos? Well, as I've already said, what you have to know for the exam is the high-low method of breaking down a mixed cost into its fixed and variable parts. Here's the key to it. In the high-low method, you take the change in cost, and divide by the change in activity. That's the secret to it. It's the change in cost, and you divide by the change in activity. So let's put this in. We know that when Matt handles 80,000 kilos, Matt spends $160,000 on handling costs. When Matt handles 60,000 kilos, Matt spends $132,000 on handling costs. The point is, when kilos went up 20,000, handling costs went up 28,000. Again, you're going to take the change in cost, and you're going to divide by the change in activity. If you take the change in cost, $28,000, divide by the change in activity, an additional 20,000 kilos, what that tells you is that $1.40 of every kilo must be purely variable handling costs. When you take the change in cost and divide by the change in activity, what you're isolating is the variable part of the cost. Now, here's the point. Once you have the variable part of the cost, now you can plug the fixed. All you have to do to get the fixed is go to any level of activity they gave you in the problem. I'll use 80,000 kilos. What do we now know happens at 80,000 kilos? Well, at 80,000 kilos, we now know from the last question that $1.40 every kilo is purely variable handling. So you multiply that out at that level, they're spending $112,000 on variable handling. Well, $48,000 must be fixed. Why? Because that gets you back to the $160,000 they spent in total on handling costs at that level. Just to show you it doesn't matter what level you test, let's go to 60,000 kilos. At 60,000 kilos, we now know $1.40 every kilo is purely variable handling costs. You multiply that out. At that level, they're spending $84,000 on variable handling. Well, $48,000 must be fixed. That gets you back to the $132,000 they spent on that level. Notice once you have the variable part of the cost, then you can plug the fixed. All right, now we can answer the question. What does it really cost Matt to handle 75,000 kilos? Well, if Matt handles 75,000 kilos, we know that $1.40 every kilo is purely variable handling. You multiply that out. At that level, Matt is spending $105,000 on purely variable handling. $105,000. What's fixed? It's got to be $48,000. Fixed is fixed. It's set in amount. It's not going to rise and fall with activity. That's the nature of fixed costs. So fixed would still be $48,000, and Matt spends $153,000 at that level. And the answer is B. Make sure you know the high-low method of breaking down a mixed cost. Now, another thing about our classes on cost accounting, I want to make sure that you're aware that when we went through cost accounting together, when we went through job order costing and process costing and standard costing, in all those areas, what we were talking about was absorption costing. Let me define that. Under absorption costing, the units that are produced absorb all manufacturing costs, both the variable and the fixed. That's what's meant by absorption costing. The units you produce absorb all manufacturing costs, both the variable and the fixed. In other words, in absorption costing, both the variable and the fixed manufacturing costs are considered part of unit cost. Both the variable and the fixed manufacturing costs are considered inventoriable. They find their way to inventory. I bring this up because when you get into decision making, then you're introduced to another way of costing units. It's called direct costing or variable costing. Under direct costing or variable costing, only the variable manufacturing costs are considered part of unit cost. Only the variable manufacturing costs are considered part of unit cost. The fixed manufacturing costs, the fixed part of factory overhead, the fixed manufacturing costs in direct costing are going to get treated as a period expenditure, an expense of the period, not a product cost. Let's go right to a set of problems. Let's go to 2 and 3. In question number 2, they ask what would operating income be under direct costing, and in question 3, they ask what's finished goods under absorption costing. Well, I want to start with I'm going to start with question number 3 first. Let's do absorption costing, and let me just say this to you again. If you're in the exam and they ask you anything about absorption costing, just go back in your mind to what we did in cost accounting, because that's what absorption costing is all about. So in this problem, let's work out what finished goods would be under absorption costing. First of all, if you read the introduction, notice they produced 100,000 units. They sold 80,000. So there must be 20,000 units in finished goods, and they did say there's no beginning inventory to worry about. So all we know is they produced 100,000 units, they sold 80,000. So we know there are 20,000 units in finished goods. Let's work out the unit cost under absorption costing. Under absorption costing, would you pick up the $4 of material? Of course you would. Would you pick up the $2.50 of direct labor? Of course you would. Would you pick up the $1.50 of purely variable overhead? Absolutely, you'd pick that up. How about the variable selling, $2 per unit? No. That's a selling expense. Belongs below gross profit. It's not a manufacturing cost. It's not an inventoriable item. So don't fall for that. Not that $2. That's a selling expense. Belongs below gross profit. That's not an inventoriable item. It's not a manufacturing cost. And, of course, same thing with the fixed selling. Not a manufacturing cost. It's a selling expense. Belongs below gross profit. But in absorption, we would take that 240,000 of fixed factory overhead, divide by 100,000 units of production, and put $2.40 of fixed factory overhead on every unit you produce. The unit cost under absorption comes out to $10.40. Notice the units that are produced absorb all manufacturing costs, both the variable and also the fixed. That fixed factory overhead is part of unit cost in absorption. So if I take that unit cost, $10.40, times the 20,000 units in finished goods. They produced 100,000 units, they sold 80. There's 20,000 units in finished goods. In absorption, they're valued at $10.40 each. Finished goods is valued at $208,000. So the answer to question number 3 is B. So we've got that one. Now question number 2 asks about direct costing. Before we answer question number 2, what if they had asked me for finished goods inventory under direct costing? They didn't ask that here. But let's do an analysis here. What if they'd asked for finished goods inventory under direct costing? Well, if I'm using direct costing, remember, only the variable manufacturing costs are part of unit cost. Only the variable manufacturing costs find their way to inventory. So in direct costing, I'd pick up the $4 of direct material. That's purely variable. I'd pick up the $2 of direct labor. That's purely variable. I would pick up the $1.50 part of overhead. That's purely variable. Again, the variable selling, no. Even though it's variable, you don't pick it up because it's not a manufacturing cost. It's not inventoriable. Fixed selling, of course not. Don't pick that up. It's not a manufacturing cost. It's a selling expense. Belongs below gross profit. And the fixed factory overhead, no. The fixed factory overhead will be treated just like the fixed selling, an expense of the period, not a product cost. So notice if you add it up, the unit cost under direct costing or variable costing would come out to $8. So if they'd asked me for ending inventory under direct costing, I would take the 20,000 units in finished goods times $8. The answer would be 160,000. They didn't ask that, but that would be finished goods under direct costing. Now there's a couple of relationships that I think ultimately you just memorize, because I think these relationships always help you in the exam. All else being equal, if you produce more units than you sell, absorption will give you more profit than direct. I think I'd memorize that. If you produce more units than you sell, absorption gives you more profit than direct. For example, in this problem, didn't they produce 100,000 units, sell 80. So what did you do? If you produce 100,000 units and you sell 80,000, didn't you add 20,000 units to finished goods? And in absorption, there'd be $2.40 of fixed overhead in every one of those units. So what you're doing is taking $48,000, 20,000 units times $2.40. You're taking $48,000 of fixed overhead costs you incurred this period, but you're deferring it. You're putting it on the balance sheet in inventory. So the expenses under absorption are $48,000 less. The profit is $48,000 higher under absorption. So all else being equal, if you produce more units than you sell, absorption gives you more profit than direct. All else being equal, if you produce less units than you sell. If you produce less units than you sell, absorption gives you less profit than direct. Notice the mores and lesses go together. That's why I'm phrasing it the way I am. If you produce more than you sell, absorption gives you more profit. If you produce less than you sell, absorption gives you less profit. And if you produce the same number of units that you sell, absorption gives you the same profit as direct. I would know those relationships. Now let's handle question number 2. Question number 2 says, all right, what is operating income under direct costing or variable costing? Well, of course, the tempting thing is to sit in the exam and try to do out a whole income statement. I would not do that. There's a little shortcut. Don't do out a whole income statement. The fast way to do a problem like this, if they want to know the operating profit under direct costing, which is a very typical question in a decision-making type of question, the key to answering it is to figure out contribution margin per unit. What does the sale of each unit contribute to the recovery of fixed costs? That's a very powerful piece of information. That's what you want to focus in on. Contribution margin per unit. What does the sale of each unit contribute to the recovery of fixed costs? Well, let's work it out. I know the selling price per unit here is $20. Now, what do I back out of there to get contribution margin? Variable costs. So I'm going to take out the $8 of variable manufacturing costs. Remember, that $8, that's what would go to inventory under direct costing. Those are all your variable manufacturing costs, the $4 of material, the $2.50 of labor, the $1.50 of variable overhead. Remember, that $8, that's what goes to inventory under direct costing. It's all variable. So take out the variable manufacturing cost of 8. Would I back out the variable selling of 2? I would, because there's no contribution to fixed costs till you cover all your variable costs, even that variable selling. So I'll back out that variable selling also of $2 per unit. The contribution margin per unit comes out to $10. That's the definition of contribution margin. Contribution margin is defined as selling price minus all variable costs, not just the variable manufacturing, which goes inventory, $8. You'd also pick up the $2 of variable selling, because again, you have no contribution to the recovery of fixed costs until you cover all your variable costs, including that variable selling. So you take the selling price per unit, 20, minus all the variable costs, the $8 of variable manufacturing, the $2 of variable selling, you've got $10 of variable costs. So the contribution margin per unit is $10. Now I know every time they sell a unit, it contributes $10 to the recovery of fixed costs. How many units did they sell? They sold 80,000 times 10. There's your total contribution margin, 800,000. Now just back out your fixed costs. Once I know that sales contributed 800,000 to the recovery of fixed costs, now I just back out the fixed costs. Fixed factory overhead, 240,000 a year. Fixed selling, 140,000. That gives me a profit of 420,000. So the answer to number 2 is B. That's a quick way to work out profit under direct or variable costing. The key is to work out that contribution margin per unit. That's the way you want to start to think. Let's do another question. Let's go to question number 4. Under variable costing, which costs are assigned to inventory? How about, am I going to assign variable factory overhead? Yes. Remember, in variable costing or direct costing, only the variable manufacturing costs are considered part of unit cost. Only the variable manufacturing costs are considered inventoriable. So the variable part of overhead, that's a variable manufacturing cost. We pick that up. How about variable selling? No. That's a no. That's a selling expense. Belongs below gross profit. That's not an inventoriable item. And the answer is D. No, yes. Question number 5. K had fixed factory overhead of $100,000. variable selling of 80,000. Under direct costing, under variable costing, what's a product cost, what's a period cost? Well, remember, the key point is, in variable costing or direct costing, you're going to treat the fixed factory overhead just like the fixed selling. It's not a product cost, it's a period cost. It's an expense of the period. The answer is D. You want all 180,000 under period cost, nothing under product cost, because that's the whole point of direct costing. Variable costing. Direct costing or variable costing treats the fixed factory overhead just like the fixed selling, an expense of the period, not a product cost. So it's all of it under period cost, nothing under product cost. Answer D. Question number 6. They want to know the unit cost, the inventoriable unit cost under direct or variable costing. Well, you know, under direct costing, only the variable manufacturing costs are considered part of unit cost. So I'm going to pick up the direct material and direct labor of 200,000. I'm going to pick up the 45,000 of purely variable overhead. That's a variable manufacturing cost. The fixed factory overhead, no. That's going to be treated as a period expenditure, not a product cost. The variable selling, no. That's a selling expense. Belongs below gross profit. It's not an inventoriable item. If you add it up, the total cost I'm going to assign to inventory, 245,000. 200,000 of material and labor, 45,000 of variable overhead. 245,000. If I take that 245,000, divide by the 10,000 units produced, the unit cost under direct costing is $24.50. Answer A. Question number 7. They say operating income under direct costing compared to absorption costing would be higher. They're asking you, when would absorption be lower than direct, right? That's the question. When is income under absorption lower than direct? Well, that's why I think it's good to memorize those relationships. Remember, all else being equal, if you produce more units than you sell, absorption gives you more profit. If you produce less units than you sell, absorption gives you less profit. So I'm looking for an answer here. Now, once I know that absorption is less than the direct, then I know they produced less than they sold. And if they produce less than they sold, inventory is going down. I'm looking for an answer where inventory is going down, and the answer is B. If beginning inventory is greater than ending, inventory is going down. Answer B. Beginning inventory is greater than ending, inventory is going down. And why is inventory going down? They produced less than they sold. And if you produce less than you sell, absorption gives you less profit than direct. I would know those relationships. Keep studying. Don't fall behind. Keep up with your homework. I'll see you in the next class. Welcome back to our discussion of the kind of problems that you can get in the exam on decision making. And if you looked at your viewer's guide, you know that the first 2 questions for this section I wanted you to get done before watching the class. Let's do the first 2 questions. In question number 1, they want to know what finished goods inventory would be under direct or variable costing. And I'm sure you noticed that in this year they produced 10,000 units, but they sold 9,000. If you produce 10,000 units and you sell 9,000, given that there are no beginning inventories, there must be 1,000 units in finished goods. And now we're going to value that finished goods inventory under direct or variable costing. And we know under direct or variable costing, only the variable manufacturing costs are considered part of unit cost. Only the variable manufacturing costs are considered inventoriable. So let's go through it. We know that the direct material of 20,000, that is a purely variable manufacturing cost. So we'll divide by the 10,000 units produced and put $2 of direct material on every unit produced. The direct labor of 10,000, we know that that's a purely variable manufacturing cost. We divide by the 10,000 units produced, put $1 of direct labor on every unit. The variable factory overhead of $6,000, that is a variable manufacturing cost. So we divide by the 10,000 units produced and put 60 cents of variable overhead on every unit produced. The unit cost under direct or variable costing is $3.60. Notice that the $12,500 of fixed factory overhead, That's not part of unit cost, not under direct or variable costing. The $12,500 fixed factory overhead, that's going to be treated as a period expenditure, just like fixed selling, fixed administrative costs. We're not going to treat that as an inventoriable cost. So the unit cost under direct or variable costing is $3.60. And if there's 1,000 units in finished goods times $3.60, the answer is A. Finished goods is valued at $3,600. Question number 2 says, which method, absorption or variable costing, would give you the highest income, and by what amount? Well, first of all, if you remember the relationships we talked about in our last class, if you produce 10,000 units and sell 9,000, if you produce more than you sell, absorption gives you more profit. Right away you know that, so it has to be A or C, because absorption is going to give you more profit. But they also want to know by what amount. Well, remember, in absorption, they're going to take that $12,500 of fixed factory overhead. They're going to divide by 10,000 units produced, and in absorption, they're going to put $1.25 of fixed factory overhead on every unit produced, because that's the whole point of absorption costing. The units that are produced absorb all manufacturing costs, both the variable as well as the fixed. So if you produce 10,000 units and sell 9,000, you're adding 1,000 units to finished goods. And in absorption, there'd be $1.25 of fixed overhead on every one of those units. So what you're really doing is taking $1,250 of fixed overhead you incurred this period, but you're deferring it. You're putting it on the balance sheet. So the expenses on the income statement are $1,250 less. Profit is $1,250 higher. Under absorption, the answer is A. Now, what I want to do next is look at a couple of relationships that turn up a lot in questions in the exam. Let me just mention a hypothetical. Let's say that a company sells units for $8 each. Their variable cost per unit, $2. Their fixed costs are $10,000 a year. Now, we're going to look at this situation under 2 levels of activity. First, let's assume that they produce and they sell 1 unit. Let's go through some categories. If they produce and they sell 1 unit, at that level, what's total fixed cost? Would still be $10,000, wouldn't it? Still be $10,000, because fixed is fixed. It's set in amount. That budget does not rise and fall with activity. So as far as we know, if they produce 1 unit, total fixed cost would still be $10,000. What about fixed cost per unit? The next category. Well, I've got to take 10,000 of fixed costs, divide by 1 unit. Wouldn't the fixed cost per unit also be 10,000? That's simply taking the 10,000 of fixed costs, dividing by 1 unit. Fixed cost per unit would also be 10,000. What about variable costs per unit? It would still be $2. That hasn't changed. Total variable costs? Well, I produced and sold 1 unit. There's $2 of variable cost in each unit, would be also $2. How about total costs? Well, my total costs, I've got 10,000 of fixed, $2 of variable. Total cost would be $10,002. $10,002. Sales at the level would just be sold 1 unit for $8. Sales would be $8. And then the last category, what's the ratio of variable cost to sales? Well, if I take their total variable cost, $2, over the total sales, $8, 25%. Now let's look at the same categories if they produce and they sell 10,000 units. If they produce and they sell 10,000 units, what's total fixed costs? Still 10,000. Fixed is fixed. It's set in amount. What's fixed cost per unit? Well, that's gone down to $1, because now I'm taking my total fixed cost, 10,000, dividing by 10,000 units produced. Fixed cost per unit has gone down. So notice something. Notice fixed costs in total stay the same. Fixed cost per unit fluctuate. Notice as production rises, fixed cost per unit go down. The exam plays a lot of word games with these kind of concepts. Yeah, fixed costs in total stay the same. Fixed cost per unit fluctuate. As production rises, fixed cost per unit goes down. As production falls, fixed cost per unit rises. So fixed cost per unit does fluctuate. How about my variable cost per unit? Would still be $2 at any level. So variable cost per unit stays the same. How about total variable cost? Well, now I've produced 10,000 units times 2 would be $20,000. Notice variable costs are exactly the opposite of fixed in the sense variable costs in total fluctuate. Variable cost per unit stays the same. It's really the exact opposite. Fixed costs in total stay the same. Variable costs in total fluctuate. Fixed cost per unit fluctuates. Variable cost per unit stays the same. You have to get used to these relationships. Now, of course, total cost, that would always fluctuate depending on the level of activity. Now, my total cost, I've got 20,000 of variable, 10,000 fixed, 30,000. You know total costs are going to fluctuate with activity. How about my sales? I sold 10,000 units at $8 each, 80,000. And then my final category, the ratio of variable cost to sales, if I take the total variable cost, 20,000, over sales, 80,000, it's still 25%. That does not change at any level. That has remained the same. I'll show you just one way they could hit something like this. Look at question number 3. It says when production is increasing, that's all we know, production is increasing, within the relevant range, a flexible budget is used. What is the anticipated result on each of the following? Well, if production is rising, what's going to happen to fixed cost per unit? It's dropping. Fixed cost per unit goes down. I think a lot of people in the exam go too fast and they go, oh, fixed costs are always the same. Not per unit. Not per unit, like in the example we just went through. At 1 unit, my fixed cost per unit were 10,000. At 10,000 units, fixed cost per unit would be $1. Fixed cost per unit is going down if production's rising. How about variable cost per unit? No change. Stays the same. Let's go to question number 4. In question number 4, we're asked, what is the break-even point in units? And this gives me a chance to say that one formula you would definitely memorize for the exam, just flat out memorize, is the formula for determining the break-even point in units. You know what break-even point is. Break-even point is the point of sales where there's no profits and there's no losses. And you cannot go into that exam and not have memorized the formula for the break-even point in units. Let's go over it. To figure out the break-even point in units, in the numerator, you put total fixed costs. You want to put fixed factory overhead, fixed selling, fixed administrative costs. You want your total fixed costs in the numerator. Remember, you don't break even until you cover all your fixed costs. Not just your fixed factory overhead. You've got to cover your fixed factory overhead, your fixed selling, your fixed administrative costs. So that's what goes in the numerator, total fixed costs. You're going to divide by our old friend, contribution margin per unit. As we said in another class, one of the critical questions in the exam is, what does the sale of each unit contribute to the recovery fixed cost? You can do a lot with that. You want to figure out contribution margin per unit. That's the formula. Total fixed costs divided by contribution margin per unit will give you break-even point in units. So let's get to work here. First of all, what's total fixed costs? Well, notice that the fixed factory overhead is applied at $7 a unit. The fixed selling and admin is applied at $3 a unit. They're applying $10 of fixed overhead on every unit, and that's based on this current level, which is $900,000 of sales. The selling price is $20 a unit. So if you take $900,000 of sales, divide by 20, they must have sold 45,000 units. And if they're applying $10 of fixed overhead on every unit, again, that's $7 of fixed factory overhead, $3 of fixed selling and admin. If they're applying $10 of fixed overhead on every unit they produced, and that's based on 45,000 units of activity, total fixed cost must be $450,000. So that gives me my numerator. Total fixed costs. Notice that's both the fixed factory overhead, the fixed selling, the fixed admin, has got to add up to $450,000. Now I want to divide by contribution margin per unit. How do I get that? Well, contribution margin is defined as the selling price minus all variable costs. So I'm going to take the selling price, 20. I'm going to back out the prime costs of 6. You know, prime costs are direct material, direct labor. I'm going to back out the variable overhead, $1. How about the variable selling? That's right, back it out. It's not that variable selling would go to inventory. It wouldn't. But if I'm analyzing break even, I have no contribution to fixed costs till I cover all my variable costs. Remember, the definition of contribution margin is selling price minus all variable costs, not just what goes to inventory, minus all variable costs. So I'm going to take the selling price 20, minus the prime cost, direct material and direct labor of 6, minus the variable overhead of 1, minus the variable selling and admin of 1. My contribution margin per unit is 12. Every time they sell a unit, it contributes $12 to the recovery of fixed costs. So now I can solve it. If I take the $450,000 of fixed costs, divide by 12, break-even point in units is 37,500, answer C. If they sell 37,500 units, they'll hit the break-even point, that point of sales where there's no profits, no losses. Let's go to question number 5. Question 5 says, what is the most likely strategy to reduce the break-even point? What's going to have you reduce that break-even point? Well, look at answer C. First of all, if you decrease fixed costs, that makes sense, right? Because that's the numerator. The numerator goes down. That's certainly going to lower your break-even point if nothing else changes. But also in answer C, you increase contribution margin. I increase the denominator. If I lower fixed costs, the numerator, and I increase the denominator, contribution margin per unit, I've definitely lowered the break-even point. I've reduced it without question, and the answer is C. Let's go to question number 6. 6 and 7 are also a set on break-even. 6 says, how many radios must S sell to earn an operating income of $35,000? So notice, I've got to work out how many radios I have to sell to generate this profit of $35,000. Well, this formula that you really have to memorize is very useful because you can use it here also. All you have to do in this case is take the total fixed costs, which are $15,000, add the profit that you want to generate, $35,000, that adds up to $50,000, and divide by good old contribution margin per unit. We know the selling price here is $30 a unit. Variable costs are 20. The contribution margin per unit is 10. Now I have everything I need. If I take the total fixed costs of $15,000 plus the profit before tax that I want to generate, $35,000, that adds up to $50,000. Divide by contribution margin per unit. I know every time they sell a unit, it contributes $10 to the recovery of fixed costs. That's the selling price 30 minus variable cost 20. If I sell 5,000 radios, answer A, I'll generate a $35,000 profit before tax. 7 says, what's break-even point in dollars? Well, let's figure out break-even point. We know that formula. That's the total fixed cost, $15,000, divide by contribution margin per unit, which is $10. If they sell 1,500 radios, they'll hit the break-even point. They sell radios for $30 each. Notice here they don't want it in units. They want it in dollars. Don't forget that the formula that I had you memorize, fixed cost divided by contribution margin per unit, that gives you break-even point in units. That tells you how many units you have to sell to break even. But sometimes the exam doesn't cooperate. They want break-even point in dollars. Well, it's still a useful formula. Because if I can figure out break-even point in units, that's the fixed cost, $15,000, divide by contribution margin per unit, 10. If I know they have to sell 1,500 radios to break even, if they want it in dollars, I just multiply by the selling price. I sell radios for $30 each. Break-even point in dollars is $45,000. Answer C. Now there's another way to get that. Because sometimes this comes in handy. One way you can get break-even point in dollars is to do what I just did. Figure out the break-even point in units, multiply by the selling price. But there's another way you can get break-even point in dollars, and sometimes this comes in handy. We know that they sell units for $30 each. Variable costs are 20. Notice variable costs are 2/3 of selling price. Contribution margin is $10 or 1/3. Contribution margin per unit is $10, 10 over 30, or 33 1/3%. That 33 1/3%, that's called the contribution margin per ratio. That's the contribution margin ratio. The other way to get the break-even point in dollars is simply to divide your fixed cost, $15,000, by that contribution margin ratio, which is 33%. That'll also give you $45,000. So one more time, you want to get break-even point in dollars, you can either figure out the break-even point in units, multiply by the selling price, or if you don't have that kind of information, just take the total fixed cost, in this case $15,000, divide by the contribution margin ratio. Selling price is $30. Think of it as 100%. Variable costs are 20, which is 2/3 of that, 66 2/3%. Contribution margin per unit is 10 over 30, or 33 1/3%. If you take the fixed costs, 15,000, divide by 33 1/3%, the contribution margin ratio, you'll get 45,000, break-even point in dollars. That's the other way to get break-even point in sales. In question number 8, they want to know the break-even point in dollars. Now, all we know in this problem is that their sales are 800,000, and again, think of that as 100%. We know variable expenses are 160,000. Notice variable costs are 20% of sales. Well, if variable costs are 20% of sales, contribution margin ratio is 80% of sales. Remember, that's always a function of 100. If variable expenses are 10% of sales, contribution margin ratio is 90% of sales. And that's always a function of 100. So here we know that the variable expenses are 160,000 over sales 800,000. Variable expenses are 20% of sales. So contribution margin ratio is 80% of sales. All right, now I can solve this in a couple of different ways once I know that. First, I could do trial and error if I wanted to. I could say, how do I get break-even point in sales? Well, is it A? Let's say the answer is A. It's 200,000. I know the contribution margin ratio is 80%, so I multiply by 80%. The contribution margin for answer A is 160,000. Back out the fixed cost, 40,000. No, there's 120,000 of profit in answer A. That's not the break-even point. How about C? What if the sales are 50,000? Contribution margin ratio is 80% of that. So total contribution margin would be 40,000. That's just enough to cover the fixed cost, 40,000. Yes, I do break even in answer C. You could just do trial and error there. Or go back to the formula. If I take the total fixed costs, 40,000, divide by the contribution margin ratio, which is 80%, that'll also give me 50,000. Remember that little trick? You take total fixed costs, divide by that contribution margin ratio, which in this case is 80%. That'll also give you the break-even point in dollars, which is 50,000. In question number 9, they want to know what the fixed costs are. How do we figure out fixed costs? Well, we know that the sales are 200,000, and we know that the margin of safety is 80,000. Well, you have to know what margin of safety means. It's a definition you have to be aware of. Margin of safety is defined as how far the sales would have to drop before you incur a loss. How far your sales would have to drop before you incur a loss. That's margin of safety. So if right now sales are 200,000 and there's a margin of safety of 80, then the break-even sales must be 120,000. Again, margin of safety is how far the sales would have to drop before you start incurring losses. So if sales are 200,000 and margin of safety is 80,000, then back out the 80, break-even sales must be 120,000. Margin of safety is really how far above break-even you are. So now I can solve it. If I know break-even sales are 120,000, they said that my contribution margin ratio is 20%. So if I take 20% of 120,000, notice that comes out to 24,000. My contribution margin must be, at that level, 24,000. And remember, at break-even, my contribution margin is just enough to cover my fixed cost, which must also be 24,000. And the answer is B. So remember that definition of margin of safety. It's how far your sales would have to drop before you incur losses. It's how far above break-even you are. So in this case, sales are 200,000. Margin of safety is 80. Well, break-even sales must be 120,000. And if the contribution margin ratio is 20%, then at that level, at break-even, 120,000 in sales, contribution margin must be 24,000. And at break-even, that contribution margin is just enough to cover my fixed costs. Fixed cost must be 24,000. As I say, answer B. Question number 10. Question number 10 says, Lake increased their direct labor wage rates. So direct labor is going up. is direct labor a variable or a fixed cost? You know, it's a variable cost. So one of my variable manufacturing costs is going up. That's all I know. Direct labor, wage rates are going up. All of the costs remain the same. All of the revenues remain the same. Well, first of all, what's going to happen to your budgeted break-even point? Well, if my sales price remains the same and all that's happened is one of my variable costs has increased, then my contribution margin has shrunk. Contribution margin per unit is going down. I have to sell more units to break even. So you want increase under that first column. There's going to be an increase in my budgeted break-even point. My selling price is staying the same, but one of my variable costs is going up. So contribution margin per unit is going down. I'm generating, less profit out of each unit. I have to sell more units to break even. How about my margin of safety? Well, margin of safety is how far my sales would have to drop before I incur losses. How far above break even I am. Well, if my break even point is going up, then my margin of safety, I'm not as safe as I was. It is shrinking. And the answer is B. Please continue with your homework. Don't fall behind. I will look to see you in the next class. Welcome back to our discussion on decision making, and our next topic is really the heart and soul of decision making, and that is profit analysis. And the CPA exam tends to get you into profit analysis in a couple of different ways. First, they may give you a problem on a special order. They'll say, a factory normally sells units for $75 each. A special order comes in. Someone's willing to buy 10,000 units for $62 each. Should the company accept the offer? So that's very often how you will see a profit analysis problem laid out, as some sort of special offer. Another thing the exam likes, make or buy decisions. I'm sure you've seen these kind of problems before. It costs so much to make a motor, so much to buy a motor. What's the best thing for the company to do? What's the best thing for the bottom line? Should they make it or should they buy it, and why? These are classic problems that come up on profit analysis. And before we do a couple, I just want to give you one quick point, and that is the key to all of these problems, whether it's a special offer or a make or buy decision, is you only look at what changes if you accept a given proposal. That's the key to all of these problems. The analysis is just look at what changes if you accept a given proposal. In other words, you only look at variable items. Fixed costs are irrelevant to a decision like this. Why? Because the fixed costs go on whatever I do, right? If costs are fixed, if they're set in amount, I'm going to incur the same amount of costs whether I accept the special offer or reject it. I'm going to incur those same fixed costs whether I make the part or buy the part. Therefore, they have no bearing on the decision. And that's really the key to these problems. Only look at what changes if you accept a given proposal, which is to say, only look at variable items. Let's look at questions 1 and 2. Questions 1 and 2 are about Golden Company. Golden Company manufactures 5,000 units of part 10541. And in question number 1, they say, in deciding whether to make or buy the part, what does it really cost to make it? What is the relevant cost to make the part? Well, let's look at what it costs to really make this. I'm going to have to pick up the $2 of direct material. I'm going to have to pick up the $8 of direct labor. I'm going to have to pick up the $4 of purely variable overhead. I have to pick up that first $14 because those costs are all variable. I only incur those $14 of costs if I make a part. So, of course, I have to consider that. And what you'll learn very quickly from doing problems like this is you have to read very carefully what they say about the fixed. Let's read what they say about the fixed. It says, Golden has also determined that if they buy the part from Brown, 2/3 of the fixed overhead applied will continue. 2/3 of that fixed overhead applied to the part will continue even if the part is purchased from Brown. So think about it. The fixed overhead that's applied to each part here, $6, they're saying 2/3, 4 of the 6, will continue regardless of what they do. Well, if 4 of the 6 are fixed, will continue regardless of what decision they make, it has no bearing on the decision. You're stuck with it. It's a fixed cost. But isn't that another way of saying that 1/3 of the 6, $2 of the $6 are fixed, won't continue if I go out and buy the part, only will continue if I make the part. I'll say that again. 1/3 of the 6, $2 of the $6 of fixed overhead applied to each unit, won't continue if I go out and buy the part. So only will continue if I make the part. So it becomes another relevant cost to make the part. What does it really cost to make a part? It costs $2 of material, $8 of labor, $4 of variable overhead, and $2 of fixed that won't continue if I go out and buy the part, only will continue if I make the part. I got to consider it. It really cost me $16 to make the part. $16 times 5,000 parts. What it really costs to make the part is $80,000. Answer B. Now, in number 2, they say, should Golden accept Brown's offer and why? Well, Brown is offering what? Brown will sell us 5,000 units for $19 each. Let's work it out. If we buy 5,000 units from Brown at $19 each, that's $95,000. But if I buy the part from Brown, that frees up the facilities, and notice I can make product RAC and generate $4,000 of profit. So what does it really cost me to buy the part from Brown? It cost me $95,000, 5,000 parts at 19, minus the $4,000 of profit I can make on product RAC by freeing up the facilities. What it really cost me to buy the part is $91,000. What it really cost me to make the part is $80,000. The answer is A. Now, I reject this. I'm going to reject it. Why? Because it's $11,000 cheaper to make the part. The answer is A. That's sort of a classic illustration of profit analysis. Let's do another one. Question number 3. Notice in question number 3 we have East Division. East Division, notice, has incurred a $25,000 operating loss if you look at the income statement. And what they want to know is if East is eliminated, what's the effect on operating income? If that East Division is eliminated, what is the effect on operating income? Well, let's start with what everything looks like before we eliminate East. Before I eliminate the East Division, isn't the total contribution margin $390,000 for West, $70,000 for East? It's $460,000 total contribution margin. What's total fixed cost? $110,000 for West, $50,000 for East, $160,000. So my profit contribution after fixed costs would be $300,000. Back out the corporate costs of $180,000. That's $135,000 for West and $45,000 for East. Back out the corporate cost of $180,000. Right now, before I eliminate East, I am making $120,000 profit. Now, what happens if I eliminate East? If I eliminate East, now I lose East's contribution margin of 70, so now my total contribution margin is just that $390,000 for West. How about fixed costs? Yeah, the fixed cost now would just be the $110,000 for West. They say that East's fixed costs would be eliminated. They did say in the problem that if East is eliminated, the fixed cost for East could be avoided. So now my fixed costs are just $110,000. That gives me a total contribution margin of $280,000. What are my corporate costs? My corporate costs would still be $180,000. They didn't say I'd eliminate the corporate costs allocated to East. That still exists. So my total corporate costs are still $180,000. So notice my profit is now $100,000. My profit for the company was $120,000 before I eliminated East. It's $100,000 when I eliminate East. The answer is A. If I eliminate East, my total profit is $20,000 lower. Again, the key is just look at what changes if you make a certain decision. Only look at variable items. What's going to change? That's always the question. Question number 4. Rice is going to discontinue a department that has a $24,000 contribution margin. So that's all we know. They're going to eliminate a department that has a $24,000 contribution margin, a $24,000 contribution to the recovery of fixed costs. Now, $48,000 of costs are allocated to this department, but they said $21,000 of that 48 cannot be eliminated no matter what you do. Well, if $21,000 of the $48,000 cannot be eliminated no matter what you do, then don't worry about it. You're stuck. That $21,000 is irrelevant to the decision. If the cost is going to go on whatever you do, you're stuck with it. It's fixed. Don't worry about it. But isn't that another way of saying $27,000 of the $48,000 can be eliminated? So I'm losing $24,000 of contribution margin, that's true, by eliminating the department, but I'm also eliminating I'm eliminating $27,000 of costs. So I lose $24,000 of contribution margin. I've eliminated $27,000 of costs. Overall, I'm $3,000 better off. The answer is C. The total effect on my profit is a $3,000 increase. Lose $24,000 of contribution margin, but save $27,000 of costs. Overall, my profit is $3,000 higher if I eliminate the division. Answer C. Question 5. Cuff Caterers. Cuff Caterers is on the phone, and they quote a price. They're going to charge $60 per person for some dinner party. So you're stuck with that. Someone's on the phone, and they've quoted that price, so you're stuck with that. And they want to know, all right, if you're stuck with that, if you're only going to get $60 from each person, what can you charge for the food? Well, they say that there's a sales tax of 6% on the food plus the service charge, and there's a 15% service charge just on the food. So if you're stuck on a $60 charge per person, given these other charges, what can you charge for the food? Well, I'm sure you see that fundamentally this is a little algebra question. And obviously that's one way you can solve this. But if you're not good at algebra, I'll show you another way. You've got answers here. Why can't you just test the answers? Let's go to answer B. Pick an answer that's easy to work with, $51 even. What if they charge $51 for the food? Well, if they charge $51 for the food, remember there's a 15% service charge just on the food. So take 15% times $51, there'd be a $7.65 service charge, 15% of 51. And then there's a 6% sales tax on the food and the service charge. So I'm going to add up the 51 and the $7.65. That adds up to $58.65 times 6%. The sales tax would be $3.52. If you add up 51 plus 765 service charge plus 352 sales tax, it adds up to $62.17. That can't be the answer. If I charge $51 for the food, I have to get $62.17 out of every person. But I've already quoted a price of $60. I'm stuck with $60. So that's not going to work. All right, now, my next question is this. You got to be logical if you're testing answers. If 51 is too much, what are you going to test next? 5640? Of course not, right? You have to go down, right? You have to be logical here. If 51 is too high, well, you want to try a little bit lower. Don't go to $56.40. Obviously not. Let's go down to $49.22. What if I charge $49.22 for the food? Well, if I do, there's a 15% service charge just on the food. So take 15% of $49.22. The service charge is $7.38. Now the sales tax is on the food and the service charge. So I'm going to add up $49.22 plus the service charge, $7.38. That's $56.60 times 6%. The sales tax is $3.40. And notice if you add up $49.22 for the food and $7.38 for the service charge and $3.40 for the sales tax, does add up to exactly $60, and the answer is C. If you've quoted a price of $60 a person, what you can charge for the food is $49.22. No, that's not the only way you can solve that, but as I say, if you're really good at algebra, just set up a little algebra problem, you've got that. But if you're bad at algebra, don't forget you have answers. Just test out the answers. Same thing with question number 6. Question number 6 says, hey, we're going to sell 500 units. We expect the traceable cost to be $990,000. if we're going to sell units for $500 each, and the traceable cost for this department, $990,000, and we want to make a 15% profit on sales, a 15% profit margin on sales, what's our target price? Well, again, you could set up an equation, or you can test answers. Let's go down to answer C. In other words, you sit in the exam and go, what if I did sell for $1,980 a unit? Well, if I sell for $1,980 a unit, I know I'm going to sell 500 units. That's given. So you multiply it out. My total sales are $990,000. That's just enough to cover my traceable cost of $990. There is no profit in answer C. That can't be the answer because I want a profit that's going to be 15% of sales. And there's no profit in answer C. So, all right, so C doesn't work. Let's try B. What if I sell for $2,277 per unit? Well, if I sell for $2,277 a unit, I know I'm going to sell 500 units. That's given. My total sales would be $1,138,500. Back out my traceable costs, which are given at $990,000. I make $148,500 profit. If you make $148,500 profit on $1,138,500 of sales, the profit margin's about 13% of sales. That's not enough. I want the sales price to be high enough so that my profit margin is 15% of sales. Here it's about 13%. All right, let's go a little higher. Let's try answer A. If I sell units for $2,329 each, I know I'm going to sell 500, so my total sales at that level would be $1,164,500. Back out my traceable cost, $990,000. I make a profit of $174,500 over the sales, $1,164,500. It's exactly 15%, and the answer is A. That was my objective. I want a profit margin equal to 15% of sales, and answer A fits the bill. And again, that's not the only way to solve a problem like that, but if you're not good at algebra, don't forget you've got answers, and you can just test those out. Keep studying. Get your homework done. I'll look to see you in the next class. Welcome back to our discussion on planning and measurement. And in this class, we're going to begin to discuss the different cost accounting systems that you have to be comfortable with on the exam. And let me say right off the bat that the goal of any cost accounting system is to simply tell management what it's costing to produce one single unit. That's the goal of any cost accounting system. And, of course, you know why management has to have that information. If management does not know what it's costing to produce one single unit, they don't know what to bill for their work. They don't know how to value their ending inventory for the balance sheet. So the real issues here are billing and control. Now, here's the basic point. If I'm a manufacturing company and I'm trying to determine what it costs to produce one single unit, I basically have two ways to go. There are basically two pure systems. It's either going to be, number one, some sort of job order approach, or number two, it'll be some sort of process approach. Those are the two pure systems. And the bottom line is this. What determines whether I should use a job order approach or a process approach is the type of units that I produce. The type of units that you produce, the type of production you're involved in, will dictate whether you should use a job order approach or a process approach. Let me explain. If a factory's involved with custom-made items, if every unit they're working on is custom-made, it's unique, has its own list of customer specifications, it's different from any other unit they're working on in the factory, well, that factory is basically forced to use some sort of job order approach. But if a factory is involved in any sort of mass production, any type of mass production, they're basically forced to use some sort of process approach. So that's what determines what sort of system you should use. It's really the kind of units that you produce. Now, we're going to begin with job order costing. And as I said a moment ago, in a job order system, every unit we're working on in the factory is unique. It's custom made. It's different from any other unit I'm working on in the factory. And if every unit is custom made, if every unit is unique, the only way to reasonably figure out what that unit costs is to keep track of all the material, labor, and overhead I put into that unit or that job. In other words, in a job order system, when I start a custom-made job, I also start a job order cost sheet or a job order cost card. And on that sheet or on that card, I simply keep track of all the material, all the labor, all the overhead I put into that unit or that job. Let me just show you a job order cost sheet for, say, job 1501. In job 1501, we put in 6 pounds of direct material at $8 a pound. So what did we do? We charged $48 of material to that job. Labor, we spent 9 hours of direct labor on that job at $11 per hour. That's our hourly rate. So what we did is charge $99 of labor to that job. Now notice overhead's a little different. Overhead, we're applying at $8 per direct labor hour. That's my predetermined rate for overhead. And I took that $8 times the 9 hours we spent on the unit, and we applied $72 of overhead to this job. If you add it up, this job, 1501, it cost in total $219. Now that job cost sheet, as simple as it looks, really illustrates the main thing that you have to remember about job order costing. Here's the main point. In job order costing, direct material and direct labor are charged to a job based on the actual amounts incurred on the job. But overhead gets applied to a job based on a predetermined rate. That's the essence of it right there. Direct material, direct labor get charged to a job based on actual, just based on the actual amounts incurred on the job. But overhead gets applied to a job based on a predetermined rate. Now, as we go through cost accounting, I'm not going to spend a lot of time on journal entries, but I do want to look at a couple of journal entries in this case, because there's something you have to see here in terms of entries. How do we handle it with entries that I apply overhead to jobs based on a predetermined rate, based on an estimate, but direct material and direct labor are charged to jobs based on actual? How is this all handled with entries? Well, let me show you the entries that we would make for that job 1501. You know that in job 1501, we charged $48 of material to that job. My entry for the material would be debit work in process, $48, credit material inventory, $48. Now, you know I charged $99 of labor to that job. What's the entry for the labor? I debit work in process, $99, credit wages payable, $99. So again, notice, direct material, direct labor simply get charged to work in process based on the actual amounts incurred on the job. Now, the overhead I apply based on that predetermined rate. I took that predetermined rate, $8 an hour, times the 9 hours we spent on the unit. I'm going to debit work in process, $72. Notice the overhead, that's based on the predetermined rate, and I credit an account called overhead applied, $72. What you have to remember is that a factory like this is going to have an overhead applied account. Overhead applied always has a credit balance, And it's where we keep track of what? It's where we keep track of all the overhead we've estimated for jobs. Remember, the predetermined rate, that's just an estimate. That has nothing to do with actual overhead costs. That's just an estimate. So overhead applied has a credit balance, and it's where we keep track of all the overhead we've estimated for jobs. Now, you know, in a factory like this, there has to be some way to keep track of actual overhead costs. So now let's say the same factory goes out and purchases. They actually go out and purchase $100 worth of supplies for the factory. Now, you know that supplies for the factory is an actual overhead costs. So what is the entry? Well, when there's an actual overhead cost, like supplies, we're going to debit, say, stores control 100. We'll credit cash 100. The reason I'm using stores control is because it's supplies. And presumably with supplies, they'd have some sort of inventory of supplies. So I'm going to debit stores inventory or stores control 100, credit cash 100. Now, one more thing. Now let's assume we actually send $25 worth of supplies from stores inventory to work in process. If I actually send $25 worth of supplies from stores inventory to work in process, I'm going to debit. Do I debit work in process? No. Remember, work in process is always debited for the estimate. For overhead, work in process is debited for the predetermined rate. No, if I actually send $25 worth of supplies from stores inventory to work in process, I'm going to debit overhead control 25 and credit stores inventory 25. What you have to remember is that a factory like this is going to have an overhead control account. Overhead control always has a debit balance, and it's where we keep track of what? All the actual overhead costs. You know what I'm trying to say. You don't go in that exam without understanding the difference between overhead control and overhead applied. Again, overhead control always has a debit balance, and it's where we keep track of all the actual overhead costs. Overhead applied always has a credit balance, and it's where we keep track of what? All the overhead we've estimated for jobs. And of course, when you get to the end of the period, there's going to be a difference between overhead control, your actual overhead costs, overhead applied, all the overhead you've estimated for jobs. That's your overhead variance. We'll talk about that later on. Now, with that in mind, let's do a couple of questions. Hopefully you've downloaded and printed out the questions for this class. And if you look at question number 1, they say in a traditional job order system, when you issue indirect material like supplies to production, what are you going to do? Well, think of the entry. When I actually issue something like supplies, indirect material to production, I debit overhead control and I credit stores control. I credit stores inventory. They ask me what increases is overhead control. You have to know those entries, and the answer is C. That's what's going to increase, overhead control. Question number 2. In a job order system, the use of, notice, direct material. The use of direct material would increase what? Remember, when I use direct material, I debit work in process, and I credit material inventory. Direct material and direct labor simply get charged to jobs based on the actual amounts spent on the job. So what would increase is work in process. Answer A. Work in process would just be debited for the actual direct material that we used in the job. Question number 3. In a process system that's applying overhead based on a predetermined rate. Remember, even though we haven't discussed process costing in any detail yet, in process costing, you can also apply overhead based on a predetermined rate. And it's the same basic idea. You can have an overhead control account. You can have an overhead applied account. In a process system, when you apply overhead, what's going to increase? Well, when you apply overhead, what's your entry? I don't care whether it's job order or process. You debit work in process for the estimate, and you credit overhead applied. So what's going to increase is work in process. Answer D. Question number 4. In a job order system that uses a predetermined rate for overhead, what's going to explain underapplied overhead? What explains underapplied overhead? Well, what's going to cause you to underapply overhead in terms of volume is if the actual volume is less than expected. See, if you thought you were going to produce 1,000 units and you only produce 2, you don't apply enough. You don't apply enough overhead based on that predetermined rate. So you underapply. So actual volume must be less than you expected. How about the amount of actual fixed cost? The amount of actual fixed cost must be greater than you thought, because you set up your predetermined rate. You thought your fixed costs were going to be $1 million. That's how you set up your predetermined rate. If your fixed costs turn out to be $100 million, with that predetermined rate of $10 an hour, whatever it is, you don't apply nearly enough. You underapply. So that the answer is C. That's what causes underapplied overhead. If you produce less than you expected, or if the actual fixed costs are much greater than you expected, you underapply. Now, question number 5, we have a job order question. And the basic question at the bottom is, what was the amount of direct material charged to job 5? And if you read it carefully, job 5 is the only job that's still in production. To solve this, let's set up a little T account. If we set up a T account for work in process, we know they started the month with a beginning balance in work in process of $4,000. And then they charged work in process with $24,000 of direct material. There would have been a debit to work in process for $24,000 of direct material. There would have been a debit to work in process for $16,000 of direct labor. And remember, overhead in this problem is applied at 80% of labor costs. So if labor was charged at $16,000, overhead must have been charged at 80% of $16,000 or $12,800. If you add up all the debits to work in process, they add up to $56,800. Those are the total debits to work in process. Now, there was a credit to work in process of $48,000. That went to finished goods. In other words, they must have, in terms of entries, they must have debited finished goods, $48,000, credit work in process, $48,000. The point is, what's still left as a balance in work in process is $8,800. Now, they want to know how much direct material is still in there. There's only job number 5 still in process. And we know job number 5 is worth $8,800. That's the balance in work in process. But how much of that is material? Well, we know of that $8,800, $2,000 is labor. That's given. Well, if $2,000 is labor, $1,600 must be overhead because overhead is applied at 80% of labor costs. So if there's $2,000 of labor, it must be $1,600 of overhead. So now you can plug the material. If there's $2,000 of labor, $1,600 of overhead, there must be $5,200 of material. The answer is B, because we know the whole job is worth $8,800. That's still the balance left in work in process. I want to say a couple of comments about activity-based costing, ABC costing. In activity-based costing, direct material, direct labor are handled exactly the same way we've been handling them in all these problems. What's different is overhead. In an activity-based costing system, they try to identify the activities that add value to the product. What activities really add value to the product? What they call value-adding activities. And in an activity-based costing system, in an ABC system, they try as much as possible to identify and eliminate non-value-adding activities like storage. You know, storage does not add value to the product. Customers are not willing to pay for storage. Storage is what they call a non-value-adding activity. So you try as much as you can to eliminate something like storage. And you try to identify what activities really add value to the product. What are these value-adding activities? And then, when you identify the activities that add value to the product, what really drives those costs? Is it labor hours? Is it machine hours? Is it labor cost? You try to find the cost drivers. That's what activity-based costing is about. So direct material and direct labor handled exactly the same way we've been handling them in all these problems. But overhead is handled differently, where we identify all the value-adding activities and we identify what really drives those costs. What are the cost drivers? So with that in mind, look at question number 6. They say, what effect does ABC costing have on the number of cost pools and allocation bases? Well, with activity-based costing, you're going to have a lot more cost pools. You know, remember, in a traditional job order system, you'd basically just add up all the costs in a department, all the indirect manufacturing costs in a department. You'd have one cost pool. But in an activity-based system, you're identifying cost by activity. You have all these activities that add value to the product. So cost pools are much greater. And allocation bases, much greater. The answer is D. You want to increase under both. Because once you identify all the different cost pools, then you want to identify what really drives those costs. So you're going to have labor hours, machine hours, labor costs. There's going to be all sorts of allocation bases also. So it's increase under both. Answer D. In question number 7, what is characteristic of an activity-based costing system? How about number 1? Are cost drivers used as a basis for cost allocation? Yes. In an activity-based costing system, you look for cost drivers. You identify all the activities that add value to the product, and then you have to identify what really drives those costs. Is it labor hours? Is it machine hours? What really drives those costs? So you do use cost drivers. How about number 2? So you want yes for statement number 1. How about number 2? Are costs accumulated by department? No, that's not activity. No, costs are accumulated by activity, not by department. If you're accumulating cost by department, that's just a traditional job order approach. Add up all the indirect costs in the department and use labor hours. Allocate based on labor hours. That's a traditional system. But in an activity-based costing system, you're going to accumulate cost by activity, not by department. So no to the second statement. How about number 3? Activities that do not add value to the product are identified and eliminated to the extent if possible. Yeah, that's true. Both first and third statements are true. The answer is C. That's the whole point of activity-based costing. Try to identify those non-value-adding activities, and as much as possible, eliminate any non-value-adding activities like storage. As I say, customers are not willing to pay for storage. Storage does not add value to the product. So as much as possible, you'd want to eliminate storage. Try to eliminate non-value-adding activities. And in an activity-based system, you would order things like supplies just in time to use them. You wouldn't have an inventory of supplies. You wouldn't have storage. You'd order things like supplies, materials, you'd use a just-in-time system. You'd order them just in time to use them. Keep studying. Don't fall behind. And I'll look to see you in the next class. Welcome back to our discussion on planning and measurement. And in this class, we are going to continue our discussion of cost accounting. And what we're going to get into next is mass production. And as we said in an earlier class, if a factory is involved in mass production, any sort of mass production, they're basically forced to use a process costing system. Now, I want you to know that immediately there's something about process costing that makes it a little bit more complicated. And that is, in process costing, you are required to make a cost flow assumption. You have to. And there are only 2. It's either going to be first in, first out, or weighted average. But you can't avoid that. In process costing, you have to make a cost flow assumption. Either going to be weighted average or first in, first out. Now we're going to begin with weighted average, a weighted average cost flow assumption with process costing. And if you downloaded the viewer's guide for this class, you'll notice that in your packet for this class, there is a problem called Joy Manufacturing Company. Together, let's do the problem on Joy Manufacturing Company. It's a process costing problem, and let's assume it is a weighted average cost flow assumption. The way I'd want you to remember process costing is that it comes down to 3 critical steps. That's really what process costing comes down to. It always comes down to 3 critical steps. Step number 1 is to account for all units. Let's account for all units. I like my students to think of accounting for all units as fundamentally a 2-column reconciliation. We'll start with a column on the left. Notice that in the beginning work in process, January 1st, there were 25,000 units. And let me ask you something. Does it matter whether those units are 50% complete, 40% complete, 80% complete, 100% complete? Not in this step. Remember, when you account for all units, you just deal in whole units. Don't worry about how complete they are at this point. You're just dealing in whole units. In other words, in the beginning work in process, there were 25,000 raw units. Just think of them as raw units. And then, during the year, they started another 80,000 units into production. So you add that up. That tells you there are 105,000 units to account for. Now, once you work that out, once you know that there's 105,000 units to account for, now you basically sit back and ask yourself a question. Logically, what can happen to any unit that you're working on? Well, if I gave you time to think of it, I think you'd agree with me. There's 3 possibilities. There are 3 physical things that can happen to any unit we're working on. We can finish it and transfer it out. We can still be working on it because we're not done with it yet, or we can ruin it. Those are the 3 possibilities. You can finish it, you can still be working on it, or you can spoil it. And if that makes sense to you, what that does is set up your right-hand column. Let's set up the right-hand column. I'm going to set up finished, ending work in process, spoiled. Now, of that 105,000 units, how many were finished? 65,000. Notice 65,000 units were finished and transferred. How many are still being worked on in the ending work in process? 35,000. We haven't had time to finish those. Notice that only adds up to 100,000 units. We must have spoiled. We must have lost 5,000 units. That gets you back to the 105,000 units that you had to account for. And I'll say that very often in the exam, what's missing is spoilage. And if you know that little two-column reconciliation, you can find the spoilage. But let's agree on this. In an exam like this, any piece of information can be missing. That's the problem. The exam plays games with you. Maybe the number of units that you finished is missing, or maybe the number of units that you started in the period is missing. But if you know this two-column reconciliation, you should be able to find it. That's why you have to know step one. Anytime you're in the exam and you're doing a problem, say, hey, I don't have something. There's something missing. Go back and do step one. You'll find it. And as I say, normally it's the spoilage. Here there are 5,000 spoiled units. Now let's go to step two. In step two, you must calculate your EFU, your equivalent finished units, your EFU. Now before we do the calculation, I just want to take a moment and make sure that you understand the concept of whole unit equivalence. I'm sure you do. But just to make sure, the basic idea of this step comes down to this. Let's say I tell you that there's 100,000 units on hand, and I tell you each one is 70% complete. Well, if there's 100,000 units on hand, and each one is 70% complete, that's equivalent to having 70,000 units on hand that are finished. See, when you calculate your EFU, you're taking their production, you're taking whatever they accomplished, and you're converting it into finished whole units. So if I tell you that there's 1 million units on hand, and each one is 55% complete, well, that's equivalent to having 550,000 units on hand that are done. That's the thinking in this step. Now, before we do the calculation, there's another little wrinkle that you have to think about. Normally, in a process problem, normally, you have to do a separate EFU calculation for raw material and a separate EFU calculation for labor and overhead or conversion costs. Now, why is that? Because don't forget, different elements of production can be at different stages of completion. In other words, can't I have units that are, say, 90% complete in terms of raw material, but only 20% complete in terms of labor and overhead? See, that's the basic problem, that different elements of production can be at different stages of completion. You can have units that are 94% complete in terms of material, but only 85% complete in terms of labor and overhead. So you'd have no choice but to do a separate EFU calculation for raw material and a separate EFU calculation for conversion costs. And that's normally what you see in the exam. So be ready to do that as well. Now, I'm assuming in this problem that we are using a weighted average cost flow. If we're using a weighted average cost flow, let's do our EFU, our equivalent finished units for material. Here's the format. Under weighted average, to calculate your equivalent finished units, you have to take the number of units they finished. Just pick up what they finished. Notice they finished and transferred here 65,000 units. Now you add to that what they accomplished, what they did to the ending work in process. Notice in this problem, there were 35,000 units in the ending work in process, December 31. If you look at the degree of completion table, those 35,000 units are 50% complete in terms of raw material. That's 17,500 whole unit equivalents. If you add it up, the EFU for raw material comes out to 82,500 whole units. That's how you do equivalent finished units under weighted average. It's what you finished plus what you accomplished, what you did to the ending work in process. We finished and transferred 65,000 units. Then we add what we did to the ending work in process, 35,000 units, got them 50% complete in terms of material. That's 17,500 whole unit equivalents. EFU for material, 82,500 units. Let's do the EFU for conversion costs, for labor and overhead. Well, I follow the same format. I'm going to take the number of units they finished, 65,000, and I'm going to add to that what they accomplished in the ending work in process. There are 35,000 units in the ending work in process. Table says we got them 30% complete in terms of conversion cost before we ran out of time. What is that? That's 10,500 whole unit equivalents. So if you add it up, the EFU for labor and overhead for conversion costs for the period, 75,500 whole units. That's the format you follow. That's how you do EFU, equivalent finished units under weighted average. It's the number of units you finished plus what you accomplished in the ending work in process. Now, before we go to step 3, I want to step back for a moment and have you notice that we did have some spoilage here. In this problem, there were 5,000 lost units. We found those 5,000 lost units back in step 1 when we accounted for all units. Now, when you see spoilage in a problem, I want you to remember that there are basically 2 types of spoilage. There is normal spoilage and there is abnormal spoilage. Let's talk about the difference. Normal spoilage is spoilage that cannot be prevented by management. In other words, a certain amount of spoilage is inevitable. A certain amount of spoilage is the natural result of producing anything in this world, and there's nothing management can do to prevent a certain level of spoilage. That's the definition of normal spoilage. It's spoilage that cannot be prevented by management. Now, on the other hand, abnormal spoilage is spoilage that could have been prevented by management. Spoilage that should and could have been prevented by management. Now, of course, the important thing is, how do you account for each type? Normal spoilage, generally speaking, is ignored. Normal spoilage, generally speaking, is ignored. In other words, generally, you do not put normal spoilage in an EFU calculation. You just ignore it. And that has the effect of spreading the cost of the normal spoilage among the remaining good units. That's the effect that has. Again, normal spoilage, generally, you just ignore it. You don't put normal spoilage in an EFU calculation. And that'll have the effect of spreading the cost of the normal spoilage among the remaining good units. And that makes a lot of sense when you keep in mind one basic point, and that is normal spoilage is a product cost. That's the bottom line. Normal spoilage is a product cost. Why? Because it ends up being part of the unit cost of all the surviving good units. Now, abnormal spoilage is different. Abnormal spoilage is handled completely differently, and there's 2 big things to remember about abnormal spoilage. First of all, abnormal spoilage is added to your equivalent finished units calculation. In other words, if I had abnormal spoilage in this problem, now my format for EFU would have 3 lines. I would take what they finished, add what they did to the ending work in process, and I'd add the abnormal spoilage. You have to add another line to that format. It's what you finished, plus what you did to the ending work in process, plus the abnormal spoilage. So abnormal spoilage belongs in your EFU calculation, and what you ultimately do with abnormal spoilage is add up the material, the labor, and the overhead costs related to the abnormal spoilage and show it as a loss on the income statement. It's a loss for the period. That's why in the exam, they refer to abnormal spoilage as a period cost. So that's the fundamental difference. Normal spoilage is a product cost. Why? Because it ends up being part of the unit cost of all the surviving good units. Abnormal spoilage is a period cost. Why? Because it gets reported as a loss for the period. That's the fundamental difference with spoilage. Now, one other point. If the exam is silent, as they are here, if they say nothing, you assume spoilage is normal. If they're silent, they don't specify, you just assume spoilage is normal. So if you go back to Joy Manufacturing, we had 5,000 lost units. They said nothing about it. I'm assuming that's normal spoilage, and I basically ignore it. Notice I didn't put that normal spoilage in my EFU calculation. All right, now let's go to step 3. The third step is unit costs. You have to be able to do a unit cost schedule. So let's set it up. Under weighted average, you're going to take costs from the beginning work in process. Take the costs from the beginning work in process plus current costs. That'll give you a total. Then you divide by equivalent finished units, and that'll give you unit costs. So let's start with direct material. There was $95,000 of direct material in the beginning work in process. The current material costs $400,000. If you add that up, that adds up to $495,000 of material. I'm going to divide that by 82,500 equivalent whole units of material produced this period. And the unit cost of material comes out to exactly $6. Let's do conversion costs, or labor and overhead. There was $78,750 of labor and overhead in the beginning work in process. The current conversion costs $110,000. If you add that up, That's $188,750 of conversion costs. I'm going to divide that by 75,500 equivalent finished units of labor and overhead that I completed this period. And the unit cost for conversion cost comes out to $2.50. My total unit cost is $8.50 per unit. $6 of material, $2.50 of conversion costs. I want to back up a step for a minute. Remember we said that we're going to use process costing when we're involved in mass production. And I think that in step 3, you can graphically see what mass production is all about. What you basically do in mass production is you keep track of all the costs in a department, in a process. Then you divide by the number of equivalent whole units produced, and that tells you what each one costs because they're all the same. Each widget costs $8.50. Each gallon of solvent costs $8.50. 1 gallon of solvent is just like another gallon of solvent. 1 widget, just like another widget. So that's what step 3 is really the whole focus right there. Take all the costs in the department, divide by the whole units produced. That tells you what each one costs because they're all basically the same. This is mass production. All right, now that we've done the 3 steps, let's talk about a couple of things the exam could ask you for. The exam might ask you, what were the costs transferred on to the next department? What were the costs transferred to finished goods? Well, now I can answer that. I take the 65,000 units that I transferred times $8.50. Every unit I transferred is at an average unit cost of $8.50. If you multiply that out, it comes out to $552,500. This is my transferred out costs. The exam could ask you that. What's the value of ending work in process? What are the costs I still have on hand? Well, in the ending work in process, December 31, I have 35,000 units. Aren't they 50% complete in terms of material? So we know that that's 17,500 whole unit equivalents times $6, the unit cost of material. I've got $105,000 of raw material in the ending work in process. How about labor and overhead or conversion costs? Well, I've got 35,000 units in the ending work in process. They are 30% complete in terms of conversion costs, so that's 10,500 whole unit equivalents times $2.50, the unit cost for conversion cost. I've got $26,250 of conversion cost in the ending work in process. The value of ending work in process would be $131,250. That's $105,000 of material, $26,250 of labor and overhead or conversion cost. Value of ending work in process is $131,250. Now, I could have plugged that, couldn't I? You see a little shortcut here. If you go back to the problem, notice that the total manufacturing costs I have to account for $683,750. That's the total production costs. So if I sent $552,500 out the door, I have to have the rest, $131,250 on hand, because that gets me back to the total manufacturing costs of $683,750. Or you can go the other way. I know the total cost to be accounted for is $683,750. So if $131,250 is on hand, I must have transferred $552,500 out the door. So sometimes that'll speed you up in the exam, knowing that you can reconcile back to the total manufacturing costs. Now, there's another thing that the exam likes to do with process costing. You know that in process costing, we normally do a separate calculation for raw material, equivalent finished units, and a separate calculation for conversion cost, equivalent finished units. And we know why, because, as we said before, different elements of production can be at different stages of completion. Well, what I want to focus in on for a couple of minutes is the EFU calculation that you make for raw material. Because what the exam can do is make different assumptions about when you add the material. For example, they could say in a problem like this, all the material's added at the beginning. And you have to know what that does to your equivalent finished units calculation. Or they could say, all the material's added at the end. And you have to know what that does to your equivalent finished units calculation. So let's do this problem again. Remember, in this problem, when I did the EFU for raw material, how did I do it? I said, well, under weighted average, I take the number of units that I finished, 65,000, and I add what I accomplished in the ending work in process. There were 35,000 units in the ending work in process. They gave me a table. They said they were 50% complete in terms of raw material. I got them 50% complete in terms of raw material before I ran out of time, so that's 17,500 whole unit equivalents. My EFU for material came out to 82,500 whole units. That's what we did in this problem. Now let me change it. What if we did the same problem, but now they said all the materials added at the beginning. In other words, now they wouldn't give you these percentages. They wouldn't give you the degree of completion table. They would just have a line in the problem. All the materials added at the beginning. What would you do? Well, if all the materials added at the beginning, I'm going to start the same way. Under weighted average, I take the number of units that I finished, 65,000, and I add what I accomplished in the ending work in process. Now I've got 35,000 units in the ending work in process. And if I add all the material at the beginning, I assume those 35,000 units are 100% complete in terms of material, because the first thing I did was add all the material. Now the EFU would be 100,000 units. It's what I finished, 65,000 units, plus what I did to the ending work in process, and I'm assuming those 35,000 units would be 100% complete in terms of material. That's 35,000 whole units. Notice now my EFU is 100,000 whole units. It's a little different. You know, if you want to picture this, when they say all the materials added at the beginning, it's the way a sculptor works. You know, a sculptor says, I'm going to make a statue. First thing I do is put a hunk of marble down. Well, that's done, right? There's 100% of the material. Now comes the labor and overhead. Now I sculpt the marble. That's exactly what they're saying. Now, same problem. What if they said all the materials added at the end of the process? Well, if they say all the materials added at the end, it means the last thing you do, the very last step in the process, the very last thing you do to a unit is add the material. So now if they say all the materials added at the end, I say, well, under weighted average, the way I figure out equivalent finished units, I take the number of units that I finished, again, 65,000, start the same way. I'm going to add what I did to the ending work in process. There are 35,000 units in the ending work in process. Now I assume they are 0% complete in terms of material. There's no material till they're finished. There's no material till the very end. So those 35,000 units in the ending work in process, I'm assuming they're 0% complete in terms of material, so I'd add 0, and the answer would be 65,000. So what are they saying here? They're saying, gee, the last thing I do is add the material, right? All the labor and overhead comes first. Then I add the material. Is that realistic? Well, if you want to picture it, imagine a factory where all the labor and overhead goes into setting up a mold, say. That's sort of what's going on here. Just imagine a factory where all the labor and overhead goes into setting up a mold and calibrating it. Then the last step is, add melted plastic. That's sort of what they're saying. But that's the very last thing you do. And now those 35,000 units in the ending work in process, they would have 0 material on them. There's 0% complete in terms of material, so I add 0, and the answer, like I say, would be 65,000. I just wanted to show you that because the exam does not always give you degree of completion tables. A lot of times in these problems, a lot of times in multiple choice, they just kind of throw in all the materials added at the beginning or all the materials added at the end, and you have to know how to deal with that in terms of your equivalent finished units. We will continue our discussion of process costing in our next class. I look to see you then. Welcome back to our discussion on process costing. And you know that I wanted you to do a couple of questions before watching this particular class. Let's go to question number 1. I'm sure you noticed in question number 1, the cost flow assumption is weighted average. Remember, in process costing, you have to make a cost flow assumption. There's only 2, either first in, first out, or weighted average, and the exam is going to have to mention what it is. Here it's weighted average, and what they're asking is, under weighted average, what is the unit cost for direct material? Well, let's go through our steps. Step 1, we account for all units. And remember, we think of that as a 2-column reconciliation. Starting with the column on the left, we know there were 15,000 units in the beginning work in process. And remember, it doesn't matter how complete they are. When you're accounting for all units, you just deal in whole units, raw units. There were 15,000 raw units in the beginning work in process. Then during the year, they started 40,000 units into production. So you just add that up. That gives you 55,000 units to account for. And as I said earlier, once you know that, you know logically there are only 3 things that can happen to any unit you're working on. You can finish it, you can still be working on it, or you can ruin it. And that just sets up the right-hand column. How many did we finish? 42,500 units. How many are we still working on in the ending work in process that we haven't had time to finish? 12,500. And notice, that does add up to the 55,000 units we have to account for. In other words, there are no spoiled units. And that's always why I do the first step. See if there's any spoilage. Make sure I have all the information that I need. As I said In a prior class, if anything is missing, you do step 1, you'll find it. Here there is no spoilage. Let's go to step 2. In step 2, we have to calculate our EFU, our equivalent finished units, and we're only doing the EFU for material. Remember, normally in process costing, you do a separate EFU calculation for raw material and a separate EFU calculation for conversion costs. Here we're just going to do material. Under weighted average, to calculate our equivalent finished units, I'm going to take the number of units they finished. Just pick up what they finished and transferred, 42,500 whole units. Then I add to that what they did, what they accomplished in the ending work in process. We know there are 12,500 units in the ending work in process. Question is, how complete are those units in terms of material? That's right, 100%. How do you know that? Because they said all the materials added at the beginning. They threw that in there, didn't they? If all the materials added at the beginning, the first thing I did was add all the material, like a sculptor. Put a lump of marble down. Then the labor and overhead comes to sculpt the marble. It's already done. So there's 12,500 whole units of material in the ending work in process. If you add it up, the equivalent finished units of material for the period, 55,000. This period we produced 55,000 whole units of material. Now let's go to step 3, unit cost. Remember, under weighted average, I'm going to take the material cost in the beginning work in process, 5,500, plus the current material cost, which is 18,000. That adds up to $23,500 of total material. I divide by the number of equivalent whole units of material produced, 55,000, and that gives me the unit cost for material, 43 cents, and the answer is D. Let's go to question number 2. In question number 2, again, the cost flow assumption is weighted average. Exam's got to say. And they say, how much conversion cost, labor and overhead, was transferred to the second department? Well, let's go through our steps. First thing we're going to do is account for all units. Step 1. We know that there were 2,000 units in the beginning work in process. Then during the year, they started an additional 8,000 units into production, so that gives me 10,000 units to account for. Just 10,000 raw units have to be accounted for. I can finish units, I can still be working on them, or I can spoil them. That sets up your right-hand column. How many did you finish? 7,000. How many units are you still working on? 2,500, and you spoiled 500, and that gets us back to the 10,000 units we had to account for. We have accounted for all units. Now, since they're asking for the conversion costs that were transferred to the next department, let's just do our EFU, our equivalent finished units, for conversion costs. We know in weighted average, I'm going to take the number of units they finished and transferred, 7,000. I'm going to add to that what they did, what they accomplished in the ending work in process. There are 2,500 units in the ending work in process. Table says they got them 80% complete in terms of conversion costs before they ran out of time. That's 2,000 whole unit equivalents. So we put that in. Now, how about the spoilage? Now, I want to go back to something we said in a prior class. Notice this is normal spoilage. They said it was normal. And I said in a prior class that normal spoilage, generally speaking, is ignored. But I did make the point, generally speaking, it's ignored. Generally speaking, you don't put normal spoilage in an EFU calculation, and that'll have the effect of spreading the cost of the normal spoilage among the surviving good units. That's generally what you do. This problem, there's a twist. If you read it carefully, they said about halfway down, the costs of spoiled units will be assigned to the units completed and transferred to the second department in the period that spoilage is identified. That sentence changes everything. When they said the cost of spoiled units, the cost of spoilage will be assigned to the units completed and transferred to the second department in the period the spoilage is identified. That's going to change how we handle this normal spoilage. Even though it's normal spoilage, I'm going to include it in the equivalent finished units. I'm going to add another 500 units. And now the equivalent finished units for conversion cost would be 9,500. 9,500, not 9,000, 9,500. By the way, if I were doing the EFU for material, I'd also put the spoilage in because of that line. In other words, when spoilage is added to equivalent finished units, it's not just for labor and overhead, it's also for material as well, but we're not doing material. But my point is, the equivalent finished units for labor and overhead for conversion cost now would be 9,500 units. Now let's go to step 3, unit cost. Remember, under weighted average, I'm going to take the labor and overhead, the conversion cost in the beginning work in process, 10,000, plus the current conversion cost, 75,500. That gives me a total of 85,500 of total conversion cost. I'm going to divide by the number of equivalent whole units produced, that 9,500, and the unit cost for labor and overhead for conversion cost comes out to $9. Now at the bottom, when they say, what was the conversion cost transferred to the second department? Well, didn't I finish and transfer 7,000 units? There's $9 of conversion cost on each one of those units. That's 63,000 of conversion cost I transferred to the next department. But I also transferred the spoilage. They said the cost of spoilage is assigned to the units and transferred to the second department in the period in which the spoilage is identified. I'm also sending the second department 500 spoiled units. There's $9 of labor and overhead on each one of those units. That's another 4,500. See, what's probably happening here is the second department is taking that spoiled units, taking that 500 units, and probably correcting them, saving them. I mean, if it was true spoilage, scrap, it would be thrown away. But the fact that the 500 units are being transferred to the second department must mean that they can work on the units and save them and still turn them into sellable units. That's why even though it's normal spoilage, it's handled differently because they are being transferred to the second department to be worked on. So that's another $4,500 of labor and overhead transferred to the second department with the spoiled units. So what's the total labor and overhead? What's the total conversion cost I transferred to the second department? 63,000 with the units transferred and 4,500 with the spoilage. 67,500, which is answer C. That's a hard problem because of that little wrinkle on the normal spoilage. Continue your studying, don't fall behind, and we will continue our discussion of process costing in the next class. See you then. Welcome back to our discussion on cost accounting, and if you've downloaded the problem for this class, I'm sure you've noticed it's Joy Manufacturing Company once again. It's a problem we did in an earlier class, only now we're going to solve Joy Manufacturing Company under first in, first out. Up till this point, all we've covered is process costing under weighted average. But what if we did Joy Manufacturing Company under a first in, first out cost flow? Well, remember, it comes back to the same 3 steps. Step number 1, let's account for all units. We know that there were 25,000 units in the beginning work in process. Doesn't matter how complete they are, not in this step. You just deal with raw units. Then they started another 80,000 raw units into production. So if you add that up, that gives you 105,000 units to account for. And again, we know there's only 3 things that can happen to any unit you're working on. You can finish it, you can still be working on it, or you can ruin it. So that sets up your right-hand column. How many did we finish? 65,000. How many are we still working on? 35,000. And we spoiled 5,000, and that gets us back to the 105,000 units that we knew we had to account for in the first place. I'm sure you've already noticed step 1, accounting for all units, is always done the same way. It doesn't matter what the cost flow assumption is, you're just accounting for raw units. So it's 5,000 lost units either way. And, by the way, the notes I gave you in an earlier class on spoilage would all still apply. There's normal spoilage, there's abnormal spoilage. Normal spoilage is a product cost. Abnormal spoilage is a period cost. All those notes are exactly the same. If the exam is silent, I assume it's normal spoilage. Generally, normal spoilage is just basically ignored. So we'll ignore it from this point on. But I just wanted to mention that the notes that we went over earlier on spoilage would still apply, whether it's FIFO or weighted average. Let's go to step 2. In step 2, we have to calculate our equivalent finished units. And you know that we're going to have to calculate a separate EFU for raw material and a separate EFU for conversion cost because different elements of production can be at different stages of completion. So let's do our equivalent finished units for raw material. To do the EFU for raw material, I'm going to take the number of units that I finished, 65,000. I'm going to add to that what I accomplished in the ending work in process. There are 35,000 units in the ending work in process. They say we got them 50% complete in terms of material before we ran out of time. That's another 17,500 whole unit equivalents. And I'm sure you've noticed, down to this point, it's exactly like weighted average. It's identical. But with FIFO, you add one more thing. You have to put another line in here. With FIFO, now you must subtract what you already accomplished in the beginning working process before the period started. You've got to back out what was already done to the beginning working process before the period started. In this problem, there were 25,000 units in the beginning working process, January 1. The table says they were already 10% complete in terms of material when I started the month, when I started the year. That's 2,500 whole unit equivalents. You back out that 2,500, the EFU for raw material is 80,000 whole units. Let's do conversion cost. I'm going to take the number of units that I finished, 65,000. I'm going to add to that what I accomplished in the ending working process. There are 35,000 units in the ending working process. Table says I got them 30% complete in terms of conversion cost before I ran out of time. That's another 10,500 whole unit equivalents. But remember, in FIFO, you have to do one more thing. You have to subtract what was already done to the opening working process before you started. There were 25,000 units in the opening working process January 1. Table says they were already 20% complete in terms of conversion cost before you started. So back out 5,000 whole unit equivalents, and it comes out to 70,500 whole unit equivalents of conversion cost under FIFO. Now let's go to step 3. In step 3, we have to calculate the unit cost, and it's a little different. In FIFO, when you do your unit cost, you take current costs only. It's not like weighted average. In weighted average, you would take costs from the beginning working process plus current cost, but not in FIFO. FIFO, you're going to take current costs only. So for raw material, I'm going to pick up the current raw material cost only, 400,000. I divide by the number of equivalent whole units of material produced this period, 80,000, and the unit cost for material comes out to $5. Same thing with conversion cost. I'm going to pick up the conversion cost for the current period only, 110,000. Divide by the EFU for conversion cost, 70,500 whole units, and the EFU for labor and overhead, conversion cost, comes out to $1.56. My total unit cost is $6.56. Those are the 3 steps under first in, first out. All right, now, what if they were to ask, what's the cost in the ending working process? How would I do it? Well, in the ending working process, I've got 35,000 units, don't I? December 31. Table says they're 50% complete in terms of material, so that's 17,500 whole unit equivalents times $5, the unit cost of material. There must be $87,500 of material in the ending working process. How about conversion costs? Well, there's 35,000 units in the ending working process, December 31. Table says they're 30% complete in terms of labor and overhead, so that's 10,500 whole unit equivalents times $1.56, the unit cost for conversion cost. There's $16,380 of conversion costs in the ending working process. If you add it up, ending working process comes out to $103,880. That's $87,500 of materials, $16,380 of labor and overhead. Total ending working process is $103,880. What if they wanted the cost transferred out? You know what to do. Don't I know the total manufacturing costs are $683,750? I knew when I started I had total manufacturing cost to account for of $683,750. If $103,880 is in the ending working process, I must have transferred the rest out. $579,870 must have been transferred out. Maybe you can plug that because you're always proving back to the total manufacturing cost for the period. Those are the steps under first in, first out. Why don't we try a multiple choice? If you go to multiple choice number 1 for this class, at the bottom it says, what is the total value of material cost in the ending working process under first in, first out? Well, let's go through our steps. First, we want to account for all units. We think of that as a 2-column reconciliation. Column on the left. We know there were 100 units in the beginning working process, January 1. Then they started another 500 units into production during the quarter. So you add it up, that gives us 600 units to account for, right? That's all the left-hand column is about, just dealing with raw units. What were the raw units to account for? 600. And now we know there's just three things that can happen to units. You can finish them, you can still be working on them, or you can spoil them. How many did we finish? 400. How many are we still working on? 200. That does reconcile to 600 whole units. The spoilage must have been 0. We assume that they spoiled 0 units. Let's do step 2. We calculate equivalent finished units. Remember, under FIFO, that is the cost flow assumption here. Under FIFO, we're going to take the number of units they finished, just pick up what they finished and transferred, 400 units. We're going to add to that what they accomplished, what they did to the ending work in process. There are 200 units in the ending work in process. They say they got them 75% complete in terms of material before we ran out of time. That's another 150 equivalents of material. And as I pointed out earlier, down to there, it's exactly like weighted average, isn't it? But in FIFO, you have to do one more thing. Now you have to subtract what was already done to the beginning work in process before you started. Weren't there 100 units in the beginning work in process, January 1? They said they were already 50% complete. Already 50% complete in terms of material before you started. You're going to back out 50 whole unit equivalents. And the EFU for material under FIFO comes out to exactly 500 units. Now let's go to step 3, unit cost. Under FIFO, you want to pick up the current cost only. What's the current material cost? $720,000. Notice I don't pick up the costs in the beginning work in process, just the current costs, $720,000 of material. I divide by the number of equivalent whole units of material produced, 500, and the unit cost of material, $1,440. That's my unit cost material, $1,440 for each unit of material produced. Now I can answer the question. When they ask at the bottom, what's the total material cost in the ending work in process? Well, don't I have 200 units in the ending work in process? Table says they're 75% complete in terms of material. That's 150 whole unit equivalents of material times 1,440. The unit cost of material is exactly $216,000 of material, $216,000 worth of material in that ending work in process. And the answer is D. Make sure with process costing, you know both first in, first out, and weighted average. Keep up with your studying. Don't fall behind with your homework. I'll look to see you in the next class. Welcome back to our discussion on cost accounting. And before we leave the topic of process costing, I want to cover one more facet of process costing, and that is the topic of joint products and byproducts. Let me just start with a couple of quick definitions. Joint products are 2 or more, could be 3, could be 4, 2 or more products that produce significant total revenue. 2 or more products that produce significant total revenue and are processed together in the same department. In other words, 2 or more main products that are processed jointly, they're processed together in the same department. A byproduct is a product of insignificant total value, insignificant total revenue, that is produced incidental to the production of a main product. So a byproduct just sort of tumbles out. It's a product that produces insignificant total revenue, and it's produced incidental to the production of a main product, which is our real objective. And if you're with me on the definitions, let me just get right to what the exam likes to ask. What the exam likes to ask is the relative sales value method of allocating the joint costs. If joint products are 2 or more main products processed together in the same department, how do we allocate those joint processing costs? And as I say, what the exam likes to ask is the relative sales value method of allocating joint costs. Now, you have to be careful. There's different names for this approach. It's called the relative sales value method. It's called the relative sales value at split-off method. It's called the net realizable value method. It's really different ways of saying the same thing, but it's what the exam always hits on. The relative sales value method, the relative sales value at split-off method, the net realizable value method. Let's go right to a problem. If you look at question number 1 that you've downloaded for this class, you'll notice that A and B are joint products. They're two main products. They're processed together in the same department. And they say at the bottom what joint cost would be allocated to A if we use the net realizable value method. Well, first of all, let's work out the sales value for each product. The sales value of A is $80,000. That's what we can sell A for, $80,000. Now, what about the additional processing costs? You've got to remember, the additional processing costs are a dollar-for-dollar reduction of the sales value. So the sales value of product A, the net realizable value of product A, is $72,000. Same thing with B. We can sell B for $40,000, but there's some additional processing costs. And again, those additional processing costs are a dollar-for-dollar reduction of the sales value. So we're going to back out those additional processing costs of $22,000. The net realizable value of product B is $18,000. The total sales value for both products combined, $90,000. Now, before we do the final solution here, I want to point out a couple of things. What would you do in this problem if they said they actually intend to sell so many pounds of A? They actually intend to sell so many pounds of B. You couldn't care less. I want you to remember that in the relative sales value method, what we need is the theoretical sales value of all the good pounds produced. If they start telling me how many pounds they actually sold, I couldn't care less. It's one of the big tricks in the exam. They start telling you how many pounds were actually sold, that doesn't mean anything. What you're after in this method is the theoretical sales value of all the good pounds produced. And the other important point is, don't forget those additional processing costs. As I said, those additional processing costs are a dollar-for-dollar reduction of the sales value. So as I say, the relative sales value of product A, $72,000. The relative sales value of product B, $18,000. Total sales value for both products, $90,000. Now I strike a ratio. Since A makes up $72,000 of the total $90,000 sales value, since A makes up 80% of the total theoretical sales value, 80% of the net realizable value in this method, A would be allocated 80% of the $60,000 of joint costs, so $48,000, and the answer is C. Notice you are literally using relative sales values to allocate those joint costs. And again, sometimes the exam calls it the relative sales value method, the net realizable value method, as they did here, the relative sales value at split-off method, really different ways of saying exactly the same thing. Let's go to question number 2. They say in question number 2 that actual sales values at split-off are not known for products Y and Z. So we don't know the sales value at split-off for Y and Z. The relative sales value at split-off point is being used to allocate joint costs. There's been an increase in costs beyond split-off for product Z while Y's costs remain constant. That's all you know. All you know is that there's been an increase in cost beyond split-off for product Z. Y's has remained constant. If the final sales values remain constant, the final sales prices remain constant, what's going to happen to joint costs? Well, remember that the costs beyond split-off are a dollar-for-dollar reduction of the sales value. They reduce the net realizable value of the product. So if there's been an increase in cost beyond split-off for product Z, then what I'm going to net out of Z is going down, down, down. If there's been an increase in cost beyond split-off for product Z, I'm netting less and less out of Z. Net realizable value for Z is going down. Y is remaining constant. So if I use relative sales value at split-off to allocate joint costs, the percent of joint costs will increase for Y and go down for Z because the net realizable value of Z is going down. So joint cost for Y would increase, joint cost for Z would go down. Now, we haven't said much about byproducts to this point. Remember, a byproduct is a product that produces insignificant total revenue, immaterial total revenue, and is produced incidental to the production of a main product. Now, under generally accepted accounting principles, because a byproduct is insignificant, it's immaterial by definition, you have a lot of latitude on how to handle byproducts. Some companies treat what they net out of a byproduct as miscellaneous income. That's perfectly okay. So you can treat what you net out of a byproduct, make a few dollars on it. You can treat that as miscellaneous income, other income on the income statement. Some companies treat what they get out of the byproduct, they make a little profit on the byproduct, and they treat that as a reduction of cost of goods sold. That's fine. Now, the most common approach you see in the exam is this. In the exam, what they like the best is taking what you're going to net out of that byproduct. Let's go to question number 3. In question number 3, we have a process that produces two joint products, J and K, and a byproduct, B. And notice B can be sold for $9,000, but there's also additional costs beyond split off of $4,000. So let's work that out quickly. What's the net realizable value for the byproduct? I expect to sell the byproduct for $9,000. There are additional processing costs of $5,000. So what I expect to net out of the byproduct is $4,000. The net realizable value of that byproduct is $4,000. Now, what do they say about the byproduct? They said that the net realizable value of the byproduct is subtracted from joint costs. This is the method that you see most often in the exam, where they take what they're going to net out of the byproduct, what they call the net realizable value of the byproduct, that $4,000, and they use it to lower joint costs. And you got to be careful. There's a name for that. Sometimes the exam calls this the net realizable value method of accounting for byproducts. I think you should be aware of that. If the exam mentions the net realizable value method of accounting for byproducts, this is what they're doing. They're taking the net realizable value of the byproduct, again, that's the $9,000 you can sell it for, minus the additional cost of $5,000, that's $4,000. They're taking what they're going to net out of the byproduct and treating it as a reduction of joint costs. And one more time, they have a name for that. That's called the net realizable value method of accounting for byproducts. That's what they're doing here. So because I'm using the net realizable value method of accounting for the byproduct, I'm going to take their joint costs, which are $54,000, but I'm going to lower that $54,000 by the $4,000, net realizable value of the byproduct. So now the joint costs are $50,000. And once you've made that adjustment, now it's just a straight relative sales value at split off problem. I'm going to take the sales value of my main products. The sales value of K is $40,000. There are no additional costs beyond split off, so the net realizable value of K is that $40,000. I'm going to take the sales value of J, $60,000. There are no additional costs beyond split off, so the net realizable value of J is $60,000. My total theoretical sales value is $100,000. And let me say to you again, they start telling you how many pounds they actually sold. You couldn't care less. You're after the theoretical sales value of the good pounds produced. That's what you care about here in this method. So I'm going to take the total theoretical sales value for my main products, $100,000, and I say, well, since K makes up $40,000 over $100,000, since K makes up 40% of the total theoretical sales value, in this method, K would get 40% of joint costs. And what are joint costs now? Well, they were $54,000. But because I use the net realizable value method, because I'm taking the net realizable value of the byproduct, $4,000, subtracting from joint costs, now there's only $50,000 of joint costs. K gets 40% of that, or $20,000. Answer C. That's what they wanted. They wanted to know the joint cost that would be allocated to product K. And the answer is $20,000. The answer is C. So, like I say, with byproducts, you can treat that net realizable value as other income. You can treat it as reduction of cost of goods sold, but that's the approach the exam likes usually, what they call the net realizable value method of accounting for byproducts, where you take the net realizable value of the byproduct and use that net realizable value of the byproduct to lower joint costs. Watch out. You got to know what that net realizable value method of accounting for byproducts is all about. Don't fall behind. Keep up with your work. I'll see you in the next class. Welcome back to our discussion on cost accounting. And before we leave the topic of cost accounting, there's one more subject we have to discuss, and that is the subject of standard cost accounting. Now, when I say standard costing, I am saying that a corporation has a job order or a process system, either one, but they've set up standards, they've set up goals that management should reasonably be able to meet. I want to go back for a minute to an earlier class. Remember in an earlier class we talked about job order costing, and we said that the essence of job order costing is to remember that in job order costing, direct material and direct labor are charged to a job based on actual, always based on the actual amounts incurred on the job. But overhead gets applied to a job based on a predetermined rate. I know you remember that. Well, just remember with standard costing, all elements of production will be applied to a job based on a predetermined rate. In other words, in standard costing, now I'm going to have a predetermined rate for raw material, or what? A standard amount of material that I apply to every unit I produce. I'm going to have a predetermined rate for labor, or what? A standard amount of labor that I apply to every unit I produce. And as always, there will be a predetermined rate for overhead, or a standard amount of overhead I apply to every unit I produce. That's standard costing. Another thing that might help you is to remember in this topic, when you see standard, think budget. Standard means budget. So when I say I have a standard for material, it means I have a budget for material for every unit. I have a standard or a budget for labor. I have a standard or a budget for overhead for every unit I produce. And I'm sure you know that the whole reason we come up with these budgets, these standards, is ultimately to compare standard or budget with what actually happens, so I can judge management. I set up these standards or these budgets to give management a yardstick to measure performance by. That's why we go through this whole process. And of course, the way I judge management performance is with the use of variances. And that's what I want to get into next. What we're going to get into next are all the different variances that you have to know for the exam. There's quite a few. And if you downloaded the problem for this class, I'm sure you noticed that we have a big problem to work on, Armando Corporation. If you take a look at it, they start off by giving you the standards. Very typical setup for a problem like this. Here are their standards. On every unit, they're supposed to put 20 standard yards of material at $1.35 a yard. That's the standard price per yard. So what are they doing? They're applying $27 of material to every unit they produce. Labor, they're supposed to put 4 standard hours of labor into every unit they produce. $9 per hour is the standard rate. So what are they doing? They're applying $36 of labor to every unit they produce. They say overhead is applied at 5/6 of direct labor. If you take 5/6 of 36, you get 30. That's where the 30 comes from. So every unit they produce, they're applying $30 of overhead. That's their budget. That's their standard for overhead. And they say that in that 30, the ratio of variable cost to fixed is 2 to 1. Well, if the ratio of variable cost to fixed is 2 to 1, then that $30 must break down to $20 variable, $10 fixed. You might want to just make a little note of that. We'll talk about that later, but that's how the $30 must break down. $20 variable, $10 fixed. We'll talk about that later. But the standard, the budget for every unit is $93. And then they say the standards are based on normal monthly activity involving 2,400 direct labor hours or 600 units of product. Well, that makes sense too, because if normal activity is 2,400 hours and they're supposed to put 4 standard hours in every unit they produce, doesn't it make perfect sense that normal activity in units is 600? The fixed overhead budget for the month is $6,000. The variable factory overhead rate per direct labor hour is $5. So there's all your standards. There's all your budget information. Now here's what actually happened. And that's the basic setup of all these problems. We give you the standards. We give you the budget. Here's what actually happened. They went out and they actually purchased 18,000 yards of material at $1.38 a yard. They actually spent $24,840 on material. And notice they actually used 9,500 of those yards. They actually worked 2,100 hours of labor, $9.15 an hour. That was the actual rate. So they actually spent $19,215 on labor, and they actually spent $16,650 on overhead. And they say one more thing. 500 units of product were actually produced. You might want to circle that 500. That's important. In a variance problem, you have to know how many units were actually produced. Remember, we're going to judge management on what they actually produced. We don't judge management on what they should have produced. No, that's a different question. We judge management. How well did they do on the units they actually produced? So that's a critical number. We want to know how many units they actually produced, and that's 500. They say we have to come up here with 6 variances, and let me just say, these are the big 6. These are the 6 the exam has asked for the most. Now, as we go through these 6, I'm going to mention some other variances they might ask for, but these are the big 6. Let's start with material price variance. Now, before we get into how to solve this, let me just quickly say that there are basically 2 ways you can approach variances. You can memorize a format, or you can take a shortcut. And what I want for you is that you can do both. I know that seems unreasonable, but that's really what you should be able to do. You should know the formats, and I think sometimes the shortcuts help you also. I know you want to say, Bob, just show me the shortcut, but depending on how they write the problem, sometimes the shortcuts can be difficult. In other words, sometimes the shortcuts are great, they save you time, but sometimes you need the format. The formats will never let you down. I don't care how they set up a problem. It's good to come back to the format sometimes. So it's really good to know both if you can. So let's start with the format for material price variance, the first one they asked. If I want to do material price variance, I'm going to take the actual yards purchased times the actual price. It's the actual yards purchased times the actual price, and compare that with the actual yards purchased times the standard price. Just remember, it's actual times actual compared with actual times standards. Let's fill it in. I'm going to take the actual yards purchased, 18,000, times the actual price per yard, which is $1.38. They actually did spend $24,840 on material. Now I'm going to compare that with the actual yards purchased, 18,000, times the standard price they should have paid per yard, which is $1.35. What they should have spent was $24,300. There's a $540 material price variance. Now, I know you're aware of this, but we have to say it right away. You never come up with a variance where you don't immediately stop and think, is it favorable or unfavorable? I mean, all that matters, really, is whether it's favorable or unfavorable. We're trying to judge management. So just to come up with a number, it doesn't really, in a vacuum, doesn't mean anything. The question is it favorable or unfavorable? This is unfavorable. It's definitely unfavorable. Now, the reason is because they're over budget. You could look at it that way. They spent too much. But I'll just give you another quick way to get favorable or unfavorable. Just remember, in every variance that we do, if the top number is higher than the bottom number, it's automatically unfavorable. I'm trying to take the thinking out of it, because a lot of students can get the number, they just aren't sure whether it's favorable or unfavorable. So just remember, in every one we do, not just this one, in every variance we do together, if the top number is higher than the bottom number, it's automatically unfavorable. If you ever see a bottom number higher than a top number, it's favorable every time. Never mind why. It'll just slow you down. That way, that's why it's automatic. You can label them immediately. Now, another point. That variance is unfavorable. That's true. So it's a debit. I want you to remember that unfavorable variances are always debits. Favorable variances are always credits. Sometimes that messes a student up. So that's a $540 debit, because unfavorable variances are always debits. Favorable variances are always credits. So that would be a $540 debit, unfavorable material price variance. Now that's the format. I'm sure you already see it. What's the shortcut? Well, the other way to get it is, didn't they pay 3 cents more than standard? Weren't they 3 cents over budget for every yard they purchased? If you take 3 cents times 18,000 yards, that'll also give you 540. And sometimes it'll help if you know that shortcut, but that's the other way to get it. They're 3 cents over budget for every yard they purchased. Multiply 3 cents times 18,000 yards, and that'll give it to you also. Let's do number 2, the material usage variance. To get the material usage variance, we're going to take the actual yards used, not purchased, used times standard price, and we're going to compare that with the standard yards they should have used times standard price. It's actual times standard compared with standard times standard. Let's work it out. We're going to take the actual yards they used, 9,500. Notice, actual yards used, not purchased, used, 9,500, times the standard price per yard, $1.35. That comes out to $12,825. Now we're going to compare that with the standard yards they should have used. How do we get that? Well, they made 500 units. Let's get back to that again. That's a critical number. they made 500 units. According to budget, aren't they supposed to put 20 standard yards into every unit they produce? If you take 500 times 20, they should have used 10,000 yards times $1.35 standard price. That comes up to $13.5. There's a $675 material usage variance. And, of course, that's favorable because the bottom number is higher than the top number. It's a credit. It's favorable. That's material usage variance. And, of course, the shortcut, what's the shortcut? Didn't we save 500 yards? Look, our standards, our budgets are reasonable. Our budget says you make 500 units, it ought to take 10,000 yards of material. Well, we made 500 units, and for some reason we only used 9,500 yards. Somewhere along the line, we saved 500 yards. And if you multiply 500 yards saved times $1.35 standard price, that'll also give you $675 favorable material usage variance, or it's a credit. Now, they could ask you for this variance. As I mentioned, I'm going to bring up a couple they could ask for. What if they wanted the total material variance? Well, I hate you to miss that. Just combine the two you have. I have an unfavorable material price. That's a $540 debit. I have a favorable material usage, a $675 credit. Just combine the two. Total material variance is a $135 credit, or favorable. Hate you to miss that because you just combine the two you already have. The hard work's already done. Now, I'll tell you one thing you're going to like. If you don't mind material price and material usage, I don't think you're going to mind at all labor rate and labor efficiency because it's the same formats. So notice, if you just know these two formats, you get 4 of the big 6 variances right away. Here's what I'm saying. We can take the same format we use for material price, actual times actual compared with actual times standard, but now I can use it for labor price or labor rate variance. If I'm going to use the same format for labor, what do the letters stand for now? I'm going to take the actual hours worked, 2,100, times the actual rate, $9.15 per hour. They actually spent $19,215 on labor. I'm going to compare that with the actual hours worked, 2,100, times the standard rate, which is $9 an hour. That comes out to $18,900. There's a $315 debit, unfavorable labor rate variance. Why is it a debit? Because the top number is higher than the bottom number. Just remember, top number is higher than the bottom number, it's a debit. It's unfavorable every time. Bottom number higher than the top number, it's a credit. It's favorable every time. Never mind why. That way it's quick, it's automatic. And, of course, the shortcut on this one is to do what? Didn't they spend 15 cents over budget? Didn't they spend 15 cents over standard, over budget for every hour they work? And if you multiply 15 cents times 2,100 hours, that'll also give you $315. That's the other way to do that. Now let's get the labor usage or labor efficiency variance. It's the same format as material usage. We're going to take the actual hours worked, 2,100, times the standard rate, 9. That comes out to $18,900, as you already know. We're going to compare that with the standard hours they should have worked times standard rate. Now, what's the standard hours they should have worked? That's the number you got to come up with. Well, how many units did they produce? Notice I keep coming back to that. We judge management on what they actually produced, not what they should have produced. They actually produced 500 units. Budget says they're supposed to put 4 standard hours into every unit. So they should have worked 2,000 standard hours. Times 9, that comes out to 18,000. There's a $900 debit, unfavorable labor efficiency variance. Now, you know the shortcut here. What's the shortcut? Didn't they waste 100 hours? Your standards say, look, if you make 500 units, it ought to take 2,000 hours. Well, our workers made 500 units, and it took 2,100 hours. Somewhere along the line, we wasted 100 hours. And if you take 100 hours wasted times the standard rate, 9, that'll also give you 900. Unfavorable labor efficiency variance. It's a debit. Now, here's one they could ask for. What if they wanted the total labor variance? Well, I hate you to miss that. You've already done the hard work. If they want the total labor variance, just combine the two you have. You have a $315 unfavorable labor rate variance. That's a debit. You've got a $900 unfavorable labor efficiency variance. That's a debit. Your total labor variance would be $1,215 debit, unfavorable. So as I say, what you've really just learned is if you get those two formats down, you can handle 4 of the big variances they ask for all the time. Material price, material usage, labor rate, labor efficiency. It's really not too bad. In our next class, we will continue with Armando, and we will go through the overhead variances. I look to see you in the next class. Welcome back to our discussion on cost accounting, and in this class, we're going to finish our discussion on Armando Corporation, the big problem that we started in our last class on variances. And I know you remember that in our last class, we had discussed the raw material variances and the direct labor variances, and I want you to keep in mind that direct material and direct labor represent purely variable costs, simply meaning the amount of cost incurred is directly related to the number of units produced or the number of hours worked. After all, the more units I produce, the more direct material costs I incur. The less units I produce, the less direct material costs I incur. The more units I produce, the more direct labor costs I incur. The less units I produce, the less direct labor costs I incur. Direct material and direct labor are purely variable manufacturing costs. And I mention that because when you begin to discuss factory overhead variances, it's important to keep in mind that factory overhead is both variable and fixed. And I want to make sure you see why. Keep in mind that factory overhead represents all the indirect manufacturing costs. And the fact is, some of those indirect manufacturing costs are considered variable. Some of the indirect manufacturing costs are considered fixed. That's why factory overhead is really both. I mean, think of the things we put under factory overhead. I put depreciation on the factory under factory overhead. That's a fixed cost. But I also put supplies for the factory under factory overhead. That's a variable cost. And that's the basic point. Factory overhead has both fixed elements like depreciation, property taxes, insurance, but factory overhead also has variable elements, supplies, utilities. Factory overhead is both variable and fixed. And in order to do overhead variances, the first thing you have to be able to do is a flexible budget for factory overhead at different levels of activity. If you go back to Armando Corporation, you'll notice that the fixed overhead budget is $6,000 a month. They also say that the variable factory overhead rate per direct labor hour is $5. So with that information in mind, let's do a couple of flexible budgets for factory overhead. In order to do the overhead variances, you have to be able to do two flexible budgets. First, we're going to do a flexible budget for factory overhead based on the standard hours they should have worked. So let's go over the standard hours. In this problem, how many units were actually produced? 500. And if you go back to the standards, how many standard hours should they put into each unit? 4. So the standard hours they should have worked for what they accomplished is 2,000. They made 500 units. They're supposed to put 4 standard hours into every unit. So they should have worked 2,000 standard hours for what they accomplished. Together, let's do a flexible budget for factory overhead based on those 2,000 standard hours. At 2,000 standard hours, what's the fixed factory overhead budget? 6,000. Remember, fixed is fixed. It's set in amount. This budget is not going to rise and fall with activity. So the fixed, that stays set in amount, 6,000. What you always have to be careful about is the variable budget. They gave us that other information that the variable factory overhead rate per direct labor hour is $5. In other words, they're saying every time this factory works another hour, they incur another $5 of supplies, supervisor salaries, utilities. Remember, some overhead costs are variable. So that's what they're getting at. Every time this factory works an hour, they incur another $5 of purely variable factory overhead. So I'm going to take those 2,000 standard hours times $5, theoretically at that level. The variable overhead budget would be $10,000. The fixed overhead budget is $6,000. A fixed factory overhead budget based on those 2,000 standard hours would be $16,000. Now let's do another budget. Let's do a flexible budget for factory overhead based on the actual hours they worked. Go back to the actual information. How many actual hours did they work? 2,100. So let's do a flexible budget for factory overhead based on the 2,100 hours they actually did work. Well, first of all, what's the fixed budget? 6,000. Fixed is fixed. It's set in amount. Again, that budget is not going to rise and fall with activity, no matter how many hours they work, within a relevant range, within a certain range of activity, within a certain range of activity, maybe from 0 hours of labor, 0 hours of production, up to 10,000 hours. Some costs stay fixed within that relevant range. So fixed is fixed. It's set in amount 6,000. What you always have to be careful about is that variable budget. They said every time they work an hour, they incur another $5 of variable factory overhead. So I'm going to take the 2,100 hours they actually did work times $5. Theoretically, at that level, the variable budget would be $10,500. The fixed budget stays $6,000. So a budget based on the actual hours they worked would be $16,500. You cannot do overhead variances if you cannot do those budgets. Those are the two budgets you have to be able to do. A budget based on the standard hours they should have worked, and a budget based on the actual hours they did work. Once you have those budgets, now you can do the overhead variances. We're going to start with the two-way analysis of analyzing overhead. That's what they ask for here. If you go back to the problem, notice they ask for the controllable factory overhead variance and the volume or capacity overhead variance. They want two overhead variances. This is what the exam refers to as the two-way analysis, the two-variance method of analyzing factory overhead. Here's how you do the two-way analysis. At the top, put in their actual overhead costs. If you go down to the actual information in the problem, notice they actually did spend $16,650 on actual overhead costs. That's what they actually spent on fixed items, plus what they actually spent on variable items, $16,650. Would the exam have to give you that? Yes. There's no way you could come up with that. Actual overhead cost, that'll be given. All right, then you leave a good amount of space, and at the bottom, you're going to put in the overhead applied to work in process. Now, if you go back to the standards, what's their predetermined rate for overhead? Isn't it $30 per unit, if you look at the standards? So I'm going to take that $30 times the 500 units they produced. They must have applied $15,000 of overhead to work in process. Now, the difference between the actual overhead costs, $16,650 at the top, and the overhead applied to work in process, $15,000, that $1,650 difference, that's called total overhead variance, or the net overhead variance. And I want to show you that because the exam has asked for that a lot. They didn't ask for it here, but you have to be able to get that number. Again, that's called the total overhead variance or the net overhead variance, $1,650, and we know it's unfavorable. Why? Because the top number is higher than the bottom number. Remember, that never lets you down. If the top number is higher than the bottom number, it's a debit. It's unfavorable every single time. Now, before I leave that applied number, think about how I got that applied. I took their predetermined rate, $30 a unit, times 500 units produced, and I said, well, they applied 15,000. Well, I have to warn you, sometimes in the exam, rather than give you a predetermined rate per unit, they give you a predetermined rate per hour. So let me show you another way to get that number, just in case it comes up. If you go back to the standards, we know that they are applying $30 of overhead to every unit. Now, if you look at the standards, how many standard hours do they spend on every unit? 4. If you take that $30, divide by 4, the predetermined rate per hour is $7.50. So my point is, you could be in the exam, and rather than give you the amount they're applying per unit, they could just simply say, the predetermined rate for overhead is $7.50 an hour. Notice, in order to get applied, I would take that $7.50 times the 2,000 standard hours they should have worked. That'll give me the 15,000 also. Remember, don't use actual hours there. If I want to work out applied, remember, everything goes to work in process at standard. So, again, if I did not have the $30 a unit here, if all they said was overhead is applied at $7.50 per hour, I would take that $7.50 an hour times the 2,000 standard hours they should have worked. And that would also give me 15,000. But you have to be able to get that applied number. All right, now back to the basic format. we put their actual overhead costs at the top. At the bottom, we put the overhead applied to work in process, the difference between what they spent and what they applied. That's your total overhead variance. That's your net overhead variance. They could ask for that. And if all they want is the two-way analysis, you just put something in the middle. In the middle, you put the flexible budget for factory overhead based on standard hours. We already did that. A flexible budget for factory overhead based on standard hours, remember, came out to $16,000. Just put that in the middle. And now you have the two-way analysis. The difference between what they actually spent, $16,650, and the budget based on standard hours, $16,000, that's $650. That's called overhead controllable variance, and it's unfavorable because the top number is higher than the next number down. Never lets you down. That's a debit. It's unfavorable. And then finally, the difference between the budget based on standard hours, $16,000, and what they applied, $15,000, that $1,000, that's called overhead volume variance or overhead capacity variance. The exams use both terms. It's called overhead volume variance or overhead capacity variance, and that's unfavorable because 16,000 is higher than 15. The top number is higher than the next number down. You know it's a debit. You know it's unfavorable. So that's what they mean by the two-way analysis. It's overhead controllable, overhead volume. That's the two-way analysis, the two-variance method. Now, a couple of things about these two variances. The controllable variance. The controllable variance, that's 650, that is made up of both fixed and variable costs, fixed and variable. And it's really a function of two things. The controllable is really a function of spending and efficiency. And theoretically, spending and efficiency are within the control of management. So in the two-way analysis, we just say they should have been able to control it. But that's what it's about. It's made up of spending and efficiency. And theoretically, spending and efficiency is controllable by management. So what we're just saying in the two-way analysis is 650 should have been controlled. Now, the $1,000 volume variance. The reason why you get a volume variance is you've either worked over normal. You've worked over normal, so you've over-applied your fixed overhead, or you've worked under normal and you've under-applied your fixed overhead. That's why you have a volume variance. Volume variance represents purely fixed cost. There's no variable in there. Purely fixed cost. You get a volume variance because you work over normal, and therefore you over-apply your fixed overhead, or, as you did here, you work under normal, so you under-applied your fixed overhead. If you go back to this problem, what's normal activity? 600 units. How many did they produce? 500. They produced under normal. And if you produced under normal, you must have under-applied your fixed factory overhead. Remember, the unders go together. If you produce under normal, well, then you under-apply your fixed factory overhead. If you go back to the standards, we know their predetermined rate for overhead is $30 a unit. And didn't they say that the ratio of variable cost to fixed is 2 to 1? Well, if the ratio of variable cost to fixed is 2 to 1, we know that $30 breaks down to $20 variable, $10 fixed. So if that's true, doesn't it mean they're applying $10 of fixed overhead to every unit they produce? How many units did they produce? 500. If you take $10 times 500, didn't they apply 5,000 of fixed overhead to production, to work in process? But the problem is the fixed budget is 6,000 at any level. Fixed is fixed. So what they did is under-apply their fixed factory overhead. That's why you have a volume variance. Volume variance represents purely fixed costs. You either produced over normal, so you over-apply your fixed overhead, or like in this problem, you produced under normal, so you under-apply your fixed factory overhead. Now notice, if you understand the two-way analysis, you can handle some questions in the exam. If you look at question number 1 for this class, they say, under the two-way analysis of analyzing overhead, what is used to calculate the controllable variance? To calculate controllable, do we need a budget based on actual hours? No. No, we don't need that. You want to know in that column. Controllable is defined as actual overhead costs compared with budget based on standard hours. I don't need the budget based on actual hours. And, of course, the second column, budget based on standard hours, I do need that. And it's no, yes, answer D. Let's look at question number 2. Under the two-variance method of analyzing overhead, the difference between a budget based on standard hours and what you applied is called what? That's the volume variance or the capacity variance. Answer C. So make sure you know that basic format for the two-way analysis. Now let's take Armando. Let's do the same problem, but now let's do the three-way analysis of analyzing overhead because the exam is asked for that. So let's go over the three-way analysis. If they want the three-way analysis of analyzing overhead, you start the same way. At the top of the page, put their actual overhead costs, $16,650. They have to give you that. Leave a good amount of space at the bottom. Put in the overhead applied to work in process. We know they're applying $30 of overhead to every unit. They made 500 units. So they applied $15,000 of overhead to work in process. And once again, the difference between what they actually spent, $16,650, and what they applied, $15,000, that $1,650, that's called the total overhead variance or the net overhead variance. We know it's unfavorable. I always start by getting that one. Now I'm going to put in a budget based on standard hours. That's $16,000. And as always, the difference between a budget based on standard hours, $16,000, and what was applied, $15,000, that $1,000, that's called overhead volume variance or overhead capacity variance. It's $1,000, and we know it's unfavorable. Notice, to this point, it's exactly the same format as the two-way analysis. But in the three-way analysis, I add one more thing. Now I add a budget based on actual hours. And remember, we already calculated that. That came out to $16,500. When I put in the budget based on actual hours, based on the actual 2,100 hours they did work, $16,500, now I have two more variances. See, what the three-way does is take the controllable and divide it up into its spending and efficiency problem. So I put in the budget based on actual hours. Now I do a further analysis. The difference between what they actually spent on overhead, $16,650, and a budget based on actual hours, $16,500, that $150, that's called overhead spending variance. And of course, it has to be unfavorable because $16,650 is higher than $16,500. Top number's higher than the next number down. You know it's a debit. You know it's unfavorable. And then finally, the difference between the budget based on actual hours, $16,500, and a budget based on standard hours, $16,000, that $500 is called overhead efficiency variance. And of course, that's unfavorable because $16,500 is higher than $16,000. And did you notice this? If I take overhead spending, $150, overhead efficiency, $500, overhead volume, $1,000, it gets me back to the total overhead variance of $1,650. Unfavorable. You know, all the individual variances have to get back to the net, have to get back to the total overhead variance. Sometimes that'll help you. So anytime the exam mentions the three-way analysis, that's what they're looking for. They're looking for overhead spending, overhead efficiency, overhead volume. That's the three-way analysis. Overhead spending, overhead efficiency, overhead volume variance. Now, there is a four-way analysis. Now, if they want the four-way analysis, which the exam is asked for, use the same basic format. At the top of the page, put their actual overhead costs, $16,650. They have to give that to you. Leave a good amount of space at the bottom. Put in the overhead applied to work in process. We know that's $15,000. And as always, the difference between what they spent, $16,650, and what they applied, $15,000, that $1,650, that's called the total overhead variance or the net overhead variance. Unfavorable. We got that. Then you put in a budget based on standard hours. That's $16,000. So the volume variance stays the same. Difference between the budget based on standard hours, $16,000, and what was applied, $15,000. Overhead volume variance, $1,000. Unfavorable. That hasn't changed. Then I put in a budget based on actual hours, $16,500. We've got that. Notice the efficiency variance stays the same. That's the difference between the budget based on actual hours, $16,500, and a budget based on standard hours, $16,000. So notice when you go from the three-way analysis to the four-way analysis, volume variance stays the same, efficiency variance stays the same. What's different in the four-way analysis is that in the four-way analysis, they take the spending variance and divide it into two. You have to come up with a fixed spending variance and a variable spending variance. And the only way to do the four-way analysis is they have to break down that $16,650. What they actually spent on overhead costs, that $16,650, they have to tell you how much they spent on fixed items, how much they spent on variable. That was not given in the Armando problem. But let me just make it up. Let's say the $16,650 broke out this way. Let's say they spent $6,200 on fixed items, $10,450 on variable items. And again, the exam would have to give you that. So let's say that's how the $16,650 broke down. They spent $6,200 on fixed items, $10,450 on variable items. Well, now you can do it. They spent $6,200 on fixed items, depreciation and so forth, on the factory. What was their fixed budget at any level? $6,000. Don't forget their fixed budget was $6,000 at any level. So they have a $200 unfavorable. Top number is higher than the bottom number. They spent too much. They have a $200 unfavorable fixed spending variance. Now, how about the variable spending variance? Well, they actually spent $10,450 on variable items. What should they have spent? Well, they worked 2,100 hours. Every time they work an hour, they're supposed to incur $5 of variable factory overhead. Take $5 times 2,100 hours. They should have spent $10,500. They spent $10,450. They have a $50 favorable variable spending variance. So there's your four-way analysis. You have a $200 unfavorable fixed spending variance, a $50 favorable variable spending variance, $500 unfavorable efficiency variance, $1,000 unfavorable volume variance, and notice all the variances combined get back to the net, the $1,650 unfavorable. You can actually give 5 overhead variances: fixed spending, variable spending, efficiency, volume, and net. You've got 5 overhead variances. Now, before you do the next class, there are 5 multiple choice that I want you to do for the next class. I want you to get the answers for those questions before you do the next class. That is your assignment. And I'm sure you've noticed that I did not include solutions in the viewer's guide to any of the questions that I've had you do with me. And that's because I want to solve questions with you, and when I assign questions, I want you to get the answer. So deliberately, you don't have answers in the viewer's guide for the questions that I give you. So you have 5 questions that I want you to get done before you watch the next class, and I'll look to see you then. Welcome back to our discussion on cost accounting, and for this class, I gave you a group of variance questions that I wanted you to get done before watching this class. Now let's go through them. In question number 1, they're asking you for the material price variance, and what I'm hoping is eventually you get these formats down. We know that the format for material price is the same format you use for labor rate variance. It's actual times actual compared with actual times standard. So you start to fill it in. We're going to take the actual units they purchased, 4,200, times the actual price per unit. We're not sure what that is, but we know they did spend $10,080 on material. If you take the $10,080 they spent, divide by the 4,200 units they purchased, the actual price per unit must have been, if you divide it out, $2.40. Now we're going to compare that with the actual units they purchased, 4,200, times the standard price per unit, which is $2.50. What they should have spent was $10,500 on material. What you have here is a $420 material price variance, and you know it's favorable because the bottom number is higher than the top number. It's a credit, it's favorable, and the answer is B. And of course, the other way to get this variance, the shortcut, if you will, is looking at the difference in price. The standard price per unit is $2.50. The actual price was $2.40. Turns out they actually saved 10 cents on every unit they purchased. You multiply 10 cents times the 4,200 units they purchased, that would also give you the $420. As I said in a prior class, what I want for you is you know the format and the shortcut. That way you can adjust to how the exam tests it. In number 2, they ask for the unfavorable, so they're telling you it's unfavorable, the unfavorable labor efficiency variance. And in terms of formats, remember the same format you use for material usage, you're going to use for labor usage or labor efficiency variance. It's actual time standard compared with standard time standard. So let's fill it in. We're going to take the actual hours they worked, 4,100, times the standard rate per hour, which is $12 per hour. Multiply that out, that comes out to $49,200. Now you're going to compare that with the standard hours they should have worked times standard hours. The number you had to come up with, the number you had to think about, is the standard hours they should have worked. How do you get that? Well, how many units did they produce? 1,000. How many standard hours should go into each unit? 4. So the standard hours they should have worked for what they accomplished, 4,000 times 12, that comes out to 48,000. You have a $1,200 unfavorable labor efficiency variance, and you know it's unfavorable. Top number is higher than the bottom number. It's a debit. It's unfavorable, and the answer is B. By the way, notice that the actual rate per hour, $12.20, that's not used here, not in labor efficiency variance. I just need the standard rate per hour. Actual rate per hour, I would use that if I was figuring out the rate variance, but not the efficiency variance. I didn't need that $12.20 at all. Now, in the next two questions, we have a set. And in both questions, we are using the three-way analysis of analyzing factory overhead. Now, remember, in order to do a variance analysis on factory overhead, you have to be able to do two flexible budgets for factory overhead. Why don't we start by doing our flexible budgets? First, you have to be able to do a flexible budget for factory overhead based on the standard hours they should have worked. And they gave you that. That's 7,600. At 7,600 standard hours, what's their fixed budget for overhead? 14,000. Fixed is fixed. It's set in amount. That's a budget that does not rise and fall. Does not rise and fall with activity. It's going to stay fixed, set in amount, 14,000. But it's the variable budget I have to work with. If the standard hours they should have worked total 7,600, and every time they work an hour, they incur another $2.50 of variable factory overhead. They gave you that. The variable factory overhead rate per hour, $2.50 times 7,600 standard hours. The variable budget should have been 19,000. The fixed budget, 14,000. A budget based on standard hours for overhead comes out to 33,000. 33,000. Now let's come out with our flexible budget for factory overhead based on the actual hours they worked, and that was 7,000. So let's work it out. We know the fixed budget at that level would still be 14,000. Fixed is fixed, set in amount. That budget does not rise and fall with activity. But if the standard hours, if the actual hours they work total 7,000, and every time they work an hour, they incur $2.50 of purely variable factory overhead, their variable budget at that rate, at that level, should have been 17,500. The fixed budget stays 14,000. A budget based on the actual hours they work, 7,000, comes out to 31,500. Now, with those two budgets, now we can do our analysis. The difference between what they actually spent on factory overhead, they gave you that, 30,000, and a budget based on actual hours, that 31,500, that $1,500 difference, that's called overhead spending variance. And it's got to be favorable because the bottom number, the budget based on actual hours, is higher than the next number up, what they actually spent. So we know that that's 1,500 favorable, so the answer to number 3 is A. Now in number 4, they want the overhead efficiency variance. Well, you have to put in the other budget. The difference between a flexible budget based on actual hours, that 31,500, and a flexible budget based on the standard hours they should have worked, 33,000, that's your overhead efficiency variance. And that's also 1,500, and it's also favorable because the bottom number, 33,000, is higher than the next number up, 31,500, so the answer is also A. If you can do those two budgets, if you can do a budget for overhead based on standard hours they should have worked and a budget for overhead based on the actual hours they did work, you can do any variance problem. Up, as in a prior class we learned, up to the 4-way analysis, you'd have no problem at all with overhead variances. And then even a question like number 5, a theoretical question, saying under the 3-way analysis, what is used to calculate a spending variance. Do I need actual overhead costs to get a spending variance? I do. Spending variance is defined as the difference between actual overhead costs and a budget based on actual hours. So yes, I need actual overhead costs to work out a spending variance. I also need a budget based on actual hours. I need yes under both columns, and the answer is D. I hope you did well on that set. Keep up with your work. Don't fall behind. That's always what I worry about. I'm sure it's what you worry about. And I will look to see you in the next class.